OKI. OKI Voice Synthesis LSI Data Book. N, Rio N. Representative 408-988-6300. 3350 Scott SIVD SLDG 44. Santa Clara, California 95054. First edition. Issue date, Aug 1987. OKI. Voice Synthesis. LSI Data Book. Introduction. Datasheet. Appendix. Copyright 1987, OKI Electric Industry Company, Ltd. OKI makes no warranty for the use of its products and as sums no responsibility for any errors which may appear in this document, nor does it make a commitment to update the information contained herein. OKI retains the right to make changes to these specifications at any time, without notice. Contents. Introduction. Introduction. 3. Product lineup. 8. Comparative functions block diagram. 9. Packaging. 10. Useful information. 16. Datasheet. MSM 5205. 21. MSM 5218. 27. MSM 6295. 36. MSM 5248. 47. MSM 6243. 60. MSM 6212. 79. MSM 6308. 91. MSM 6309. 100. MSM 6258/MSM 6258V. 110. MSC 1161. 148. Appendix. Application Notes. 163. Voice Synthesis LSI Library. 184. A&A. 185. Introduction, Introduction. The voice synthesis LSI. In regular tape recorders where sound is stored as analog signals on magnetic tape, the subsequent amplification of those signals to drive a speaker is referred to as sound reproduction. It cannot be called sound synthesis if the amount of information stored, which is 100% in the above tape recorder, is reduced. The amount of storage medium, memory, can also be reduced for greater economy. Where the amount of information is reduced, compressed, on the basis of a certain principle, the restoration of the original sound is called synthesis. Voice synthesis methods. Voice synthesis methods can be divided into three major types: waveform, encoding, parametric synthesis, and synthesis by rule. Each type is briefly outlined below. 1. Waveform coding methods. This type includes differential PCM, DPCM, adaptive delta modulation, ADM, and adaptive differential PCM, ADPM. The original sound wave amplitude is sampled at fixed intervals, digitized, and the volume of data then reduced on the basis of the principles mentioned above. 2. Parametric synthesis methods. Characteristic information included in voice waveforms is extracted as parameters for synthesizing purposes. The Parker method is a typical example. In this method, where models of the human vocalization mechanism are used, voiced and voiceless consonant sounds are discriminated, and voiced sound pitch and amplitude data is extracted together with filter characteristic of vocal tract. Voice synthesis is then achieved by passing this data to hardware consisting of digital filter circuits, etc. 3. Synthesis by rule method. This synthesis method is an ideal method where groups of phonemes expressed by small quantities of data are skillfully linked together to reproduce any desired words. However, since further elucidation of linguistic laws taking intonation, accents, and length sounds into consideration is required to achieve a highly natural voice, this method must still be considered to be in the research stage. Basic ADP method. OKI voice synthesis LSLS are based on adaptive differential PCM, ADP, which is an improved form of the DPCM method. The PCM and ADP methods are described below. 3. Comma dot, underscore dot comma dash. 1. Pulse code modulation, PCM. Voice waveforms and other analog data can be PCM encoded into digital data by sampling and quantization in SNH, sample and hold, NAD. Converter stages. The SYN ratio in this case is determined by the following expression: N, 1, x 6 dB, where N is the number of output bits from the AD converter, assuming that the maximum waveform amplitude is equivalent to full scale in the converter. For example, if the sampling frequency is 8 kHz and the number of AD converter output bits is 12, the required amount of data, number of bits, per second is 8 kHz x 12 bits equals 96 k bits lowsec. This is called the bit rate. The SYN ratio in this case is obtained as 12:1, x 6 equals 66 dB. 2. Adaptive differential PCM. The ADP method was devised as a means of reducing the bit rate without sacrificing the SYN ratio too much. In this method, the amount of data is reduced by quantizing and encoding the differential, dN, between adjacent signal samples. A feature of this method is the ability to make adaptive changes to the quantization width C.N when quantizing the differential dN. In the DPCM method, the quantization width is fixed. In other words, Cn is enlarged when the differential dN is large, and reduced when dN is small. 3. ADP analysis. 4. If the input at the nth sampling point is xn, and the waveform reproduction value at the n1, th sampling point is xn1, the differential dN between the two is 1 backslash dN equals xn, xn1, differential calculation. This is then encoded by the quantization with C.N at the present point of time. The nth point of time. Ln equals dnlc.n, encoding, Ln equals ADP data. And if this is then quantized and the waveform subsequently reproduced, Qn equals, Ln plus 1/2, C.N, quantization. 1 backslash xn equals xn1 plus qn, reproduction. The quantization width for the next, n plus 1, th item of data is then changed from C.n to C.n plus 1. 0.6.n plus 1 equals 0.6.nm, ln, quantization width change. Where m, ln, is the ln function format. The quantization width is thus determined according to the previously accumulated data. N plus 1, th sample. N1, th sample nth sample, N plus 2, th sample. Input waveform. Fig 1 ADP method computation process. 4. ADP data. The ADP data ln is expressed as m bits of data including the polarity bit. For example, a 4-bit expression is given as ln equals b3 b2, b1, bol. Where b3, polarity bit, indicates the polarity of the, begin ind, differential dn. b2, MSB indicates the presence of a 4.6.n digit in the changed portion. B1, 2SB indicates the presence of a 2.6.n digit in the changed portion. And BO, LSB, indicates the presence of a 0.6.n digit in the changed portion. 5. ADM reproduction. ADM reproduction can be expressed as part of the ADM analysis. The reproduction for the nth ADM input data ln is given as 5. Qn equals ln plus 1/2, 6n, quantization, equals, minus 1 xb3, 46n b2 plus 26n b1 plus 6n bo plus 126n. AA. Xn equals xn1 plus qn, reproduction. And 6n plus 1 is calculated for the n plus 1, th item of ADM data. 6n plus 1 equals 6nm, ln. In other words, in addition to serving as data used for calculating new PCM values for previously set quantization widths, the ADM code also serves as the data for calculating the quantization width to be set next. Furthermore, if xn is set to 12 bits, and ln is set to 4 bits, the quantity of ADM encoded data is compressed by April 12. Note, the 1/2 element in quantization qn equals ln plus 1/2, 6n. Serves as a means of linear equalization for changed polarity. OKI ADM types. Although the ADM method is the basic method adopted by OKI, a few modifications have been made, and 2 analysis/synthesis methods are now in use. These are outlined briefly below. 1. Straight ADM. This is the basic unmodified ADM method where the quality of sound is better than the 2 methods described below. This method is also suitable for sound effects. 2. Compressed ADM. The compressed ADM method is the straight ADM method subject to on-voice elimination processing node 1 and waveform repetition processing node 2. The bit rate, therefore, can be reduced to 1/3 of the straight ADM bit rate. Furthermore, the degree of data compression can be changed for each word. Note 1. On-voice elimination processing. Extensive reduction of on-voice interval data by replacing on-voice intervals, which exceed a certain length, with on-voice data. Note 2. Waveform repetition processing. 6. Data volume reduced by repeating a single item of waveform data in voiced waveforms such as vowels which are repeated periodically. Features of OKI voice synthesis LSLS. The major features of OKI voice synthesis LSLS are summarized below. 1. Quality and object of synthesis. I. Good quality sound with high degree of naturalness. 2. Synthesis of sound effects, musical instruments, and animal sounds also possible. 2. Hardware. I. Easy to handle built-in ROM 1 chip devices prepared for application in simple sets. 2. Range of voice synthesis LSLS with varying built-in ROM sizes to meet diversified market needs. 3. Low power requirements due to CMOs with low fundamental oscillating frequency, ideal also for battery-operated applications. 3. Software. I. Simple and precise analysis for broader range of user-selected sounds. 2. Comprehensive range of analytical tools to enable synthesis to be executed by user. Because of the fine quality of sound achieved in a wide range of applications, OKI voice synthesis LSLS are used by a great many users in many different applications. 7. Product lineup. Functions 5205, 5218, 6295. And specifications. ADM. Straight 000. Method. Compressed. Add 3-bit 00. Bit length. 4-bit 000. Oscillation. 384-738K 384-768 M1, 5M frequency, Hertz. Maximum vocalization determined determined F. Time by external 90 seconds. Connections. Maximum number determined. Of vocalized words by external F27 connections. Analytical functions, 0. Built-in ROM, KBLTS. BUID 1 and converter voltage. EEP type. Button AD converter. External memory interface, 0. Input. SW input. Interface. Microcomputer. Control 000. DA. A class 000. Output. B class. MSCL 161 connection. Power supply voltage, V, 555. Power consumption 4 mAh 5 mAh. In standby mode. Package shape 18 dip 24 dip 44 flat. 32 ATAT. Remarks, external. ROM. Note, 1 applicable when FSAMPLE equals 5.5 kHz. 2 applicable when TSAMPLE equals 8.2 kHz compressed add. 3 applicable when power supply voltage IS3V. 8. 5248. 0. 10-50K. F. 3 seconds. 7. 48. Voltage. Type. 0. U. 3. 05 RNA. 10/05/.A. Is dip. 24 flat. Chip. ROM. Code. DEILS. 6258. 6243 6212 stand MPU 6308 6309. Alone inter I. 00000. 00. 00. 02000. 30T 32K 31 32K 428 M4 to 6 M4 to 6M. Determined eternal TLT NED. 20, 40 SEC external. Connections. Deter. F2. 12.7 4. By X. Ternal. Connect. Shin S. 000. 192 288. Current voltage. Type EEP type, Y. 000. 000. 000 to 00. 00000. 00000. 00. 3 or 5 5. Note 3 null 3 ma 10 RNA IOMA. 05 RNA F opal. 051A. 40 dip 40 44 flat. 44 60 flat 44, EO flat 60 flat 44 flat 60 flat. Chip. ROM. Code. Device. Co. MSM 5248. MSM 6243. MSM 6212. MSM 6295. MSM 5205. N. / Filter C. AD cent analysis cent or cent I synthesis. Mic. CJ. 8, 12-bit. E1. JOM. Cent. 10-bit. DA. Converter. H. CJ. Converter RAM. R. 1. Underscore F. 1 LJ. MSM 5218. MSM 6258. MSM 6308. MSM 6309. Fig 2. 0. 0. S. Laughing face. I. SP Acre IAJ. Denver. C. Z. 0. I. 0. Z. SP. N. Amplifier IT, OJ. R. 0. 0. C. C. Laughing face, I. Packaging. Plastic dip, Rs, plastic flat, GS. Chip. Device 18 pin 24 pin 40 pin 24 pin 32 pin 44 pin 60 pin. MSM 52050. MSM 521800. MSM 62950. MSM 5248000. MSM 6243000. MSM 6212000. MSM 6258V00. MSM 62580. MSM 63080. MSM 63090. MSC 1161000. 10. OKI's package types. Below are OKI's IC package types and features. Through-hole and surface mount IC package. Types are described as a function of the board. Mounting method. Package types. Type package types. Package. Pin count. Symbol. 8, 14, 16, 18, 22, 24. Standard Rs. 28, 40, 42, 48. Dip skinny. Rs 20, 22. Colon. Shrink SS 42, 64. 1I. SIP. Rs 8. 5. I. Dash. LE. Q.S. I asterisk 1. PGA, 88,120,132.176. 208. Standard. 14, 16.18, 22, 24, 28. As. Dip 4TL 42, 48. 8, 14, 16, 18.22, 24. E. Ser dip as. 28, 40. 72, 88, 120, 132. PGA. As. 176,208. Asterisk 1. In development. 11. 12. Type package type. Package. Pin count. Symbol. SOP MS 8, 16, 24, 32. FP. Asterisk 2 asterisk 3 asterisk 4. QFPGS. 24, 32, 44, 56, S, 56, L. 60, 64, 80, 88, 100. 2, 128, 136, 144, 160, L. OJ. A colon. SOJ. C. JS26. J. 0. PLCC. Q. 2. OJ. T, 18,20,22,2832. JPLCCJS. 2, 44,68,84. QFPFS 42,60,64,80. E. Q. U. CCES 14,24,28,44. Piggyback VS 40,42. And dash dash dot dash L dash 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 4 dash 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 plus dash underscore 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 OJ dash IJ SIMYS 30 L2 dash 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 4 dash 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 4 dash 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 plus dash dash SIMKS 30 asterisk 2 types of packages are available, thin type and heat resistant type, with vent hole. Asterisk 3 lead pins of 24 or 32 pin plastic FPS are in 2 directions. Asterisk 4, 5, and L differ in pin pitch and outside dimensions. Flat pack family. For each type of OKI flat pack, the material it is made from, its outline and its pin count are shown here. T. Pin 8 16 24 32 42 44 56 60 64 80 88 100 128 136 144 160. Pitch GNM 0I 4P 1.27 SP 12P 4PX21 SPX21 12PX21 14P 14P 13P 1.00 Old 16P 10 U 16P X21 114P X41 I 0 Lip 16P 32P 0.80 J 2D O J11P X41I 32P X41 LSP 20P 34P 36P 40P 14P 20 00DO 0.65 U 30111I1 14P X41 ISG1 34P X41 36P X41 40P X41 LOP 15P 16P 20P CJ000 U E 1.27 2 I U I1 15P X41 16P X41 20P X41 E 2 type of packages are available, thin type and heat resistant type. W with vent hole, which shall be used depending upon board assembly method. Package outlines and dimensions. Plastic standard dip. 18 pin. Unit MML. B. 254, 02 SO 15 degree. Seam plan. 40 pin. Unit, mm. Seating plane. 14. 24 pin. Unit, mm. R backslash, comma R dash. Plastic QFP. 24 pin. NI 0-15. Seating plane. Unit, mml. 22 plus or minus 02. 0-10. Plastic QFP. 32 pin 44 pin. Unit mm. 22, T02. 15% 02. 0.1 to 0.3. In Mark CL alter. Index Mark CL alter. 60 pin. Unit 15. Useful information. Built-in ROM voice synthesis LSI. Development flowcharts. MSM 5248, MSM 6243, and MSM 621-2. 16. User. Analyze the data by analyzer. And input the analyzed. Add data into EPROM. OKI. Note 1. Record the source. Sound on an open reel. Tape deck. Recording assistance. And studio/announcer. Can also be arranged. Where required. Note 2. The voice analysis flowchart is divided into two paths as indicated, where analysis is to be performed by the user. Suitable ADM data can be readily rated by analyzer. Fig 3. User analysis support tools. OSA1, OKI Speech Analyzer. OSA1 enables user to make a straight/compressed ADM data for MSM 6243 and MSM 6212 instantaneously by inputting the voice from the line. Input via microphone or tape deck player. OSA1 also can output the analyzed ADM data. The analyzed data can be stored into the EPROM by connecting OSA1 via RS-232C interface. The OSA1 enables the user himself to change the degree of compression. Voice analysis purposes, thereby enabling sounds preferred by the user to be generated. Furthermore, if EPROMs generated with the OSA1 are used together with a simulator, described later, the quality of the sound when the LSI is formed can be evaluated. OSA1 is available to users on a loan basis. Tape deck. OSA-1. RS-232C. EPROM writer. Compressed ADM data. Input EPROM. --R generation. RR1, sound quality. L1J evaluation. MSM 6243/MSM 6212 simulator. Fig.4 voice analysis and evaluation block diagram. Where OSA1 is used. 17. Speech analyzer. The speech analyzer set using MSM 5218 is used to make an ADM data on real-time basis by inputting voice from microphone or tape deck player, etc. Analyzed data is stored in a built-in RAM, and can be written into an EPROM by a built-in EPROM writer. This EPROM can be used as the voice simulator's data or as ROM data for MSM 5248 etc. For further details, please contact Neon Denso Kajoko, Ltd. March 14, 19 Shibora, Minato-ku. Tokyo, Japan. Tel. 03-452-2351. MSM 5248 Simulator. The MSM 5248 simulator has the same functions as the MSM 5248. When the EPROM, in which the analyzed data is stored, is mounted on the simulator, this simulator can synthesize the same quality voice data as that of MSM 5248. MSM 6243 simulator, MSM 6212 simulator. When the EPROM, in which the analyzed data by using OSA1 is stored, is mounted on the simulator, these simulators can synthesize the same quality voice data as that of MSM 6243, MSM 6212 respectively. 18. Datasheet. OKI Semiconductor. MSM 5205. ADM Speech Synthesis IC. General description. The MSM 5205 is a speech synthesis integrated circuit which accepts adaptive differential pulse code modulation, ADM, data. The circuit consists of synthesis stage which expands the 3 or 4-bit add data to 12-bit pulse code modulation, PCM, data and AD/A stage which reproduces analog signals from the PCM data. The MSM5205 is fabricated using OKI's advanced CMOS process which enables low power consumption. The single power supply requirement and its availability in 18-pin molded DIP allow the MSM5205 to be ideally suited for various applications. Features: 3 or 4-bit ADM system, 12 to 32 KB/SEC with int VCK, on-chip 10-bit D/A converter, low power consumption, 10 MW typical. Functional block diagram: V0, VSS0, single plus 5V supply. Wide operating temperature: Ta equals -30 degrees Celsius to +70 degrees C. 18-pin molded DIP. I. DT 4-bit 4-T plus reset. 2I input ADM synthesis stage 1. D, register 01, 48/38. I. 112-1. XT. 1. 1. XTII. D. 1. I timing. Circuit 10. I. 1. 1. 5, IO. 12-bit. Shift. Register. 10-bit. DI out. STLO. I. VCK. LOI. IL dash underscore. L underscore 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 underscore. 1. 1. I. 1 underscore C2 underscore 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 J. 21. Pin configuration: 18V. XT. XT. Reset. VCK. T2. T. NC. 10 out. Absolute maximum ratings. Parameter symbol conditions ratings unit. Power supply voltage VTA equals 25 degrees Celsius minus 0.3 to plus 7.0 V. Input voltage V1 N Ta equals 25 degrees Celsius minus 0.3 to VV. Power dissipation POTA equals 25 degrees Celsius 200 max MW. Storage temperature TSTG, minus 55 to plus 150 degrees C. Note, stresses above those listed under absolute maximum ratings may cause permanent damage to the device. This is a stress rating only and functional operation of the device at these or at any other condition above those indicated in the operational section of this specification is not implied. Exposure to absolute maximum rating conditions for extended periods may affect CL Eurovice reliability. Operating conditions. Parameter symbol conditions ratings unit. Power supply voltage VU, plus 3 to plus 6 V. Operating temperature top, minus 30 to plus 70 degrees C. 22. D.C, A.C. Characteristics. VDD equals 5V plus or minus 5%, Ta equals minus 30 degrees Celsius to plus 70 degrees C, unless otherwise noted. Parameter symbol conditions min. Input high voltage VIH all inputs except T. T2 4.2. Input low voltage VIL all inputs except TT2 VSS-3. Input high current IIH V in equals VDD. Input low current IL V in equals OV. Output high current IOH VCK pin, VO equals 4.2 V minus 50. Output high current IOL VCK pin, VO equals 0.4 V plus 50. Oscillator frequency FOSC specified oscillator. Operating current IDD FOSC equals 384 kHz. VDD equals 5V. D/A accuracy VE full scale, VDD equals 5V. Internal 10-bit D/A. DAOUTV or output IMPT ANS. Pin description. Pin name terminal number. 2. These inputs select the sampling frequency according to figure 1. 4B/3B3. Specifies whether 3-bit or 4-bit ADM data is to be processed. 4, 5, 6, 7. Tip. Max. Unit. VDD plus 3V. 0.8V. 1 JLA. Minus 1 JLA. 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 384 768 kHz. 24 Ma. Plus or minus 4, LSB. 100, KO. 1/0. O. ADM data inputs. For 3-bit ADM data, do input is not used and should be connected to ground. VSS 9. Ground, 0V. DAOUT 10O. Output for synthesized analog signal. Peak-to-peak swing is proportional to VU. Typical connection. Scheme is shown figure 2. 23. Pin description, continued. 12. 13. IC test pins used at the factory for testing purposes only. During normal operations, TL is grounded and T2 is left open. Pin name terminal number 1/0. VCK140. This pin outputs a signal whose frequency is equal to the sampling frequency selected by the S1, S2. Inputs. See note *1. Reset 15. An active high input which initializes the internal circuitry. Internally, the reset pulse is synchronized with the VCK signal. To be effective, it must be true for at least twice VCK time. XT. XT. 16. 17. 1/0. 1/0. Oscillator input and output for a 384 kHz crystal or ceramic resonator, figure 3. VU 18. Power supply pin, typical plus 5V. 24. S1 S2. LL. LH. HL. HH. Sampling frequency. 4 kHz, 384 kHz/96. 6 kHz, 384 kHz/64. 8 kHz, 384 kHz/48. Prohibited see note *1. Note, 1. The 384 kHz oscillator must be used whether 4 kHz, 6 kHz, 8 kHz. Figure 1 functional table. Doubt. -OI. LPF. H1. Amp speaker. Cut-off frequency FC of LPF should be related to the selected sampling frequency F sample by FC equals F sample/2x 0.85. Sound quality is strongly dependent on the sharpness of the low-pass filter. Asterisk if the 5205 is sent a stream of ADM data that causes greater than full-scale output, the D/A output will wrap around, +5 0.0 +5. Figure 2. External. Reset. XT, 16, in. X384 kHz Murata Corporation. CSB 3840. C-220 PF match crystal or as required to C2-220 PF ceramic resonator. Load specifications. XT and X1, oscillator connector pins. Figure 3. Time chart. I. 2j. I. Over twice as 2. Dash, 4 underscore dot dash underscore I dash, dot I'll dash 1. IC internal I underscore. Reset timing L, dash plus dash, dash 4 underscore I dash underscore 3 underscore 00 dash 0. Input timing. II. G. C internal ITTTTTT 0 to 0, underscore J comma ILLI, I dash L dash. Data capture timing dash JJI. I. 15.6 sec. I. Dash JJ. OAOUT. 5.2 LA sec. Figure 4. Distinction between MSM 5218 and MSM 5205. Both synthesis stages, MSM 5218 and MSM 5205, work with the same method. However, with the exception that MSM 5218 is equipped with an overflow protection. In other words, when all 12 PCM bits become 1, any further exceeding analog input would cause a data overflow which is cached and rerouted as the MSB in case of MSM 5218. MSIJII 5205 returns to all bits 0 when a data overflow sets in. Therefore, the OA output of MM5205 is distorted badly. When MSM 5218 is being used to generate AOPM data for playback on MSM 5205, the peak-to-peak input LEL1L to the A to 0 converter should be limited to 80% of the converter's maximum input range. The use of an automatic gain control, AGC, amplifier or a hard limiter is recommended. 25. Typical application. MSM55 to Centronix interface circuits, FSAMPLE equals 8 kHz. Busy. Strobe. Reset. Look. 1814-15. D. VUVCR res. D. 5. D. 37D. 1126D, doubt. 64019-11-5D. MSM 5205 Rs LPF. D. 410-400. 2. D. 15. VSS. A. VU. Figure 5. MSM 5205 to Centronix timing diagram. Reset underscore 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 on. Rest dot dash min 250 sec dash underscore I. Data underscore 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 I underscore 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 IFIRSTBYTE underscore 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 strobe underscore 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 dash J I backslash underscore 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 J busy underscore 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 JJ. Figure 6. 26. Audio. Speaker. OKI 5F1I conductor. MSM 5218. ADM speech analysis / synthesis IC. General description. The MSM 5218 is a complete speech analysis / synthesis LSI featuring the adaptive differential pulse code modulation, ADM, method of data compression. The MSM5218 contains an analysis stage, where serial PCM data is compressed to 3 or 4-bit parallel ATM data. In addition, a synthesis stage synthesizes PCM data from ATM data. This PCM data can be output directly or routed to the internal 10-bit DAC for analog signal output. In addition to simplifying speech analysis and simulation, this circuit enables users to develop their own speech analysis and synthesis systems. Features: 1-chip speech analyzer/synthesizer, 3 or 4-bit ATM system, ATM data compatible with OKIs, synthesis LSI MSM5205Rs, single power supply, variable sampling frequency, 4 kHz, 6 kHz, 8 kHz. Functional block diagram. VU0-, VSS0-. Low power consumption CMOS process, 15 MW typical. Built-in 10-bit 0/A converted for analog output. Handshaking signals provided for synchronous operation with an external aid. Converter. 24-pin plastic dip, 32-pin plastic fiat. bin/TOC-. ADSI, ___. scanl.r. xt. VCK. Rese1. P. ATM analysis stage. APCM synthesis stage. L ________________________________________________________________________________________________________________________:________________________________________:________________________________________________________________________________________________________________________ T______+ T____++ T____1_++ HHI++. D4B/38 -- plus -Q anal. 10-bit. DAC. ISIN. I. Doubt. I. I_. MS8/S0. -.L. I. 12-bit. Shift. Register. I. I. ______F. _____. SOC. T1 T2 DOS. 27. Pin configuration. Top view, 24 lead plastic dip, top view, 32 lead plastic flat package. Absolute maximum ratings. Parameter symbol conditions ratings unit. Power supply voltage VDD TA equals 25 degrees C minus 0.32 plus 7.0 V. Input voltage VRN TA equals 25 degrees C minus 0.32 VDDV. Power dissipation PD TA equals 25 degrees C 200 max MW. Storage temperature TSTG, minus 55 to plus 150 degrees C. Note, stresses above those listed under absolute maximum ratings may cause permanent damage to the device. This is a stress rating only and functional operation of the device at these or at any other condition above those indicated in the operational section of this specification is not implied. Exposure to absolute maximum rating conditions for extended periods may after device reliability. Operating conditions. Parameter symbol conditions ratings unit. Power supply voltage VDD, plus 3 to plus 6 V. Operating temperature top, minus 30 to plus 70 degrees C. 28. D.CJAC. Characteristics. VOO equals 5V plus or minus 5%, TA equals minus 30 OE to plus 70 OE, unless otherwise noted. Parameter symbol conditions min. Tip. Max. Unit. Input high voltage VIH all input except 4.2 V. T1, T2. Input low voltage VIL all inputs except 0.8 V. T1, T2. Input high current 1 IIHV in equals VU 1 Xia. Input low current IL-V in equals OV minus 1 Xia. Output high current IOHSCON VCK SOC minus 50 Xia. MISB-JSO 00-03. VO equals 4.2 V. Output low current IOLSCONCK SOC 50 Xia. MSBJ 00-03. VO equals OAV. Oscillator frequency FOSC specified oscillator 384 768 kHz. Operating current 100 FVCK equals 8 kHz, 36 mA. Operating current 100 FVCK equals 16 kHz, 612 mA. Output impedance for 100 KO. DJA accuracy VE full scale, plus or minus 4, LSB. Internal 10-bit AJA, VU equals plus 5 V. SIC clock frequency FSIC, 500 kHz. Input high current, 2, IIH2V in equals VU node 120 to 400 Xia. Node 1, applicable for reset. 29. Pin description. Terminal number. Pin name. 24 DIP 32 FLT. IO. VCK110. This pin outputs a signal whose frequency is equal to the sampling frequency selected by S1, S2 inputs. Do. D1. D2. D3. 2. 3. 4. 5. 2. 3. 5. 6. Data I/O port for the ADM data. For 3-bit ADM data, do input is not used. Anacin 68. I/O. 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 Analyze/synthesize function selector. Controls data I/O port direction. When high, data I/O are outputs. And simultaneous analysis and synthesis occur. When low, data I/O are inputs and no analysis occurs. 4B/3B79. Specifies whether 3-bit or 4-bit ADM data is to be used. High equals 4-bit. 8. 9. 10. 11. These inputs select the sampling frequency according to figure 1. SIC 1012. O. Clock input for clocking in serial PCM data from an external ADC into the internal 12-bit shift resistor. ADSI 1114. Serial PCM data input. VSS 1216. Ground, OV. SCON 13170. Output which signals the start of conversion. SOC 14190. When serial PCM data output mode is selected, DOS equals H, this pin provides a 192 kHz signal which is synchronized with the output of the serial PCM data through the MSB/SO pin. Each bit of the 12-bit PCM data will be valid before the positive edge of this 192 kHz signal. DOS 1520. Selector for analog signal output, DOS equals L, or serial PCM data output, DOS equals H. 30. T1. T2. Pin name. 24 DPI. 17. 16. Terminal number. 32 FLT. 21. 22. 1/0. i.e. test pins used at factory for testing purposes only. During normal operation, T1 is grounded and T2 is left open. DOUT 1824-0. Analog signal output pin. MSB/SO1925O. MSB/serial data output pin. MSB of the data in the internal 10-bit DAC will appear at this pin if analog. Signal output mode, DOS equals L, is selected. When serial PCM data output mode is selected, DOS equals H, seri. AL PCM data can be clocked out of this pin. Binatalk 2027 specifies whether the input serial PCM data is in binary or 2's complement form. Reset 2128. An active high input which initializes the MSM5218R's internal circuitry. To be effective, must be held true for at least one VCK time. XT 22 23 29 31 Oscillator inputs for a 384 kHz crystal or ceramic resonator, Figure 2. VDD 2432. Power supply pin. Typical plus 5V. 31. S1. L. H. 32. S2. L. H. Sampling frequency 4 kHz, 384 kHzL96. 6 kHz, 384 kHzL64. 8 kHz, 384 kHzL48. Prohibited. Note, the 384 kHz oscillator must be used. Whether 4 kHz, 6 kHz, 8 kHz. With 384 kHz oscillator. Other oscillator frequencies are possible and will proportionately modify the sample rate. Figure 1. X 384 kHz. C-220 PF. C2-220 PF. Murata Corporation. CSB 384P. Or as required to match crystal or ceramic resonator. Load specifications. XL and XT, oscillator connector pins. Figure 2. Analysis with simultaneous synthesis, FSAMPLE equals 8 kHz. I125 IJSEC-plus. VCK.JIRI:__-1. 7.8 IJSEC, 3x1/384 kHz, II. Reset, 1 plus, I. Latch timing inode 1 IT. I. Internal reset 1 LL_T_T_T_T-_T-_T-_T_T_T_T_T_T_T_T_T_T_T_T_T_T_T_T_T_T_T_T_T_T_T_T_T_T_T_T_T_T_T_T_T_T_T_T_T_T_T_T_T_T_T_T_T_T_T_T_T_T_T_T_T_T_T_T_T_T_T_T_T_T_T_T_T_T_T_T_T_T_T_T_T_T_T_T_T_T_T_T_T_T_T_T_T_T_T_T_T_T_T_T_T_T_T_T_T_T_T_T_T_T_T_T_T_T_T_T_T_T_T_T_T_T_T_T_T_T_T_T_ kHz, I. SC O'Neill J. I. SIC I 111111111111 no 211111111111 III AOSI M valid PCM valid PCM valid PCM3 C equals X equals UU 111111111111 I 573 IJSECJ 22x1/384 kHz AOP J T backslash 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 SX0 11 underscore 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 O underscore underscore R dash 13 LJSEC 5x1/384 kHz G so equals U TT backslash 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 M backslash backslash I backslash backslash RI backslash backslash TO backslash backslash TO backslash IT backslash 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 I backslash backslash R backslash backslash TO backslash IT backslash 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 I backslash backslash R3 I backslash X0 I sock dash n OAS equals H I colon JJUUUUUUUUUUUUUL IJSEC 192 kHz. Note 1. Note 2. The state of the reset input is strobbed into the internal reset latch by the reset latch timing pulse. Analysis begins on the H to L transition of internal reset. Up to 12 bits of PCM data may be strobbed into the device BL-SIC. If more than 12 SIC pulses occur in a given VCK cycle, only the last 12 are regarded as valid. The cycle of SIC pulses must be completed before the next SCON pulse. PCMN, nth input PCM data, 12 bits. Synthesis only, FSAMPLE equals 8 kHz. VCK- 17.8 IJSEC, 3x1/384 kHz, I. Reset. 11, T. Latch timing I. Internal reset. N. I 49.5 IJSEC, 19x/384 kHz, I. On incorporate I.1 Timing I1 underscore dash 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 dot on 0 yen 0 x03 x backslash underscore underscore I plus L OO equals U backslash 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 X equals O equals comma equals X backslash underscore underscore equals O colon underscore underscore X equals on nth opm data QN analog output corresponding to input nth opm data. Figure 3. 33. Block diagram, analyzer. V underscore underscore plus. Data output. ROM or EPROM. Cut-off frequency FCOF LPF should be related to the selected. Sampling frequency FSample by. FC equals 0.85x FSample. 2. Figure 4. Block diagram, synthesizer. Figure 5. Distinction between MSM5218 and MSM5205. Both synthesis stages, MSM5218 and MSM5205, work with the same method. However, with the exception that MSM5218 is equipped with an overflow protection. In other words, when all 12 PCM bits become 1, any further exceeding analog input would cause a data overflow which is catched and rerouted as the MSB in case of MSM5218. MSM5205 returns to all bits 0 when a data overflow sets in. Therefore, the DA output of MSM5205 is distorted badly. When MSM5218 is being used to generate ADM data for playback on MSM5205, the peak-to-peak input level to the A to 0 converter should be limited to 80% of the converter's maximum input range. The use of an automatic gain control, AGC, amplifier or a hard limiter is recommended. 34. W. 01. 1M. Plus plus. 1 CUERFTREQI. I. J dash dash equals 7, S2. I4, O. 20, comma. 7 low slash 6. II. Anasin. 2 VAVOD 087. 10 ND69. TAGND. CSMSM6. 17 5,204 Argentine pesos 25. Dash Ikakan 14. Underscore 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 underscore. 2. Do. 201. 2. 02. 203. L underscore 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 dash dot vck L dash dash dot halt run 500 kilohertz synthesis write analysis read vck 8 kilohertz ANA/SYN. IT. Recommended timing. FSEL 1,2,4B/3B:::::X. 1X. For /JAPE controlled. HAL TLRUN ___ I system. L, 9G18 approximate 495 TJSEC. Do 03 first nibble second N, 2. Equals XXXXXXXX. First nibble second nibble. Dash, dash. Input to 5218. Output by 5218. Figure 6 typical application analyzer / synthesizer. Z. R. M. D. N. I. M. CJ. N. M. D. OKI semiconductor. MSM 6295. 4-channel ATM voice synthesis LSI. General description. The OKI MSM 6295 is a 4-channel ATM voice synthesis LSI which is fabricated using OKI's low power CMOS silicon gate technology. The MSM 6295 can access an external ROM where speech or sound effect data is stored. The maximum size ROM is 256 KB. The MSM 6295 has a 4-channel synthesis stage which allows the simultaneous playback of 4 different channels. So, it is quite useful to have a voice with BGM effect, instrumental sound, echo etc. Features. OKI straight ATM algorithm. Number of bits / sample, 4. 18 address lines for external ROM. 8-bit control bus for mode setting. External memory capacity 2 MB. Interface with common CPU and MPU. Clock frequency, 1 MHz and 4 MHz. Sampling frequency, 6.4 kHz and 8 kHz. At 1 MHz clock. 25.6 kHz and 32 kHz. At 4 MHz clock. Block diagram. 14 to 17. 10 to 13. Number of words, 127 maximum. Vocalization time, 60 SEC maximum. At 8 kHz, straight. Built-in deconverter, 12-bit. DA output format, a class. Voice level reduction. On each channel, -3 dB, -24 dB, 8 steps. -3 dB / step. Low power CMOS process. 3V or 5 VSI /9 LE power supply. 44-pin plastic flat package. 4-channel voice -- // dash / ++-- Synthesis circuit DAO. 18. 18. Dash plus dash dash dot comma dash plus dash 0A0A17. 00 dash 070 dash plus dash 1. Vono 88. 36. Pin configuration. 44-pin flat package. NE0. A7. 0. A2. 10A, 11AO, 12VU, IA07, 1406, 1505, 16AT, 04, 17OA, N02, NIINLECI 0, N2, 3, XNW0, N, W, 2. Pin description. Pin symbol pin number 110 function. 1037 1/0. H38 110. Data bus and condition output. 1239 110. These terminals are inputs of phrase. 1341 1/0. Specification. Maximum number of phrases is 127. 1441i. Also, 10-13 terminals are outputs of is 42i. Operating state, busy state, for 1 to 4 channel is 43i. 1744i. WR3i writing input. Write the data on the data bus of 10-17. The data is written by the setting up of WR. RD2i reading out input. Output busy state of 1 to 4 channel on the data bus of 10 to 13. L level or H level is output while RD is L. When it becomes H, busy state is output. 37. Pin description, continued. Pin symbol pin no. IO function. CS4I chip selection input. Input L level either when WR signal is input or when RD signal is input. Reset 8I reset input. Reset condition is available by inputting L level. All functions are suspended during reset. AO18I. S. SS. Address output. These terminals are to addresses the external ROM in which original voice data is stored. A1735i. Do9i. SSS. Input of original voice data. Input the data from external ROM which stores original voice data. 0716i. SS7i sampling input. Selecting sampling frequency. When oscillation frequency is 1.18 MHz or 4.13 MHz, following choices are available by inputting H level or L level into SS. SS equals H, SS equals L. Oscillation frequency 1.18 MHz 8 kHz 6.4 kHz. Oscillation frequency 4.13 MHz 32 kHz 25.6 kHz. DAO360 voice synthesis output. Voice synthesized analog signal is output from this terminal. XT5i crystal oscillator connector terminal. XT60 same as above. VDD17i power supply terminal. VSS1i ground. 38. Function explanation. 1 phrase specification. Phrases are specified and read into the 2-byte data which is made up of 10 to 17 data bus. The phrases specification data are latched when WR goes high while CS keeps low, L. Format of phrase specification input is as follows. 17 I's. J. 15. 1. 14. I. 13. I. 12J11. I. 1 byte. 2 byte. 1 phrase specification data. Channel specification I reduction specification. 10. As shown in the above chart, 17 of the first 1 byte data is 1. 10 is of the first 1 byte data specifies the phrase. Phrase specification data has a selection of 127 phrases which corresponds to 000, 0001. -111111. The phrase specification data is equivalent to A3, A9 address outputs, and specify both start and stop address which are stored in the external out ROM. Correspondence between phrase specification data and ROM address. Phrase specification is 15, 14, 13, 12, 11, 10. Data external ROM A17, A10, A9 as A7 as A5, A4, A3, A2, A1, A0. Address specification not valid 0 to 0 0 0 0 0 0 0 0 0 0 0. Phrase 10 to 0 0 0 0 0 0 0 1 0 0 0. Phrase 20 to 0 0 0 0 0 0 1 0 0 0 0. Phrase 30 to 0 0 0 0 0 0 1 1 0 0 0. Phrase 127 0 1 1 1 1 1 1 1 0 0 0. Phrases cannot be specified with all OS. The second byte of data specifies the synthesis operation channel as well as channel-specific reduction of playback synthesis sound. As to the format of channel specification, please refer to the following chart for channel specification format. Channel specification. Channel 17 is 1514. 000. 2000. 3000. 400. It is impossible to specify multiple channels at the same time. For example, it is impossible to specify channel 1 and channel 3 simultaneously. 39. Reduction specification. 2. 40. All 0 is considered as 0 dB, the analyzed sound itself. The reduction is made through 8 levels from about 3 dB to 24 dB with the steps of about 3 dB. As to the format for reduction, please refer to the following chart. Reduction specification. Reduction 13 12 11 10. Rate ODB 0000. 3.2 dB 0001. 6.0 dB 0010. 9.2 dB 0011. Minus 12.0 dB 0100. Minus 14.5 dB 0101. Minus 18.0 dB 0110. Minus 20.5 dB 0111. Minus 24.0 dB 1000. Channel voice synthesis suspension. Voice synthesis operation of any channel can be suspended. Its data consists of 1 byte of data. 2. Suspend a channel, make 17 equals 0. And 13, is represent the channel which should be suspended. Suspended channel 17 is 15 14 13 12 11 10. 0000XXX. 20000XXX. 30000XXX. 40000XXX. Channel suspension occurs even if multiple channels are specified. For example, if 13 is or all 1, channels 1 to 4 are suspended simultaneously. 3. Data ROM 1 address data. This specifies start and stop address of AOPM sound source data. 1 sound address data consists of 8 bytes. The first 3 bytes show start address while the last 3 bytes show stop address. The other 2 bytes are empty. By specifying the first address in which the start address is stored, the sound source which should be synthesized is selected. Address 0, 2, 3, 4, 5, 6, 7, SA1, SA2, SA3, EA1, EA2, EA3. Empty. Empty. Start address, SA1, SA3, and stop addresses, EA1, EA3, are stored according to the chart shown below. SA1, EA1. SA2, EA2. SA3, EA3. 0. A15. A7. 2 ADM sound source data. OS. 0. A14. As. 0504. 00. A13A12. A5A4. 030201. 00A17A1S. and A10 as. A3A2A1AO. AOPM sound source data consists of one sample for every 4 bits. So, 1 byte stores data of 2 samples. Data arrangement proceeds from higher rank bits, 04, 07, to lower rank bits, do, 03. The construction of sound source data should always be ended with lower rank bit. So, construct it with even number of samples. 070S0504030201 do. Start address sing MSB to SB LSB sing MSB to SB LSB. V. End address. == Y dash. Final data. I. Sound source data is compatible with the data which is analyzed by MSM 5218 or MSM 6258. In addition, the data which is analyzed by analyzer is usable, too. 41. 42. 3 Structure of sound source data ROM. Following chart shows the memory map of the sound source data ROM. 00000. Empty. 00008H. Address data. 00000. 00010H. Address. Data. Section. 003FFH. Maximum address data. ADM sound. ADM. Data. Source data. Section. 3FFFFH. 3FFFFH. Maximum ROM. When the maximum 127 phrases are selected in address data section, the data is written up to ROM. Address 003FFH. When one phrase is selected, address data is written from ROM address 00008H to 0000FH, and the rest is used as the ADM data section. Functional description. One phrase specifying input. This procedure is to input phrase specifying data onto the data bus input 10 to 17. The data is latched inside when WR goes L to H while CS remains L. Voice synthesis operation does not start till the second byte is fully latched. XTXR-. Reset I. CS. WR. 10 to 17. Phrase. Specleflow Kotlin, ______ plus dash __ LJ.J.J.1J.U.W.1JJ____ dash // comma dash _r. Deo I know sound L. Phrase specifying input is from channel 1 to channel 4 continuously. 1 An interval of 15 tcyc, maximum, is needed between phrases. 43. X. R1ch, -2ch. CS WR. 10 to 17. 1 byte data 2 byte data 1 byte data 2 byte data. 2 Oscillation frequency equals 1.18 MHz. SS equals L. Voice synthesis operation can be started from any channel, 1 to 4. The arrangement of each channel is of no concern. 2 Reduction of synthesized sound. 44. This procedure is made by the second byte of phrase specifying data. Considering a 0 data of 10 to 13 as 0 dB, synthesized sound is reduced between approximate 3 dB and 24 dB with the steps of 3 dB. When reduction rate is 0 dB. --11/2 VDDV /VVVWL 00. When reduction rate is 24 dB. -1 NVDD --- max 1116 VDD/pp. 3-channel voice synthesis suspension. This is accomplished by inputting synthesis suspension data onto data bus input 13 to 17. The data is latched inside when WR goes from L to H while CS remains active, L. Since synthesis suspension data is 1 byte data, synthesis operation is suspended right after WR is input. Multiple channels can be specified. Therefore it is possible to make suspended channels 1 to 4 simultaneously. C5 -- /______/WR-- approximate 156.5 10 to 17. Voice synthesis suspension data. DAO. For reading out of busy state. Oscillation frequency is 118 MHz. 55 equals L. While CS is L and RD is L, each operation state, busy state of channels 1 to 4 is output on 10 to 13. H is output during the operation. /10 to 13 /I busy output of each channel. H or L level. 45. S. Output of voice synthesized sound. 46. MSM6295 has a 12-bit A-class, voltage type, OA converter on chip. So, analog signal is available from OAO terminal. OAO turns approximate 112 VU, when no sound is output, right after power supply is on. This term NAL outputs the amplitude of max VOOP.P. To output sound connects LPF and amp to OAO terminal. OAO. Application circuit. Interface with microcontroller. Microcontroller. 10 to 17. RI5. WR. CS. Reset. XT. SSVU. AOA14. A5A17. 00-07. M6295. XTOAO. 256K. ROM. N. OKI semiconductor. MSM5248. 48K bit ROM ADM voice synthesizer. General description. The MSM5248 is an ADM voice synthesizer LSI using the CMOS technology process. Its internal circuit consists of the voice synthesis stage, the ROM which stores the speech data, 10-bit D/A converter, and the control circuit. It can be used in the variety of systems by connecting with the speaker via the simple interface. The sampling frequency, etc. can be optionally selected by the user. Features. COM single chip. 48K bit ROM for the user's program. Single power supply, 3V. Low power consumption, 0.2 RNA, typical. Maximum number of words, 7 words. Block diagram. VDD. VSS. Maximum length of speech, 3 seconds. Sampling frequency, 5.46 kHz. Built-in 10-bit D/A converter. 32.768 kHz crystal oscillation. Chip form, 18-pin plastic dip or 24-pin flat. Package available. Dash 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 underscore underscore dash 1 dash underscore 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 OJSD. Dash underscore plus underscore underscore dash. Jo. SD1. AOIR. Address select. 0 dash underscore dash 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 plus 1 dash underscore underscore dash dash 1 3-bit RRL ROM 8x 28-bit. Dot, dash T dot colon equals T. SDO. A2. Load 14 end. Stage address. Slash. Adpm. Address detect synthesizer. Counter Tor. 1 dash dot. 12. 14. H. 12-bit latch. Test. Test. CIR1 dash dash plus. Cult. Speech data. MSB9 ROM. 214x 348k bit. MSB. MSB. XT. XT. T1C SPG. 10 BLT DAC. SPG. 1 TLMTNGC.Jantralayer. AC. 47. Pad layout, pad location. Pad no. Symbol. Position. XY. 1 test minus 2445 minus 1197. 2 SDO minus 2445 minus 1377. 3 SD1 minus 2445 minus 1585. 4 SD2 minus 2265 minus 1585. X. 5 AC 893 minus 1585. 6 MSB 2143 minus 1585. 7 MSB 2445 minus 1289. 8 SP 2445 minus 987. 9 VSS 2445 minus 511. 10 SP8 2445 221. 11 VREF 2445 567. 12 XT 2445 1585. 13 XT 2265 1585. 14 Load 789 1585. 15 AO-2265 1585. 16 A1-2445 1585. 17 A2-2445 1317. Note, chip size, 5.2 mm x 3.48 mm. Pad size, 110 IJM x 110 IJM min. 18 VDD-2445 1137. Pin configuration. Top view, 18 lead plastic dip, top view, 24 lead plastic flat package. Test view. SU-A2. S01A1. S02A0. NC. AC load. NC. MSB-XT. 11 VREF SPE VREF. SP8. VSS SPG. 48. Electrical characteristics. Absolute maximum ratings table 1, VSS equals 0 V. Parameter symbol conditions limit unit. Supply voltage VU minus 0.3 to plus 3.6 V. Ta equals 25 degrees Celsius. Input voltage 6-0.3 to VV. Power occupation Po 200 max MW. Storage temperature TSTG, -55 to +150 degrees C. Operating range table 2. Parameter symbol conditions limit unit. Supply voltage VU, +2.4 to +3.6 V. Operating temperature top, -10 to +60 degrees C. External reference resistor RREF applicable for VREF min 100 kQ. DC characteristics table 3, VU equals 3.1 V, VSS equals 0 V, Ta equals 25 degrees Celsius. Parameter symbol conditions min tip max. H input voltage VIH, 2.5. L input voltage VIL, 0.5. H input voltage *1 IIH VIH equals 3.1 V, 1. L input voltage ILVIL equals 0 V, -1. H input voltage *2 IIH1 VIH1 equals 3.1 V 7200. H output voltage *3 IOH VOH equals 2.5 V -0.1. L output voltage *3 IOL vol equals 0.5 V 0.1. Power consumption, 1, 1001 active, 0.2 1.0. Power consumption, 2, 1002 standby. No oscillation. 1. Power consumption, 3, 1003 standby, oscillation, 1020. OASYNK current *4 isync node 1 260 400 600. OA accuracy *4 IE node 2. 0.75. 1. 1.25. X1 X1. Notes, *1 applicable for AO, A1, A2, when pull down resistor is not provided. *2 applicable for LOAO, AC, and AO, A1 and A2 when pull down resistor is applied. *3 applicable for MSB, MSB. *4 applicable for SP, SPE. Unit. V. V. ILA. 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 Ma. 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 ILA. 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 49. Table 4. Value of resistor VREF is 2 MQ. MSB LSB pin. OSP at 0000000 OSP8. Note 1, lower 2-bit in output of 12-bit latch is disregarded, and data with 10-bit is input to D/A converter. The characteristics indicates the value of the pin SP at and SP8. When the value as shown below is input to D/A converter. Table 5. Actual measurement. Input data to 1 qubit D/A converter. Value. MSB LSB. H equals 0.00000. MSB. 10 equals 0.00000. Note 2, 0.75 x 210. This formula is applied on following condition. AC characteristics. VDD equals +2.4 to +3.6 V, 1A equals -10 to +60 0C. Parameter. Oscillator frequency. AC input pulse width. Load input pulse width. D/A output delay time. Full address 0 interval. 50. Symbol. FOSC. TACW. TLW. TLO. TO. Table 6. Timing chart. Conditions. F, OSC. Equals 32.768 kHz. 1000. LSB. 0100. Min tip max. 3232.76835. 10. 65. 305. 2. Pin. SP at. Pin. SP8. Unit. Kilohertz. ILS. 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 Pin description. Terminal number. Pin name. Chip 18 DIP 24 FLT. 1/0. AO 15 15 21 I. AL 16 16 22. A2 17 17 23 I. Address selection input. Maximum 7 words or 3 words are determined according to AO, AL, and A2H/L combinations except that AO equals AL equals A2 equals L is prohibited for users because of the test code for LSI. LSI operation starting method is selected by masking option, 2. CD1 method is to apply a pointed pulse to either AO, AL or A2. Registered the other method is to apply 10 add pulse to load pin after determining AO, AL, or A2. When the voice starting method CD is selected, repeated operation or one-time operation is selected by masking option. See timing chart. Existence of pull-down resistor of AO, AL, and A2 is selected by masking option. Starting method of IC with AO to A2 pins. AO. AL2 dash. A2 dash 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 I dash 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 I. Voice output. SPIJ. SPG. Voice start of. The first word. Voice start of. Underscore I dash T OW the second word. Figure 1. IC is activated by setting only one of AL to A2 pins in H level. When switching to the voice start of another word, be sure to set full address L interval, to the maximum number of words in 3. In case the starting method is selected, load 14 14 18. Pulse input pin for LSI starting. Load pin is a pulse input pin for voice start. Load pin is pulled down inside. When the voice is started by either AO, AL, or A2, load pin should be used as open. Either repeated operation or one-time operation is selected by masking option. See timing chart. 51. Pin description, continued. Terminal number. Pin name. Chip 18 DIP 24 FLT. XT 12 12 15. XT 13 13 16. Pins for crystal. Either external clock input or crystal oscillation can be selected by masking option. External clock input. 32 kHzJL.jl. XT. QCOJ. Open. 0. Figure 2. Crystal oscillation. Crystal. Comma dot dash. H. LD dash. Figure 3. AC 557. All clear input pin. 110. I. All functions of LSI are stopped by input of H level voltage to AC pin, and status of LSI turns to stand by. AC pin is pulled down inside. The built-in POA. Power on reset function is designated by masking option. 11 11 14. This pin is an input pin for the constant current control of low impedance D/A converter. The volume of speaker can be controlled by external resistor, variable, whose value is more than 100 kΩ. More than 100 kΩ. Figure 4. 52. Pin description, continued. Terminal number. Pin name. Chip 18 DIP 24 FLT. 1/0. SP8811. 0. SP8101013. These are output pins for 10-bit OIA converter, low impedance type. When LSI is at standby, SPE plus or minus. And SPE. Turn to high impedance. MSB. MSB. 6. 7. 6. 7. 9. 10. These are output pins for the most significant bit signal and the inverted signal. Test. SU. S01. S02. 1. 2. 3. 4. As test pin is pulled down, this pin should open. 1. 2. 3. 4. 1. 2. 3. 4. SU, S01, S02 are 3-bit AOP data output pins, these pins should be open. VSS 9912. This is a ground input pin. VU 181824. This is a supply voltage input pin. O. O. I. O. 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 53. Timing chart. Repeated operation. FOSC. AC. Load OR. AO to A2. Built-in ROM. Address timing. Output. SP at .SP8. 234567891011112 ABCDEFGHIJKJM. RRR dash 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 plus dash dash I dash dash underscore 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 I end address. I start address. I dash 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 I dash 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 T equals. Figure 5. One-time operation. 54. FOSC. AC. Load OR. AO to A2. 678911112 of difficult no. L dash 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 4 dash HF dash. I. 2. I. Dash colon comma dash. Boiltil naro M underscore. Address timing start address, end address. Output underscore 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 IR ilr dash dash 1J dash dash underscore 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 SP at .SP8, L, F. Figure 6. Typical application circuit. System. TR1, 2SA 1237. FA, 250. TR2, 2SC 3064. FA, 500. VU. Figure 7. VU. VU. SP8 MSB MSB. RE. VREF. SU. SOL. S020.1F. Test. VSS. Dash equals. 55. Combination in MSM 5248 and MSM 5041, melody chip. This circuit is applied to voice and melody card and toy, etc. 22p. 22. ASIN. 16R0117 underscore 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 plus dash 4 dash underscore underscore. A1. 32,768 kHz. Crystal. SPG10. SPEB8. Pezzo. Transducer. M139. MO, VDD38. MO. MSM 5041-11. 40 pin dip. S119. C. 0.1 ILF. 100 KO. Figure 8. Option list. Table 7. No. Items. 1 package. 2 sampling frequency. Op1 pull down for AO. Op2 pull down for AL. Op3 pull down for A2. Op7. Anti-chattering when AO-A2 of starting. Method is selected. Op9 oscillation. Op10, 11 starting method of LSI. Op12 one time or repeatable. Op14 power on reset. 56. 11 vref. C. A. MS8. VSS MSB. MSM 5248-01. 18 pin dip. Selection. Chip I18P dip I24P flat. 8.19 kHz 5.46 kHz. Yes no. Yes no. Yes no. Yes no. Xtal external clock. AO-A2 load. One time repeatable. Yes no. 9. Op12. Repeatable. AOG. T. Figure 9. 8.19 kHz. 2. Tired face. 5.46 kHz. T. Op L. L. A1. 1. I. Op2. 6. XT. XT. A2. T. F. Op3 1. Start with SW input. RFB, Op9. Op10, 11. Dash 0 dash dash. LOAO go dash 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 1L dash underscore underscore dash. Start with load input. A.C.OT, dash J. VUI dash. T. Op.L.J. Figure 10. C. Anti-chattering. 2JAO, A1, A2O. Figure 11. 57. Standard version list. Type no. Contents. MSM 5248-01 Happy Birthday. MSM 5248-04 Fanfare Sound. Merry Christmas and a Happy New Year. MSM 5248-05. Merry Christmas. Option list of standard version. MSM 5248-01. No. Items. 1 package. 2 sampling frequency. Op1 pull down for AO. Op2 pull down for A1. Op3 pull down for A2. Op dash. Anti-chattering when AO-A2 of starting. Method is selected. Op9 oscillation. Op10, 11 starting method of LSI. Op12 one time or repeatable. Op14 power on reset. 58. Selection. AO-A1-A2. LHL. HLL. HLL. Dash. LHL. Selection. Chip I18P dip I24P flat. 8.19 kHz. Yes. No. No. Yes. Xtal. AO-A2. One time. Yes. MSM 5248-04. No. Item selection. 1 package chip. I18P dip I24P flat. 2 sampling frequency 8.19 kHz. Op1 pull down for AO no. Op2 pull down for A1 yes. Op3 pull down for A2 yes. Op7. Anti-chattering when AO-A2 of starting. Yes. Method is selected. Op9 oscillation x tal. Op10, 11 starting method of LSI load. Op12 one time or repeatable. Op14 power on reset yes. MSM 5248-05. No. Item selection. 1 package chip. I18P dip. I24P flat. 2 sampling frequency 8.19 kHz. Op1 pull down for A0 no. Op2 pull down for A1 no. Op3 pull down for A2 yes. Op7. Anti-chattering when A0 A2 of starting. Yes. Method is selected. Op9 oscillation x tal. Op10, 11 starting method of LSI A0 A2. Op12 one time or repeatable one time. Op14 power on reset yes. 59. OKI semiconductor. MSM 6243. Speech synthesis LSI with 192 KB IT ROM. General description. The OKI MSM 6243 is a single chip, CMOS, speech synthesis LSI for AOPM systems. It contains 192K bits of speech data ROM storage. This IC has an input interface, a timing generation circuit, and a 10-bit OA converter. Therefore, voice output systems may be constructed easily by connecting the voice output circuit consisting of a simple input circuit, filter, amplifier, and speaker to the chip. Features: CMOS single chip. Low power consumption. Custom ROM. Selection of supply voltage, 3V system or 5V. System. AOPM bit length, 4 bits. Maximum word number, 124 words. Maximum speaking time, 20 seconds. Compressed AOPM. Selection of Class A or Class B analog. Output is possible. Built-in 10-bit OA converter. Block diagram. VOD. VDO. VSS. Load. Busy/NAR. XT. XL. AC. TR. Dash. R. 1. 15. T. I. C dash. Address select. ROM. 124x 14-bit. T4. 14-bit. Address counter. T4. 192 KB LT. Data ROM. 214x 12-bit. I. Control circuit. 11. TT2, SIP and S03, SD2, SO-SU are test pins. 60. Oscillator frequency, 30 to 132 kHz, 5V. System. Chip, 40 pins plastic dip, 44 pins or 60 pins. Plastic flat package. 2 types of plastic flat package are provided depending on terminal. Pin bending or not bending. Terminal pin not bending. MSM 6243XXGS. Terminal pin bending. MSM 6243XXGSK. When placing an order, specify the type. Word selection through an internal random number circuit is possible, maximum 32 words. Dash dash. I equals colon 12 I 1 J adpm synth sizer T2 12 BTT latch 1 10 10-bit DAC slot SLB dash SIP MSB DAU DAL SPE. VCK. Pad layout, pad location. Pad no. Symbol. Position. XY. 1 SLB minus 2300 minus 1125. 2 VDD minus 2300 minus 1425. 3 SLA minus 2300 minus 1725. 4 MSB minus 2300 minus 2000. 5 DAU minus 2300 minus 2570. 6 DAL minus 2110 minus 2615. 7 SPE minus 1560 minus 2615. 8 VCK minus 675 minus 2625. 9 SIP minus 395 minus 2625. 10 VSS 885 minus 2625. 11 SDO 1075 minus 2625. 12 SD1 1480 minus 2625. 13 SD2 1660 minus 2625. 14 SD3 2060 minus 2625. Y. 15 T2 2295 minus 2325. X. 16 T1 2295 minus 1925. 0.0. 17 Load 2295 minus 1745. 18 AO 2295 minus 1345. 19 A1 2295 440. 20 A2 2295 745. 21 A3 2295 1145. Note, chip size, 4.91 mm x 5.57 mm. Chip thickness, 350 plus or minus 3011 m. 22 A4 2295 1325. 23 S 2295 1730. 24 S 2295 1910. 25 AC 2295 2310. 26 busy/NAR 2295 2625. 27 VDD 1965 2625. 28 XT 1650 2625. 29 XT 1345 2625. 61. Pin configuration. Top view, 40 lead plastic dip. VSS. A. As. AC. Busy/NAR. VU. She. XT. SIP. VCK. SPE. DAL. DAU. MSB. SLA. VOOI. SLB. NC. 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 Note, this pinout applies to the MSM6243XXRS. 62. Top view, 44, lead plastic flat package. T2 MSB. 0. SLA. VDD. SLB. A. NC. 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 A4 NC. NC A NC AC NC CR Q I K KUQ 00000 QZZZZZZ QZ Sad face F ::JCO Note 1. This pnout applies to the MSM6243XXGS and XXGSK. Note 2. Since 17 and 39 pin, VUN, is substrate continuity, short circuits with VU and VU. In the outside. 63. Top view, 60, load plastic flat package. 0000 QLC, W, J, N, QCICINNNNZZZZN. T2. 0. MSB. T, SLA. VOO. SLB. NC NC. 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 A, NC. A2 NC. NC. AINC. As NC. AC. A, 0I. 00. ZZZZZZZZ. Z. N. 3. Note 1. This pnout applies to the MSM6243XXGS and XXGSK. Note 2. Connect pin 23, VU, with VU and VU externally. This pin is conduct to the substrate. Electrical characteristics. 3V system, VU equals 3.1 V tip. Absolute maximum rating. Parameter. Supply voltage. Input voltage. Storage temperature. Operating range. Parameter. Supply voltage. Operating temperature. DAU, DAL output level. DC characteristics. Parameter. H input voltage. L input voltage. H input current 1. H input current 2. L input current. H output current. L output current. Operating power. Consumption. Standby power. Consumption. Power consumption 3. In the case of oscillation. DA output precision. DA output impedance. Notes. Symbol. VIH. VIL. IIHI. IIH2. IL. IOH. IOL. 1001. 1002. 1003. IV. VOR. Symbol conditions. VU. Ta equals 25 DC. 6. T5 TG. Symbol conditions. VU. Top. VU no load. Conditions. VIH equals 3.1 V. VIH equals 3.1 V. VIL equals OV. VO equals 2.7 V. VOL equals 0.4 V. Class B output. Selection and oscillation stop. Standby and Class B. Output selection. No load and Class A. Output selection. Asterisk 1. This applies to the AC, load, and AO2S pins. Asterisk 2. This applies to the input pin except AC, load, and AO2S pins. VSS equals OV. Ratings unit. -0.3 to +5.0 V. -0.3, VUV. -55 to +150 DC. VSS equals OV. Ratings unit. +2.4 to 3.6 V. -10 to +60 DC. 0 VUV. VU equals 3.1 V, VSS equals OV, Ta equals 25 DC. Min. Tip. Max. Unit. 2.6, V. 0.5 V. 0.01 0.5 PA. 10 to 150 PA. Minus 0.01 minus 0.5 PA. Minus 200 PA. 200 PA. 0.10 0.5 Ma. 0.01 0.5 PA. 430 PA. 100 MV. 50 KO. For SLA and SLB pins, this applies in the case of AC input H. In the case of AC input L, this conforms to Note 1. Asterisk 3. This applies when RFB exists and FOS equals 32.768 kHz. 65. SV system, VU equals S.OV tip. Absolute maximum rating. Parameter. Supply voltage. Input voltage. Storage temperature. Operating range. Parameter. Supply voltage. Operating temperature. DAU, DAL output level. Symbol. VU. 6. T19. Symbol. VU. Top. VU. VSS equals OV. Conditions ratings unit. Ta equals 25 degrees Celsius minus 0.3 plus 7.0 V. Minus 0.3 VU V. Minus 55 plus 150 degrees C. VSS equals OV. Conditions ratings unit. Plus 4.5 plus 5.5 V. Minus 30 plus 70 degrees C. No load OVU V. DC characteristics, VU equals 3.1 V, VSS equals OV, Ta equals -30 plus 700. Parameter symbol conditions min. Tip. Max. Unit. H input voltage VIH, 4.2, V. L input voltage VIL, 0.8 V. H input current LIIHI-VIH equals 5.0 V, 1 PA. H input current 2IIH2-VIH equals 5.0 V 20 to 400 PA. L input current IL-VIL equals OV, minus 1 PA. H output current 10 HVO equals 4.SV minus 1, Ma. L output current IOL-VOL equals 0.4 V1, Ma. Operating power. Consumption. Idle, 0.2 0.7 Ma. Standby power. Class B output. 1002 selection and, 0.0110 PA. Consumption. Oscillation stop. Power consumption 3. 10 D3. Standby and Class B. In the case of oscillation output selection. 15100 PA. DA output precision. No load and Class A. 130 MV. Eval output selection. DA output impedance V or, so, KO. Notes. Asterisk 1. This applies to the AC, load, and AO to A6 pins. Asterisk 2. This applies to the input pin except AC, load, and AO to A6 pins. For the pins of SLA and SLB, this applies in the case of AC input H. In the case of AC input L. This conforms to Note 1. Asterisk 3. This applies when RFB exists and FOS equals 32.768 kHz. 66. AC characteristics. VU equals plus 2.4 to plus 5.5 V are common for 3V system and 5V systems. Ta equals minus 30 to plus 70 degrees C, FOS equals 32.768 kHz. Parameter symbol conditions. Oscillator. FOSC13V system. Frequency, 1. Oscillator. FOSC25V system frequency, 2. Oscillator. FDUTY. Duty cycle. LOIT in PO, 1. In the case of TLF sample equals 8.19 kHz. Pulse width. And CPU interface. AC input. Pulse width. TW, AC. Sampling. FS1 FOSC/4. Frequency, 1. Sampling. F52 FOSC/5. Frequency, 2. Sampling. FS3 FOSC/8. Frequency, 3. NAR minimum age. TMN. I in the case of level width FS1 selection. Hold time 4. TH. In the case of load FS1 selection. Min. Tip. 3032.768. 3032.768. 4050. 1. 1. 8.192. 6.554. 4.096. 1. 1. Asterisk 1. TL, max, in the case QFSW input interface is equal to the speaking time of a specified word. Max. Unit. 35 kHz. 120 kHz. 60%. 40 ILS. ILS. Kilohertz. 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 ILS. ILS. 67. Pin description. Terminal number. Pin name. Chip 40 DIP 44 FLT 60 FLT. 1/0. AC 25 16 11 16 I. All clear. LSI comes to standby state by H input and SLA and SLB pins are pulled down to L level. Since this pin is started by load input, pulse input can be used. In this LSI, since power on clear circuit is not built in, apply AC pulse when power is turned on. AO 18945I. AL 1910510I. A 220 11611I. A 320 112712I. A 422 13813I. As 23 14 914I. As 24 15 1015I. Address. These pins are used to specify the speaking word code. Speaking word code is latched into inside by the load pulse rise. Load 17833. Speaking word code is latched into inside by the load pulse rise. When the system is reset by previously applied AC signal, the system reset is cancelled in the case of load pulse rise, and LSI is started. And when NAR output mentioned later is in the H level, load signal comes to effective. busy/NAR 26 17 12 17 Next address request. busy/NAR can be switched in an LSI, and an either of them may be specified on the occasion of order. In the case of NAR use, load input comes to effective with H level, and in the case of busy use, load input comes to effective with L level. XT 2920 1520. Crystal. This is crystal input pin for internal clock oscillation. This also becomes input pin when an external clock is used. Sheet 28 19 14 19. This is crystal input pin for internal clock oscillation. DAU 536 34 47 0. DAL 637 35 48 0. DA upper, DA lower. The output of 10 bits DA converter is connected to these pins directly. Since output impedance of these Pins are great and LPF is not built in, connect the LPF through a low impedance output buffer outside. In the selection of Class A mode, output pin is only DAU. 68. Pin description, continued. Terminal number. Pin name. Chip 40 DIP 44 FLT 60 FLT. 1/0. SLA 334 32 45I. SLB 132 30 43I. Selector A, Selector B. Switch over of the converter output condition to Class A mode or Class B mode. SLA SLB mode output pin. Open, L, Open, L, Class B X2 DAU, DAL. VDD, H, Open, L, Class B X1 same as above. Open, L, VDD, H, Class B X4 same as above. VOD, H, VU, H, Class A DAU. MSB 435 33 46 1/0. In the case of Class B mode, this pin becomes as follows. In the case of MSB equals L output, OAU output is effective. In the case of MSB equals H output, DAL output is effective. In the case of Class A mode, this pin becomes as follows. In the case of MSB equals L output, DAU output value is VDD/2 or more. In the case of MSB equals H output, DAU output value becomes VDD/2 or less. In the case of internal circuit test, this pin is used as input pin. SPE 738 36 49 1/0. Speaker enable. In the case of H-level output, DA output is effective. In the case of internal circuit test, this pin is used as input pin. VCK 839 38 51 Voice clock. Sampling frequency is output through this pin. SDU 11 241 57 IO. SDL 12 342 58 1/0. SD 213 443 59 1/0. SD 314 544 61 1/0. These pins are used for internal circuit test. These pins carry out 1/0 of 4 bits ADM data. Usually, set them to open. SIP 940 38 52. Serial/parallel. These pins are used for internal circuit test. Usually, set them to GNO level. TL. T2. Test. 16. 15. 7. 6. 2. 1. 2. 1. These pins are used for internal circuit test. Usually, set them to GND level. 69. Timing chart. Power on. VU. AC. NAR. R:/FF_______J. LSI start and no operation, standby. 1 start in the case of CPU interface. Load. NAR. Busy. SPE. DAU or DAL. Output. __I. Dash, IH. ____ dash GTL dash. TMN/R/ dash. Approximate RL dash I equals dash dash colon. 1.1 millisecond dash equals JI. IRL. Dash I1 _______________________________________________________________________________________________________________________:_:________________________________________________________:____________________________________________________________h. Approximate. Dash 1.0 millisecond dash slash. RIR. ______T____STANDBY:_J. 1. I silent. Approximate. I approximate. (1.5 millisecond 0.4 millisecond). First word. Speaking. For 3 samples. Second word. Speaking. To transfer to standby in the case of CPU interface. 70. Load. NAR. Busy. SPE. DAU or DAL. Output. Underscore 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 underscore. A. Underscore underscore. E underscore N underscore D underscore co underscore da underscore 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 underscore. Underscore 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 RL underscore 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 underscore. Last word. T, 1 equals colon 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 dot colon, S ta and D by. Speaking. Speaking. Completed. When end code, AO2 as equals L, is accompanied with load, LSI comes to the same state as standby because of AC input. Start of SW input interface and standby. One single word speaking. A dash equals X. Load. NAR. Busy. SPE. DAU or DAL. Output. 2 repetition of word speaking. A dash equals X. Load dash dot J. Approximate. I. NAR. 1 dot lmsec. J. Busy. SPE. DAU or DAL standby. Output. I. Standby. Comma. 1 slash. SPE. 1 IL. Approximate. 0.4 millisecond. 3 samples. No LOAD. Backslash. 1 slash. Slash. Voiced. B. Standby. Speaking. Slash. Speaking standby. 2. 71. Functional description. Speaking word code specification. User can specify word code set by AO, PTE and can select either CPU interface or SW input interface. 1 CPU interface. In this case, user specified words are maximum 124 words. For AO2 as, the following 3 codes, 11111111, 01111111, 10111111, are test codes, and the code 0 million is an end code, therefore, these 4 codes can not be used. The procedure up to the LSI operation start is as follows. Input AO2 as, load pulse apply, latched inside, also LSI operation starts simultaneously. Load pulse is effective when NAR output is H. 2 SW input interface. By the reason described in clause 9.1.1. CPU interface, number of words is set to maximum 124 words with combination of AO to PTE. After the code is set by AO2 as, when H-level load input is switched by push switch, etc., the specified word starts speaking. From standby to operation state. When speaking of the specified word is completed, if the load input is set being H as it is, repeat speaking of the same word, and if the load input turns to L, LSI moves to standby state automatically. Therefore, for example, so far the push switch is being pushed as it is, speaking of the same word is repeated. When the push switch is released, the repetition is stopped at the same time of the speaking ends. To make speaking of different words continuously, change the codes of AO2 as before the first word speaking comes to end, and keep the load in H state. J. End. /1 dash. Load. Start. Point 41 dash dash. Restart. Dash. 11. Dash dash start dash 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 L1. End. Standby. Sampling frequency specification. An user can specify available sampling frequency for each word when ordering. Relation between sampling frequency and oscillator frequency is as follows. In the case of F, OSC, equals 32.768 kHz. Selection 1. 32.768 kHz. 0.8.2 kHz. 4. Selection 2. 32.768 kHz. 0.6.55 kHz. 5. Selection 3. 32.768 kHz. 0.4.1 kHz. 8. 72. Straight ADPM and compressed ADPM. 1 straight ADPM. Features of the straight ADPM are as follows. 1. ADPM bit length. Fixed in 4 bits. 2. Deletion of silent component is possible. 3. High bit rate, high tone quality. 4. Suitable for a sound effect. Bitrate, BA, example. U. Ample equals 8.2 kHz. ADPM bit length equals 4 bits. Deleted silent data equals 1/5, voice. BA equals 8.2 x 4 x 4/5 equals 26.3 kbit/section. 2. Compressed ADPM. Features of the compressed ADPM are as follows. 1. ADPM bit length. Fixed in 4 bits. 2. Deletion of data by repeated detection of speech waveform. 3. Deletion of silent component is possible. 4. Low bitrate. 5. Mainly applies to speech. Bitrate example. FSAMPLE equals 8.2 kHz. ADPM bit length equals 4 bits. Number of average waveform repetition equals 3, deleted data equals 2/3. Deleted silent data equals 1/5. BA equals 8.2 x 4 x 1/3 x 4/5 equals 8.8 kbit/section. Sampling frequency and band. One simple relation between sampling frequency and band. FSAmplex 1/2 equals FBA UL. Here, FBA UL means upper limit of the band. FSAMPLE FBAND characteristics. 8.2 kHz DC, 4.1 kHz clear comprehending almost all tones of voice. 6.55 kHz DC, 3.2 kHz high tone female voice sounds usual. 4.1 kHz DC, 2.0 kHz both male and female voices sound nasal and unclear. 2. Relation between sampling frequency and LPF, low pass filter, is as follows. FSAMPLE x 1/2 equals FC, cut-off frequency of ideal filter. Practically, according to the skirt characteristics of filter, FC shall be designed to be lower than the above mentioned equation. That is, the band will be further narrowed according to filter characteristics. As an example, the FC and skirt characteristics of filter used for speech analysis by OKI are shown as follows. FSAMPLE FC skirt character FBAND 8.2 kHz 3.4 kHz minus 48 dB/oct DC 3.4 kHz 5.55 kHz 2.7 kHz minus 48 dB/oct DC 2.7 kHz 4.1 kHz 1.7 kHz minus 48 dB/oct DC minus 1.7 kHz 73. J. Dot dash dash. Dash dash. Dash 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 dot dash dash. Dash. Underscore. Precautions in use. 1. Relation between load and NAR. A load pulse input is effective when NAR output is H state, and at the load pulse rise NAR output transfers to L state, which will be held till the completion of the former word speaking. Therefore, use of NAR output is capable of speaking smoothly of the sentence composed of some words. Example. Correspond. Encodes. By A0 to A6. Today's weather is fine. Plus plus plus. 010, 0010, 01000, 0100000, 0100. AO, A6010, 0010-010, 0100-000, 0100-0 million. Load. NAR. Speaking. DA output. End. Plus. 0 million. Standby underscore plus I, dash LSI ISBIM.20 dash standby. Started. 2. Internal random number circuit. Use of internal random number circuit may be specified on the occasion of order, but the specification prohibits external code input by A0, A6 and maximum word number is limited to 32 words. 3. Analog output, DAU, DAL. The output of 10 bits to converter is connected to DAU and DAL pins directly. Since this output impedance is great and LPF is not built in, it is necessary to connect outside LPF through the low impedance output buffer. Circuit example. MSM6243-J. For output status, the following modes of Class A and Class B are obtained by 2 pins of SLA and SLB. SLA SLB mode output pin. Open, L, Class B X2 DAU DAL. VU, H, open, L, Class B X1 same as above. Open, L, VU, H, Class B X4 same as above. VU, H, Class A DAU. 74. VU. 3/4 VOO. Class A. DAU 1/2 VU. 1/4 VU. VU equals OV. VU. DAU. Class BX1 VSS. 9-bit DAC. VU. Backslash. DAL. VSS. Class BX2. 8-bit DAC, backslash. MSB1. T. R. MSB0. MSB1. MSB0. MSB1. MSB0. MSB1. MSB0. 75. Example of output interface. In the case of Class B use, output interface is connected with MSC 1161GS, provided, for only 3V system. VU. VU. VCK. SPE. DAU. DAL. MSM 6243. VSS LAVU SLB. VSS. Output of Class A. VU. MSM 6243. VCK. SPE. MSB. DAU 0-1. DAL. Open. VSS LAVU SLB. VSS. 76. VCM. Note, CS are all 0.1/LF. User specified parameter. No. Item user specification remarks. II flat pin without. II dash. I, 60 pin, bending for GS. I dip. I. 1 shipping form chip I. 40 pin, I. IIGS IGSK pin bending JF. TI. III for GSK. III. Package side view III. Supply voltage 3V system. 5V system. 2I. 2.4, 3.6V, 4.5, 5.5V, 3. Operational degree C underscore. Degree C. Temperature. 4. Interface SW input CPU input. Condition interface I. 5 busy and R busy INARI. I internal. 6 word code input external I refer to circuit 1. I random number. I other than in the case other than 32.768 kHz. 7 oscillator 32.768 kHz I 32.768 kHz specify the oscillator frequency. I in the range of 30 to 132 kHz. I when oscillator frequency is other. Sampling 8.2 kHz I 6.55 kHz I 4.1 kHz. 8 I then 32.768 kHz, specify dividing. Frequency, 1/4, 1/5, I, 1/8, I ratio within a parenthesis. I exists dash connect the resonator to XT. 9. RFB of internal. Exists. Not exists. And XT. Oscillation circuit I not exists dash apply external clock to TXI. I refer to circuit 2. Specification. Of correspond I when specified, attach corresponding. 10. Ins between. Specify I not specify table with this paper. Speaking word I when not specified, OKI decides it. And word code. A0 to A6, In the case of editing, attach an. Editing of 11 editing I know editing example sentence with this paper. Speaking words IEX 3 o'clock 10 minutes. Note 1. For parameters of number 4, 5, 6, 8, 9, 10, and 11, corresponds with ROM mask. Note 2. When an user creates a voice data, never write the voice data in 256 words x 126 bits, 3K bits, from the top. 77. Circuit 1. The following chart shows simple circuit when the word is specified. LSI inside. AO. J. AE. U. Dot is. AE. Circuit 2. The following charts show the interface examples for XT and XT. 1 RFB inside. 78. OKI semiconductor. MSM 6212. ADM 288K ROM voice synthesizer. General description. MSM 6212 is a single-chip ADM speech synthesizer incorporating 288K bits ROM to store speech data. In addition to ROM and speech synthesizer circuits, MSM 6212 contains an input interface, timing generator circuit and a 10-bit deconverter. Therefore it is possible to configure a speech output SYS TEM easily merely by connecting a simple circuit to the speech output consisting of a filter, an amplifier, and a speaker. Features: low power consumption, on-chip 288K ROM, 2 power supply selectable, 3V or 5V. Systems: maximum no of syllable words, 124 words. Maximum speaking time, 40 seconds. Compressed ADM. Block diagram. VDD. VSS. AO. A2. A3. Data ROM. Load. CS. NAR. Busy. 2 feet 5 inches x 9 equals 288 kbit. XT. XT timing controller. Class A and Class B analog outputs. Selectable. Built-in 10-bit deconverter. Oscillator frequency, 32,768 kHz. Available in 40-pin plastic dip, 60-pin plastic. Flat package, or die form. T, T2. SD2. SD. SDO. SIP. MMTHEE-. MSB. DAU. DAL. == plus OSPEL underscore underscore. Underscore 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 JTI-VCK. ACV. VDD. SLA SLB. TT2, SIP /TT. SD2, SD SDO ES pin. 79. Pad layout. 1, 2, 3, 4, 5, 6. Plus Y. I. Note, chip size, 5.7 mm x 6.0 mm. 80. X. Pad location. Pad no. Symbol. 1 SLA. 2 VDD. 3 SLB. 4 MSB. 5 DAU. 6 DAL. 7 SPE. 8 VCK. 9 CS. 10 load. 11 AO. 12 A1. 13 A2. 14 A3. 15 NAR. 16 busy. 17 AC. 18 XT. 19 XT. 20 VDD. 21 VSS. 22 SDO. 23 SD1. 24 SD2. 25 SIP. 26 T1. 27 T2. Position. XY. Minus 2699 minus 1063. Minus 2699 minus 1365. Minus 2699 minus 1545. Minus 2699 minus 2091. Minus 2699 minus 2363. Minus 2699 minus 2849. Minus 2199 minus 2849. Minus 1635 minus 2849. Minus 381 minus 2849. Minus 201 minus 2849. 201 minus 2849. 381 minus 2849. 2121 minus 2849. 2301 minus 2849. 2699 minus 2849. 2699 minus 2123. 2699 minus 1577. 2699 minus 1397. 2699 minus 995. 2699 minus 815. 2699 minus 635. 2699 2263. 2699 2443 2699 2623 2699 2849 2519 2849 2339 2849 Pin configuration. Top view, 40 lead plastic dip 60 lead plasti.c flat package, MSM6212GS. MSM6212Rs. 1M8SUUUU, UU. Z00000ZZZZZZZZZZZ. AO load. A1CS. VCK DAL NC. SPE. SPENC. DAL. Busy OAU. VCKNC. ACNCNC. XTNCNC. VUCSNC. Slawload NC. NC. AOVU. NC. NC. A1 NC. NC NC NC. NC NC NC. NC NC NC. NC. T2. NC. A3. NC T1. A. IO00, 0QC. 00000ZZZZZ003. Z equals 0000000. Note, connect pin 23, VU, with VU and VU externally since this pin is conducted to the sub straight. Electrical characteristics. 3V system, VU equals 3.1 VTIP. Absolute maximum rating. Item symbol. Power supply voltage VU. Input voltage 6. Storage temperature TSTG. Recommended operating range. Item symbol. Power supply voltage VU. Operating temperature top. OAU and OAL output level VU. Conditions. Ta equals 25 degrees Celsius. Conditions. No load. VSS 0V. Ratings unit. -0.3 to +3,6 V. -0.3 to VU. -55 to +150 degrees Celsius. VSS equals 0 V. Ratings unit. +2.4 to +3.6 V. -10 to +60 degrees C. O to VU. 81. DC characteristics, VU equals 3.1 V, VSS equals 0 V, Ta equals 25 degrees Celsius. Item symbol conditions min tip max unit. H input voltage VIH. 2.5, V. L input voltage VIL, 0.5 V. H input current asterisk 1 IIHL VIH equals 3.1 V, 1 ILA. H input current asterisk 2 IIH2 VIH equals 3.1 V10 150 ILA. L input current ILVIL equals 0 V, minus 1 ILA. H output current IOH VOH equals 2.7 V minus 50 ILA. L output current IOL vol equals 0.4 V 50 ILA. Operating current. Consumption. 1001, 0.10 0.5 mA. Standby current. 1002. When selecting. 0.01 0.5 ILA. Consumption class B output. OA output accuracy IVEI no load, 100 MV. OA output IMPT and SVOR, 170, KQ. Notes, asterisk 1 applied to AC, LOAO, and AO to A3 terminals. Asterisk 2 applied to input terminals other than the above. However, terminals SLA and SLB are applied when AC input is set to H, conform to note 1 when AC input is set to L. 5 vSystem, VU equals 5.0 vTip. Absolute maximum rating. Item symbol. Power supply voltage VU. Input voltage 6. Storage temperature TSTG. Recommended operating range. Item symbol. Power supply voltage VU. Operating temperature top. OAU and OAL output level VU. 82. VSS equals 0 V. Conditions ratings unit. Minus 0.3 to plus 5.5 V. Ta equals 25 degrees Celsius. Minus 0.3 to VU V. Minus 55 to plus 150 degrees C. VSS equals 0 V. Conditions ratings unit. Plus 4.5 to plus 5.5 V. Minus 30 to plus 70 degrees C. No load O to VU V. DC characteristics, VU equals 5.0 V, VSS equals 0 V, Ta equals 30 to plus 70 degrees Celsius. Item symbol conditions min tip max unit. H input voltage VIH, 4.0 V. L input voltage VIL, 1.0 V. H input current asterisk 1 IIH1 VIH equals 5.0 V, 1 IJA. H input current asterisk 2 IIH2 VIH equals 5.0 V 4400 IJA. L input current ILVIL equals 0 V, minus 1 IJA. H output current IOH VOH equals 4.6 V minus 1, Ma. L output current IOL vol equals 0.4 V1, Ma. Operating current. 1001, 0.20.7 Ma consumption. Standby current. 1002, 3100 IJA. Consumption. OA output accuracy IVEI no load, 130 MV. OA output impedance VOR, 150, KQ. Notes, asterisk 1 applied to AC, LOAO, and AO to A3 terminals. Asterisk 2 applied to input terminals other than the above. However, terminals SLA and SLB are applied. When AC input is set to HAC power. Conform to Note 1 when AC input is set to L. AC characteristics. Common to VU equals plus 2.4, plus 5.5 V, 3 V system and 5 V system. T30 T70 degrees Celsius F30 2768 kHa equals 0 plus T, OSC, equals Z. Item symbol conditions min tip max unit. Original oscillation. F, OSC1, 3V system 3032.76835 kHz frequency, 1. Original oscillation. F, OSC2, 5V system 3032.76865 kHz frequency, 2. Original oscillation. FDUTY, 40-50-60% duty cycle. When load input pulse width TLF sample equals 1 to 45 IJS. 8.19 kHz. AC input pulse width TW, AC, 1, IJS. Sampling frequency, 1, FS1F, OSC, /4, 8.192, kHz. Sampling frequency, 2, FS2F, OSC, /5, 6.554, kHz. Sampling frequency, 3, FS3F, OSC, /8, 4.096, kHz. NAR minimum. TMN when FS1 is selected 1. H level width, IJS. Input change standby. Ta when FS1 is selected 1, IJS. Time. Load pulse interval TNL when FS1 is selected 5 to 1000 IJS. 83. Actuation and non-operation of SW input interface. 1 single speaking. AO to A3 : X. Load, _J11. NAR. 1. J. Busy ___________. -1. No load. IT. / I. J1-1 _____. SPE-. 7. DAU or DAL silent _ word. _1 silent, standby. Output _ -1 speaking. 2 repeated speaking. 84. AO to A3 equals X, LIL. Load. -.j if F. NARL _I. R-1, smiley face, busy -L. T. -F-. SPE _______ No load. DAU or DAL __________. .jting _II SPEKLNG : J standby. Output 1-2. Approximate. 1.1 millisecond. Pin description. Terminal number. Pin name. Chip 40 DIP 60 FLT. 1/0. Load 104053I. The load pulse can be applied when NAR level, see below, is H. When load is set to H, the code at AO to A3 is transferred into the latch. A single pulse or a pair of pulses switches the LSI from standby mode to active. NAR 1550. Next address request. NAR indicates whether the load pulse, see above, can be applied or not. H level enables WLAN. L output disable. NAR outputs H when the speaking of the current addressed word begins and indicates the next address code can be entered. CS 93952. Chip select. This pin enables the use of multiple LSIs. It is open when a single LSI is used because it has an internal pull-down resistor. If H is applied to CS, the LSI is retained in standby mode. Busy 16620. This pin is used for CPU interface, outputting H level during the speaking time. AC 17730. All clear. H pulls to this pin stops all internal functions and the LSI switches to standby mode. No power on clear circuit is built in the LSI. Therefore, make sure that AC pulse is applied when the power supply is made. DAU. DAL. 5. 6. 35. 36. 45. 47. O. These pins, DAU and DAL, are connected to the output of the 10-bit DA converter. These pins have no built-in LPF because of high output impedance. Use them connected to LPF through the buffer of exter. NAL low output impedance. Example of circuit. MSM 62120-1. The following Class A and Class B modes can be obtained from 2 pins. SLA SLB mode output pin. Open, L, Class B X2 DAU, DAL. VDD, H, open, L, Class B X1 DAU, DAL. Open, L, VDDH, Class B X4 DAU, DAL. VDD, H, VDDH, Class A DAU. 85. Timing chart. 1 power on sequence. VDDF. NTW, AC. ACF. NAR ___. F. 2 LSI starting and non-operation, standby. Operating sequence for CPU interface. A0 to A3. -- Load. NAR. Busy. SPE. X / -I -VI. FFI -H. -5 L dot underscore 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 R comma comma dot DAU or DAL underscore 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 plus underscore 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 generation 1 generation 1 of first of second L dot underscore 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 output underscore approximate underscore I word 17 millisecond from operation to standby in the case of CPU interface. A0 to A3. Load. NAR. Busy. Underscore 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 AE underscore N underscore D underscore C underscore OD underscore E underscore 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 SPE underscore 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 DAU or DAL equals 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 T equals output speaking of point 1 silent standby. Final word. Note, ta. Address hold time. TNL. Double load pulse interval. TL. Load pulse width. TMN. NARH width. 86. Functional description. Designation of syllable codes. User can designate syllable codes by A0 to A3 and can select either CPU interface or simple interface. 1 CPU interface. In this case, the maximum number of users designated words, syllables, is 124. All LS represent endcode. A0 to A3 and load pulse are related to each other as shown below. A single load pulse, the max no of words, is 14. Input A0 to A3 plus apply load pulse plus data is latched internally and at the same time, the LSI is actuated. B 2 load pulses, the max no of words is 124. Input A0 to A3 plus apply first load pulse plus. Data is latched internally and LSI retains in standby status. Plus input A0 to A2, A3 IG. Nord, plus apply second load pulse plus data is latched internally and at the same time, the LSI is actuated. For the timing of load pulse application, AP. Apply it when NAR output is at H level. 4. The application of endcode, conform to the above A, and B. Load. D A. I start. B. 2 simple interface. The maximum no of words is 14. A0 to A3 equals. H is a test code. If load input is set at H level by means of a push switch after setting of a code by A0 to as, the designated word is spoken, from standby STA. TUS to operation status. If load input is set at H level when the speaking of the designated word has ended, the same word is repeated. On the other hand, if /f start load input is set at L level, LSI is automatically shifted to standby status. Therefore, as long as the push switch continues, To be depressed, the same word is repeated. If the push switch is released, the repetition is stopped. Simultaneous with the ending of speaking. If the continuous speaking of different words is desired, change codes by A0 to A3 and retain. Load input at H level, before the speaking of first word is ended. \restart. End. Dash. I start. 3. Designation of sampling frequency. It is possible for the user to designate the sampling frequency for each word. The relationship between a sampling frequency and the crystal oscillator frequency is as follows. When f, OSC, equals 32.768 kHz, I and __ standby. Selection 1. Selection 2. Selection 3. 32.768 kHz equals 8.2 kHz. 4. 32.768 kHz equals 6.55 kHz. 5. 32.768 kHz equals 4.1 kHz. 8. 87. Straight ADPM and compressed ADPM. 1. Straight ADPM. The features are enumerated below. 1. Length of ADPM bits. Fixed in 3 bits. 2. Deletion of silent component is possible. 3. High bit rate and high tone quality. 4. Suitable to imitation sound. Example of bit rate. FSAMPLE equals 8.2 kHz. Length of ADPM bits equals 3 bits. Deleted silent component 1/5, speech. B.R, 8.2 x 3 x 4/5 equals 19.7 KB/section. 2. Compressed ADPM. The features are enumerated below. 1. Length of ADPM bits. Fixed in 3 bits. 2. Deletion of data by repeated detection of speech waveform. 3. Deletion of silent component is possible. 4. Low bit rate. 5. Mainly applied to speech. 88. Example of bit rate. FSAMPLE equals 8.2 kHz. Length of ADPM bits equals 3 bits. Frequency of average repetition 3. Deleted data component of waveform 1/3. Deleted silent component equals 1/5, speech. B.RLR 8.2 x 3 x 1/3 x 4/5 equals 6.6 KB/section. Sampling frequency and bandwidth. 1. Simple relationship between sampling frequency and bandwidth. FSAMPLE x 1/2 equals FBAND, UL. Here TBAND, UL. Upper limit of band. FSAMPLE FBAND quality. 8.2 kHz DC to 4.1 kHz. Clear maximum intelligibility. Female speech of 6.55 kHz DC to 3.2 kHz high tone sounds. Nasal. Unclear both male. 4.1 kHz DC to 2.0 kHz. And female. Speeches sound. Nasal. 2. The relationship between a sampling frequency and LPF, low pass filter. The relationship between a sampling frequency and LPF, low pass filter, is FSAMPLE x 1/2 equals FC, cut-off frequency of ideal filter. However, realistically, it is necessary to design FC to be lower than the above equation according to the skirt characteristics of filter. That is, the band will be further narrowed according to filter characteristics. As an example, the FC and skirt characteristics of LPF used for speech analysis by OKI are shown as follows. Skirt FSAMPLEFC Carrick FBAND. Terrastix. 8.2 kHz 3.4 kHz minus 48 dB /oct DC to 3.4 kHz. 6.55 kHz 2.7 kHz minus 48 dB /oct DC to 2.7 kHz. 4.1 kHz 1.7 kHz minus 48 dB /oct DC to 1.7 kHz. Example of output interface. When connected to MSCL 161 for Class B, 43V system only. VDD. VDD. VCK. SPE. DAU VCK. MSB 16. DAU. DAL. MSC 1161. 6212. SPAT. SP812. VDD. VSS Law VDD SLB. VDD. Note, Cs are all 0.1 ILF. Class A output. VCK. SPE. MSB. 6212. DAU. DAL. Open. VSS Lobbed SLB. VSS. 89. 90. VU. 3/4 VU. Class A OAU. 1/2 VU. 1/4 VU. VSS equals OV. Class B X2. 8-bit OAC. Backslash. VU. OAU. VSS. VU. OAL. VSS. OAU. OAL. DAU. Class B X4. 7-bit OAC. Backslash DAL. MSB1. T. MSB0. MSB1. MSB0. MSB1. MSB0. MSB1. MSB0. An abbreviated name of the type is sometimes used as an indication representing an actual product. OKI semiconductor. MSM6308. ADM speech processor for solid-state recorder DRAM interface. General description. The OKI MSM630 is a ADM speech processor LSI for solid-state recording which is manufactured using OKI's low-power CMOS silicon gate technology. A maximum of 256K dynamic RAM is used to store the ADM data. The MSM630 has internal LPF and amplifier for a microphone. So, by connecting microphone, speak, speaker driving amplifier and 256K DRAM, recording and playback of voice can be implemented in the same manner as a tape recorder. Features. 4-bit ADM algorithm. Built-in 8-bit AD converter. Built-in 8-bit DA converter. Amplifier for microphone on chip. LPF, low-pass filter, on chip. 256K DRAM direct drive capability. Oscillation frequency, 4 MHz, 6 MHz. Block diagram. Reset O. XTO. XL, 4-J. VCK, 4-I. NCR, 4-J. SAMO. Start O. Busy 0-1. Rec/play 0-. CSEL. CSEL 20-. CA. CA20. Test. Test 2. Timing. And. Control. Channel. Control. Z. J. U. Sampling frequency, 4 kHz, a kHz. At 4 MHz. Recording phrase, 1, 2, 4 selectable. Vocalization time, 16 seconds maximum. At 4 kHz. Supply voltage, plus 5V. 44 pin plastic flat package. AOPM. Analysis. Cystiosis. 10-2. J:(L. U, U. Z. 15:O. VOD1. V002. V003 analog voltage. VSS. VSS2 analog ground. As A7. I. A. AO. RAS. Ka. We. 01/0. SG. SGC. 91. Pin configuration. IN. A. WINN. 0, NN. II. Busy AMP21. VCK AMP20. RAS Filpo. We feel ro. OVO OVU. KAVOO. 0110 SG. A6 AOIN. A3. 0 out. AOSGC. J. I, is I. WWNNNN. WW. LI. Absolute maximum ratings, VSS1 equals VSS2 equals OV. Parameter symbol conditions value unit. Power supply voltage VTA equals 25 degrees Celsius minus 0.3 to 7.0 V. Input voltage VENTA equals 25 degrees Celsius minus 0.3 to V plus 0.3 V. Storage temperature TSTG, minus 55 to plus 150 degrees Celsius. Recommended operating conditions. Parameter symbol conditions value unit. Power supply voltage VSS1 equals VSS2 equals OV plus 4.0 to plus 6.0 V. Operating temperature top, minus 40 to plus 85 degrees C. Oscillation frequency LOSC, 4.0 to 6.0 MHz. 92. DC characteristics. Parameter symbol. H input voltage 1 VIH. H input voltage 1 VIH. L input voltage VIL. H output voltage VOH. L output voltage vol. H input current 3 IIH1. H input current 4 IIH2. L input current IL. Note, 1 apply to input terminals except XT. 2 apply to XT terminal. 3 apply to start terminal. VDD equals 4.5 to 5.5 VSS1 equals VSS2 equals OV Ta equals minus 30 to 70 degrees Celsius. Conditions min tip max unit. 3.6, V. 0. 815 OD, V. 0.8 V. 10H equals dash 40 Pa 4.2, V. IOL equals 2 Ma, 0.45 V. IIH equals VOD 1 to 100 Pa. IIH equals VDD, 10 Pa. VIL equals VSS minus 10, Pa. 4 apply to terminal without pull-down resistors. Pin description. Pin symbol pin no 1/0 function. DVOD39I digital power supply terminal. VDD17I digital power supply terminal. AVDD16I analog power supply terminal. OVSS25I digital ground terminal. AVSS24I analog ground terminal. SG15I signal ground terminal. Connect condenser for stabilization. SGC12I connect condenser for stabilization. AMP1123I input terminal for amplifier 1. AMP10220 output terminal for amplifier 1. 93. Pin description, continued. Pin symbol pin number 110 function. AMP21210 input terminal for amplifier 2. AMP2020 output terminal for amplifier 2. This terminal is connected to built-in LPF. A DIN14i voice input terminal. DOUT13 output of DI converter. This terminal is connected to built-in LPF. Filpo19 output of LPF. Synthesized sound is output from this terminal. Feelro18 output of LPF. Analyzed sound is output from this terminal. Connect this terminal to a DIN. Reset 27i by inputting H level, the inside of the circuit. Returns to the early stage. Rec/play 28i selection terminal for recording or playback. H equals recording. Start 29i by inputting H level, recording, or playback. Is started. Busy 35 this terminal outputs H level while recording. Or playback. CSEL19i terminal for selecting number of recording. Words. CSEL28i same as above. CA17i terminal for specifying channels when select. ing 2 words or 4 words. CA26i terminal for specifying channels when select. ing 4 words. SAM30i terminal for determining the sampling frequency. D11041/0 and PU output terminal for 4-bit ADM data. A0440. A140. A220. A3430. A410 address terminals of 256K DROM. AS30. A6420. A750. AS310. RAS370 row address strobe for a 256K DROM. CA40 column address strobe for a 256K DROM. WE380 write enable signal to the DROM device. 94. Pin description, continued. Pin symbol pin no. I/O function. XT32i crystal oscillator connector terminal. XT330 same as above. VCK360 output sampling frequency. NCR340 this terminal is used when playbacks contents of different channels continuously. FGUTS26i terminal for selecting the cutoff frequency of the built-in LPF. Test110i terminal for in-house testing. Test211i same as above. 95. Functional description. The number of recording words of MSM630B is selectable either a single word, 2 words, or 4 words. When selecting one word, the maximum memory capacity will be 256K bits. When selecting 2 words, 12BK bits are allocated to each channel. When selecting 4 words, 64K bit are allocated to each channel. So, each recording length is limited depending on the capacity of each DROM. One selection of the number of recording words and the way to specify. Channel, CSEL1, CSL2, CAL, CA2. CSELL CSEL2. Number. CAL CA2 channel. Capacitance. Of words of channel. L, for LLCH1. LHCH2. 64K bit. HLCH3. HHCH4. HL2, LCH1 12BK bit. HCH2. HH1, CH1 256K bit. 2. How to select the sampling frequency, SAM. Following is the relationship between oscillation frequency and sampling frequency. SAM LH. FSAMP FOSC/1024, 4 kHz, FOSC/512, 8 kHz. When oscillation frequency is 4.096 kHz. 3. How to select the cutoff frequency of LPF. The cutoff frequency of LPF is controlled by FGUT's terminal. Please refer to the following chart. VOI sampling. SAM IVCK, Hz. L. I. 4K. H8K. When oscillation frequency is 4.096 kHz. 96. H. 2.3K. 3.BK. FGUTS. L. 1.95K. 2.9K. 4. Function of rec/play and start terminals. Recording. 1 rec/play equals H when recording using partial memory capacity of the channel. Start. Busy. Recording not being used. Capacity of channel. 2 rec/play equals H when recording using entire memory capacity of the channel. Start. Busy. Automatically stops. Recording. Capacity of channel. Playback. 3 rec/play equals L to playback the recorded contents once. Pulse which is shorter than recording time. Start. Busy. Point 1. Playbacks only. The recorded length. Playback. 97. 98. 4 rec/play equals L to playback the recorded content repeatedly and continuously. Start I. Busy. II. CH, playback CH2 playback CH2 playback point 1. NCRI. WL.JW. Don't, I. X. CACA2CH. X. CH, CH2. Continuous playback and repeated playback are archived by maintaining start terminal at H level. Writing to channel is done when NCR goes low, or when starts playing back each word. So channels will be changed, if start is high, when NCR goes from low to high. 5. Interval of recording time. As described up to now, by maintaining rec/play terminal high, recording is achieved for the length of time of start terminal is high. Recording time could be longer because the interval of recording time is for 4K bit. The interval of recording time can be figured out by the following formula. The interval of recording time, 4K bit rate, K sec J, SEC. Example. When sampling frequency is 8 kHz, bit rate is 4 bit x 8 kHz 32K bit/section. The interval of recording time is 4 bit 32K bit sec 0.125 SEC. So, the recording time becomes a maximum of 0.125 millisecond. Start. I. Record, D longer. Internal R ______. Start. Recording time interval. I. 4K bit I. 1 R1. 0.125 SEC, when sampling frequency is 8 kHz. Recording, actual recording time. Application circuit. VU1 VU, VCC. PF. VU. As. AMP 11A7A7. 5 MV. AMP 10A6A6. As SCR. A4. 0. A4. AMP IA3A. A2. Fill 1NA1A1. CD. In. Fill OAOAON. RAS. E. Adin Kaka, J. We. E. Reset Go. 0. Din. Start Co. 01/0. Degree out VSSCD. E. J. CSEL1A. CSEL. CA1 rec/play. CA. Fill 10. Sam. Equals. Fguts xt equals L. Test 1 0. Test 2 XL. Fixing L or A level determines. Sampling frequency, number of words and cutoff frequency. 99. OKI semiconductor. MSM 6309. ADM speech processor for solid state recorder SRAM interface. General description. The OKI MSM 6309 is a ADM speech processor LSI for solid state recording which is manufactured using OKI's low-power CMOS silicon gate technology. 64K or 256K static RAM is used to store the ADM data. The MSM 6309 has internal LPFN amplifier for microphone. So, by connecting the microphone, speaker driving amplifier and SRAM recording and playback of voice can be easily implemented in the same manner as a tape recorder. Features: 4-bit ADM algorithm, built-in 8-bit AD converter, built-in 8-bit DA converter, amplifier for microphone on chip, LPF, low-pass filter, on chip, direct drive capability for SRAM, 64K 4Ps, or 256K, 1 PCE, oscillation frequency, 4 MHz, 6 MHz, sampling frequency, 4 kHz, a kHz, at 4 MHz, block diagram, 100, reset O, XTO, SFO VCK, 4-I, NCR, 4-I, SAMO, Start O, Busy O-, RECJPLGVO.J, CSEL, O, CSEL2O, CAO, CMO, Test, Timing, and Control, Channel, Control, Recording phrase, 1, 2, 4 selectable. Vocalization time, 16 SEC maximum. At 4 kHz. Supply voltage, plus 5V. 60 pin plastic flat package and ADM. Analysis. SYSTESLS. G0U. 2. Z. Is. AO. 1108. 1107. V02. IO1. ROM. CE2SA. We. CEO. CE. CE. CE4. DVDD. AVDD. DVSS. AVSS. SG. SGC. Pin configuration. 60 pin flat package. UF. 3N0. I. A. EN equals. II. N0, 0. 0 equals 0 IW01, 222. IDZA, LL. Start AMP 20. CA, Filpo. CII. Feelrow. CSEL, SG. CSEL2 SGC. Ramadan. DVDD Bayout. 1/08 AVDD. 1107 Test 2. 1/06 Test. 1105 Rec/Play. 1/04 CE2. Index mark. 1/03 CFA. 1/02. A3. L. I0 NG. 101. Absolute maximum ratings, VSSL equals VSS2 equals OV. Parameter symbol condition value unit. Power supply voltage VTA equals 25 DC minus 0.3 to 7.0 V. Input voltage VENTA equals 25 DC, 0.3 to V plus 0.3 V. Storage temperature TSTG, minus 55 to plus 150 DC. Recommended operating conditions. Parameter symbol. Power supply voltage VU. Operating temperature top. Oscillation frequency FOSC. DC characteristics. Parameter symbol. H input voltage VIH. H input voltage to VIH. L input voltage VIL. H output voltage VOH. L output dot voltage VOL. H input current IIH1. L input current IL. Note, apply to input terminals except XT. To apply to XT terminal. 102. Condition value unit. VSS1 equals VSS2 equals OV plus 3.5 to plus 6.0 V. Minus 40 to plus 85 DC. 4.0 to 6.0 MHz. VU equals 4.5 to 5.5 VSS1 equals VSS2 equals OV Ta equals minus 40 to 85 DC. Condition min tip max unit. 3.6, V. 0. 81500, V. 0.8 V. IOH equals dash 40 Pa 4.2, V. IOL equals 2 Ma, 0.45 V. VIH equals VU 20 to 400 Pa. VIL equals VSS minus 10, Pa. Pin description. Pin symbol pin number 110 function. OV0053I digital power supply terminal. AV0023I analog power supply terminal. OVSS35I digital ground terminal. AVSS34I analog ground terminal. SG27I signal ground terminal. Connect condenser for stabilization. SGC26I connect condenser for stabilization of SG. AMP1133I input terminal for amplifier 1. AMP10320 output terminal for amplifier 1. AMP2131I input terminal for amplifier 2. AMP2030 output terminal for amplifier 2. This terminal is connected to built-in LPF. AOIN25I voice input terminal. OOUT240 output of OA converter. This terminal is connected to built-in LPF. FILPO290 output of LPF. Synthesized sound is output from this terminal. FILRO280 output of LPF. Analyzed sound, original sound is output from this terminal. Reset 39I by inputting H level, the inside of the circuit. Returns to the early stage, viz. Standby stage. Rec/play 20I selection terminal for recording or playback. H equals recording. Start 47I by inputting H level, recording, or playback. Is started. Busy 440 this terminal outputs H level during recording or playback. CSEL 150I terminal for selecting number of recording phrase. CSEL 251I same as above. CA 148I terminal for specifying channels when selecting 2 phrases or 4 phrases. CA 249I terminal for specifying channels when selecting 4 phrases. SAM 40I terminal for determining the sampling frequency. 103. Pin description, continued. Pin symbol pin no. IO function. IO11 IO. IO260 IO. IO359 IO. IO 458 IO. Input/output terminal for 4-bit ADM data. IO 557 IO. IO 656 IO. IO 755 IO. IO 854 IO. A020. A130. A240. A350. A460. A70. AS80. A790 address terminals of SRAM. AS110. A9120. A10140. N150. A12160. A13170. A14180. CE110. CE213. Control terminals for external 64K SRAM. CE336.0. CE437.0. CE2SS19.0 control terminals for external 256K SRAM. WE46.0 write enable signal to the SRAM device. ROM52I make H level when EPROM is equipped. Externally. XT41I crystal oscillator connector terminal. XT42.0 same as above. VCK45.0 output sampling frequency. NCR43.0 this terminal is used when playbacks contents of different channels continuously. FGUTS38I terminal for selecting the cutoff frequency of the built-in LPF. Test121I terminal for in-house testing. Test222I same as above. 104. Functional description. The number of recording words of MSM6309 is selectable either 1 word, 2 words, or 4 words. When selecting 1 word, the maximum memory capacitance will be 256 kbit. When selecting 2 words, each 128 kbit is allocated to each channel. When selecting 4 words, each 64 kbit is allocated to each channel. So each recording length is limited according to the capacitance of each SRAM. One selection of the number of recording words and the way to specify. Channel, CSEL1, CSEL2, CA1, CA2. CSEL2 CSEL1. Number. CA2 CA1 channel. Capacitance. Of words of channel. L, for LLCH1. LHCH2. 64 kbit. HLCH3. HHCH4. HL2. LCH1. 128 kbit. HCH2. HH1, CH1 256 kbit. 2. How to select the sampling frequency, SAM. Following is the relationship between oscillation frequency and sampling frequency. SAM LH. FSAMP FOSC/1024, 4 kHz, FOSC/512, 8 kHz. When oscillation frequency is 4.096 kHz. 3. How to select the cutoff frequency of LPF. The cutoff frequency of LPF is controlled by FGUTS terminal. Please refer to the following chart. Voice sampling FGUTS. SAM VCK, Hz, HL. L4K 2.3K 1.95K. H8K 3.8K 2.9K. When oscillation frequency is 4.096 kHz. 105. 4 function of rec/play and start terminals. Recording. 1 rec/play equals H when recording using partial memory capacity of the channel. Start __, OJ. Busy I. Recording not being used _I. Capacity of channel I. 2 rec/play equals H when recording using entire memory capacity of the channel. Start, OJ. Busy. dash colon colon equals 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 r equals eco equals rding equals 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 colon 1. Capacity of channel. Automatically stops. Playback. 3 rec/play equals L to playback the recorded contents once. 1 dash 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 plus dash pulse which is shorter than recording time. Start. Busy. I.1. Playbacks only. The recorded length. Playback. 106. 4 rec/play equals oil to playback the recorded content repeatedly and continuously. *1 I. Busy. ch, playback ch2 playback ch2 playback I. ncri. www. Don't. ca1, ca2 ch. x. x. Hertz. Continuous playback and repeated playback are made by maintaining start terminal at href. L. Writing channel is done when ncr falls down, or the time when starts playbacking each word. So, changing channel is made by turning it with the time when ncr stands up. 5 Interval of recording time. As described up to now, by maintaining rec/play terminal high, recording is made for the length of time the start terminal is high. Strictly speaking, recording time could be longer by the reason of the fact that the interval of recording time is for 4K bits. The interval of recording time can be figured out by the following formula. The step of recording time equals 4K bit rate k bit/sec. Example. When sampling frequency is 8 kHz, bit rate is 4 bit x 8 kHz equals 32 kbitsec. The step of recording time is 4 bit 32 kbitsec equals 0.125 sec. So, the recording time becomes 0.125 millisecond longer at most. Start. Internal dash underscore 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 underscore. Start. Recording time interval. I underscore 4K bit III. 0125 sec, when sampling frequency is 8 kHz. I. Recording, actual recording time. 107. Application circuit I. Interface with a single 256K SRAM. R. I. 1 equals underscore underscore dot j. AMP 11. AMP 10. AMP 21. Phylon. Philo. AOIN. Reset. Start. CSEL1. CSEL2. CA. CA2. SAM. FGUTS. Test. Test 2. VU, VO02. A14. A3. A1. AO. 07. 06. 0. C. CD2. E. NW. E. CE256. VCK. NCR. Busy. RFC/play. Fill 10. XT. XT. VSS2. SGC/SG. Dash equals. Becomes fixed H level or L level by selection. 108. A14. N. 2. J. A1. AOF. IL. N. 1/08 IL. 1/07. E. N. E. 1/02. 110. We. CE. OE. VSS. LL. D. J. 0. Following circuit is recommended if enhanced volume and sound quality are desired. AMP. FLIQI. Application circuit 2. Interface with 464K SRAMs. VU, VDO, A. AMP I. A. AMP, D. Phylin II. Do. Fill 20 We. Reset GE. CE2. Start CE3. GE4. CA. Rec/play. Fill O. XT. 0. She. A VCC. I. I/OB. I. 1/01. 2. U. We. 5E2IJL. 2. CR. 1. A VCC A12 VCC IVCC. I. I. A. ADA, AOA, A, J. I/OB. I/B. Lip. I. IIT, I2. IO. 0. 11O. U. We2, We2. OE. 2-25E2. IJL. 222. 2. 109. OKI Semiconductor. MSM6258/MSM6258V. ADM speech processor for solid-state recorder. General description. The MSM6258 is a complex and highly integrated ADM speech processor, implemented in CMOS technology for low power consumption. The integrated AD and DA converters make the chip more self-contained, relieving the need of an external conversion circuitry. The device comprises internally a DRAM controller permitting the use of DRAMs alternatively to SRAMs and ROMs to store speech data. In other words, less periphery, thus less system vulnerability. A voice detector circuit and a phrase select provision are successfully added features for more performance. The ADM analysis and synthesis block is identical to the popular OKI MSM5218, that is, the bit overflow protection is included in the interest of improved reproduction quality. The device is offered in 2 basic versions, each of which comes in 2 package types. One is the version designed to be interfaced with an 8-bit CPU like the OKI MSM80C85, and comes in a 40-pin DIP or in a 44-pin flat package. The other operates as a standalone solution that includes 19-pin programmable output lines for memory addressing and chip select in a 60-pin flat package or in a 68-pin PLCC, respectively, to permit fully surface mount implementation. MSM6258 accepts 4 to 8 MHz master clocks, out of which 2 sets of sampling frequencies can be derived. Additionally, the ADM bit number is pin selectable between 3 or 4 bits per sample. When using 256K or 1 MB DRAMs, the maximum I/O time is approximately 17 minutes at a bit rate of 16 kbps, while 256K SRAMs offer a little more than a minute of speech, both in their maximum memory configurations. At the higher bit rates, 21.2 and 32 kb/s, the I/O times are reduced proportionally. In case of DRAMs, the OKI MSC2304, 2 megabit module, or MSC2305, 4 megabit module, are recommendable for space and cost saving benefits and in the interest of simplified handling. In the external mode, the built-in 8-bit ADC is looped in that a separate ADC can be connected to MSM6258. While the accuracy may be between 8 to 12 bits for recording speech. When the playback mode is set, the internal 10-bit DAC will be disabled to permit the connection of an external device at 10 to 12 bits of resolution. 110. Features. On-chip analog I/O circuits, 8-bit ADC and 10-bit DAC. ADC and DAC can be looped to connect external devices. External conversion from 8 to 12 bits. Analog or PCM data input. Analog or PCM data output. Selectable voice detector function. On-chip complex memory timing and control. SRAM interface, 64 to 256 kbit, 128 kbyte max. Power down mode possible with SRAM. Interface. DRAM interface, 64K to 1 bit, 2 MB max. Internal DRAM controller/refresh circuit. Playback from programmed EPROMs. Master clock 4 to 8 MHz, typically 4.096 MHz. Sampling frequencies 4.0, 5.3, and 8.0 kHz. At 4.096 MHz clock. Selectable ATM bit numbers, 3 or 4 bit. Recording and playback monitor outputs. Momentary pause function during recording and playback. 7 phrase channels with individual length. 2 versions, for standalone operation. 4 CPU interface, 8-bit. 4 packaging options for flexible device. Mounting. Single power supply plus 5 volts, 10%. Current consumption, 4 mAh, at 4.096 MHz. 10 UA during standby. SRAM interface. Operational temperature, 40 to plus 85 degrees Celsius. Standalone version. Operational temperature, 40 to plus 85 degrees Celsius. MPU-IFF version. Standalone version. 60-pin plastic flat. 68-pin PLCC, upon request only. MPU interface version. 44-pin plastic flat. 40-pin plastic dip. 111. Block diagrams. A. Standalone version. CA1-, C-, CA3-, AO, ALB, VDS, 6, SIC, VR, ADSI, IAD/EADCD, dash, AC, WE, CA, RAS, OE, D/SRAM, pause, 48/38, SAML, SAM2, VCK, XT, XT, FRST, I, dash dash, doubt, dash dash equals DASO, 1 dash colon dash, dash 1S0 CK, dash dash dash, dash DDO, I, J, DL, dash dash O, D2, dash dash, J, D3, KO, D4, dash, dash, J, D5, dash dash D6, KJ, D7, RRECM, dash dash plame, dash underscore, J, RAMSL, R underscore, J, RAMS2, STSPOVF, FST, rec/play, VSS2 VSSL VDO, B. MPU interface version 112. Ven, SIC. VR, ADSI. Doubt. Dash equals dash point 4 DASO. IAD slash EAD, I dash underscore dash dash SOC. AC. CS. RD. WR. D slash C. Pause. 48/38. SAML. SAM2. MPU. XT. XT. Comma. I. Dash dash dash, OO, DL. IE. O, D2. Dash, dash. Dash dash O, D4. TE, 0.0, D5. Dash dash, D6. Dash I, D7. Dash dash RECM. Dash dash PLAME. Dash dash OVF. Dash dash MCK. STSPVCK TDS TRS1 TRS2 VDS VDO VSSL VSS2. Rec/IDY. Pin configuration. Standalone version MSM6258 GSK, GSK. 6 OLED plastic flat package, bottom. 02. 01. A6. Do. A7. VSS1. SAM1. SAM2. A8. A9. A10. XT. XT. D/SRAM. 60. MPUINT NACE version MSM6258 VRS. 40 lead plastic dual in L1NE package, top. 04. VCK. RECM. Rec/play. 03. 02. 01. Do. VSS1. SAM1. SAM2. MCK. XT. XL. MPU. TDS. TRS2. TRS1. OVF. 46/36. 20. 6, SIC. VR, ADSI. VSS2. CA1. CA2. CA3. FRST. VDD. Pause. STSP. RAS, OE. A18. CA. A17. 17. 16. 40. 05. 06. 07. IAD/EAD. VDS. 6, SIC. VRLADSI. VSS2. VDD. Pause. STSP. OL. RD. CS. WR. Doubt. AC. PLAME. SOC. DASO. 21. 113. MPU interface version MSM6258 VGS, GSK. 44 LEAO plastic flat package, top. #LLJ, dot, 0I0O WUV. BB. C. ICCO $. 4434. 33. 030 NC. 026, AOSI. 01 VR, AOSI. Do VSS2. VSSI VU. SAMI MSM6258 VGSK pause. SAM2 TSP. MCK DIG. XTRO. XTCS. MPUWR. 1123. 1222. J, 9N, L, L00, dot, colon, UR equals OG. Pound L0. Note, since 1739 pin, VU, is substrate continuity, short circuits with VU in the outside. Absolute maximum ratings. Standalone and MPU interface version. Parameter symbol. Power supply voltage VU. Input voltage V. Storage temperature TSTG. Maximum permissible loss PD. Conditions value. Ta equals 25 degrees Celsius minus 0.3 to 7.0. Ta equals 25 degrees Celsius minus 0.3 to VDD plus 0.3. Dash 1 minus 55 to plus 1 S00 C. Dash 11. Unit. Volts. Volts. Deg C. Watt. Note, permanent device damage may occur if absolute maximum ratings are exceeded. Functional operation should be restricted to the conditions as recommended. Exposure to absolute maximum ratings for extended periods may affect device reliability. Recommended operating conditions. Parameter symbol conditions value unit. Power supply voltage VU-1 3.5 to 6.0 volts. Ambient range top-1 minus 40 to plus 85 deg C. Oscillation frequency FOS-1 4 to 8 MHz. 114. DC characteristics. VDD equals 5V/10%, Ta equals minus 40 to plus 85 C, standalone version. VDD equals 5V 10%, Ta equals minus 30 to plus 70 C, MPUIIF version. Parameter SYMB conditions min-max unit. Operating current IDD at 4 MHz 4 mA. Standby current IDS with SRAM, AC equals H10 Pa. H input voltage VH1 3.6 V. H input voltage, node 1, VH2 0.8 x VDDV. L input voltage VL 0.8 V. H output voltage VOIOH equals -401A 4.2 V. L output voltage vol IOL equals 2 mA 0.45 V. H input current I high without pull down 10 IA. VIH equals VDD. H input current, no 2, IH2WJIL, IIJ8N2400 IA. L input current ILVIL equals OV minus 10.5 IA. Output leakage current ILO OV. The output relative error VDA no load 40 MV. AD conversion precision VADE VSS1 equals VSS2 equals OV minus 140 MV. VR equals VDD. AD SYN ratio SNI VR equals VDD 42 dB. Int ADC selected VSS1 equals VSS2 equals OV. AD SYN ratio SN2 12-bit, full scale 66 dB. EXT ADC connected VSS1 equals VSS2 equals OV. The output impedance RDA 1222 k ohms. VR input impedance VR 35 tip k ohms. VR input voltage VVR 0.9 x VDD VDDV. 6 input voltage VVI 0 VVRV. 6 input impedance RVI 10 k ohms. SYN equals N 1 x 6. N equals ADC bit number. Node 1 applies to XT. Node 2 applies to ST/SP and POS and MPU. 115. Pin functional description. Terminal number LSI version. Pin name IO. 40 DIP I44 FLT I60 FLT I68 PLCC SAI MPU. IAD/EAD 37 I35 I32 I62 I0 I0. In the recording, analysis, mode, this pin selects either the internal ADC or an externally connected converter. H equals internal, L equals external. 6, SIC, 35 32 30 60 00. If the internal ADC is selected, IAD/EAD equals H, the analog signal coming from a preamplifier/low pass filter configuration can be input THR-OMLY's terminal. If an external ADC is selected, IAD/EAD equals L, the PCM data clock can be input here. SIC equals S, aerial I, input CLOCK, as in the case of MSM5218. VR, ADSI, 34 31 29 59 00. If the internal ADC is selected, IAD/EAD equals H, this pin accepts the reference voltage for the internal converter. Nominally, the referent voltage is VDD. Thus derivail from the power supply rail. In the external ADC mode, IAD/EAD equals L, this pin functions as the input for PCM data. ADS I equals A, NALG/D, digital S, aerial I, N, as in the case of MSM5218. SOC 2219 1038 00. The terminal provides the serial output clock to shift out the PCM data available at DASO. DASO 2118 937 00. The recuperated PCM data is output here in the record and the playback, synthesis, mode. DASO equals D, digital/A, NALG S, aerial O, UT. DOUT 25 22 15 43 00. Voice signal output terminal. DOUT provides ground level during standby, AC equals H, in order to minimize the current through an eventual transistor amplifier stage. Note that a pop noise appears when the level goes to ground. In case of the SA version, when AC is changed from H to L, DOUT raises from GND to VDD/2 within 16 millisecond. In case of the MPU version, when recording or playback is suspended by stop command, this terminal maintains the level when suspended. By start command, recording or playback is started. At the same time this terminal changes 1/2 VDD level. During recording, analysis, this terminal monitors the analog input with a slight delay, being useful to measure with a scope in real time. 116. Pin functional description, continued. Terminal number LSI version. Pin name IO. 40 DIP I44 FLT I60 FLT I68 PLCC SAI MPU. AC 24 I21 I14 I42 I0 I0. H level applied to this pin initializes the entire internal circuitry, reset function, and causes the DOUT output to return to ground level. MSM 6258 provides power on reset, setting AC initially H. SAM 1. SAM 2. 10. 11. 6. 7. 53. 54. 18. 19. The logic levels on these two pins determine the sampling frequency as follows. SAM 1 SAM 2 sampling at FOSC equals frequency 4.096 MHz. LLFS1 equals FOSC/1024 4.0 kHz. HLFS2 equals FOSC 768 5.3 kHz. LHFS3 equals FOSC 512 8.0 kHz. HH invalid. The maximum recording playback times are calculated by T equals disposable memory capacity kbit. Sample X add bit number KB/S section. VCK 242 4250. Oh. 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 Outputs the sampling frequency, voice clock, selected at SAM1 and SAM2 for further control tasks to peripheral circuits, if required. The duty ratio is 50%, while VCK is output during AC equals L, when interfaced with DRAMs and the MPU version. When the SA version is interfaced with SRAM, VCK is output during recording and playback and not during standby. During AC equals H, VCLK is Plame 23 2012 40 During the activated playback, synthesis, state, this pin outputs an H level for the duration of the operation. During recording, analysis, a L is provided. RECM 343-43-600. This terminal outputs L, H, or a 2 Hz pulse depending on the state of operation. 1 during playback equals L. 2 standby during recording equals L. 3 during recording equals H. 4 during pause or voice detection equals 2 Hz pulse. Rec/play 4580X. Selects recording, analysis, or playback mode, synthesis. H equals recording, L equals playback. 117. Pin functional description, continued. Terminal number LSI version. Pin name. III. IO. I40 DIP 44 FLT 65. T68 PLCC SAMPU. OVF, FST, 19. 115T. 5. T3200I0. 1 overflow indicator. During recording and playback, an H is output if frequency of waveform exceeds 80% of dynamic range. 2 flag status indicator. This is a monitor output related to the phrase channels, operable in stand by only. If a selected channel does not contain voice data, an L is output. If data is present, an H is provided. Since the MPU IIF version omits the phrase channels, this function applies to the standalone version exclusively. D/SRAM 6027OX selects the DRAM or SRAM interface. H equals DRAM, L equals SRAM, EPROM. RAS, OE, 204800X. This is the row address strobe SNAL for the DRAM interface, D/SRAM equals H, or the output enable. Signal for the SRAM interface, DRAM equals L. CA 1840600X. CA on MSM 6258 is output monitor pin for column address strobe timing. Please do not connect the CA pin of DRAM directly to this pin. Only high order address bits are connected to DRAM. CA signal WE16440X provides the right enable signal either to the DRAM or to the SRAM memories. VDS 31610X. The level at this pin selects or deselects the voice detector function, H equals on, L equals off. The voice detector may be compared with an auto start recording upon detection of a sufficient voice signal level. FRST 24540X resets the flag of a selected phrase channel when the flag status is H. Only operable during standby. Also refer to OVF, FST, description. 118. Pin functional description, continued. Terminal number LSI version. Pin name IO. 400 LP44 FLT60 FLT68 PLCC SAMPU. Do 845015 IO00. 01734813 IO00. 02624712 IO00. 03514610 IO00. 04140145 IO00. 05 40 40 38 1 IO 00 06 39 37 36 66 IO 00 07 38 36 34 64 IO 00. This bidirectional data bus conveys the ADM-coded data to and from the memory. 1 byte consists of 2 nibbles in the 4-bit ADM data format. Also, in case of 3-bit data format, 2 nibbles are presented, but the LSB of each is always externally pulled down. The MSB of every nibble indicates whether the input waveform is ascending, MSB equals 0, or descending, MSB equals 1. Due to 0.7 output or input a pair of ADM nibbles during every sampling period, which is VCK. The MPUIIF version additionally uses the data bus to call and send command and status data. STSP2150OX. This is a pulse input commencing start and stop of either recording or playback. When the LSI is reset, and a pulse applied, recording or playback commerce at the raising edge of this pulse. Any operation is cancelled at the raising edge of another pulse applied to this terminal. In applications, this pin is connected to VDD via a momentary switch. If not, the pulse width should be at least 2 USEC long. The input is internally pulled down. POS 2251OX. When momentarily connected with VDD, the recording or playback operation is temporarily suspended. The input is internally pulled down. XT 14 13 10 9 1 59 58 25 24 O I O O O O. These are the crystal connectors. When the clock is to be applied from an external source, XT is used to input the signal while XT remains open. 119. Pin functional description, continued. Terminal number LSI version. Pin name 110. 40 DIP 44 FLT 60 FLT 68 PLC CSAMPU. RAMSL 431I0X. RAMS 2. 330I0X. In connection with terminal DIS, the logic levels on RAMS 1 and RAMS 2, RAM size, determine the type and capacity of the memory chips as follows. D/SRAM RAMSL RAMS 2 memory. HLL 64K DROM, including 41464. HHL 256K DROM, including 414,256. HLH1MB DROM. HHH prohibited. LLL 64K SRAM. LHL 256K SRAM. LLHA02A18 binary. LHH prohibited. 4B/3B 2016-73400. The logic levels on this pin determine the ADM data format. H equals 4-bit ADM, L equals 3-bit ADM. Cal 27570X. CA2 26560X. CA3 25550X. The address inputs to select the recording and playback phrase channels. Up to 7 channels can be selected, while the code LLL, corresponding to channel 0, is reserved for reading data from EPROMs, or for use of the memory attached without channel separation. The condition that permits recording on a channel N with FST equals L is that the flag of the upper priority channel N1 is H. Priorities, channel 1 2 3 4 5 6 7. Channel Cal CA2 CA3. 0 LLL. 1 HLL. 2 LHL. 3 HHL. 4 LLH, 5 HLH, 6 LHH, 7 HHH. The MPUIFF version omits the phrase channel provision. 120. Pin functional description, continued. Terminal number LSI version. Pin name 1/0. 40 DIP 44 FLT 60 FLT 68 PLCC SAMPU. AO 336300X. AL 356500X. A 2376700X. A 339200X. A 441400X. A 544700X. A 6491400X. A 7511600X. A 8552000X. A 9562100X. AL 0572300X. AL 12800X. A 1222900X. A 1363300X. A 1483500X. A 15113900X. A 16134100X. A 17174500X. A 18194700X. Address outputs to external RAM. Depending on which type of RAM and RAM capacity is used, the bus provides the number of required addresses, while not required lines operate as chip select outputs. Active equals 0. In other words, the pins RAMS1 and RAMS2 program the add test bus A0 to A18. Memory type addresses chip select. DRAM 64K A0 to A7 A8 to A18. DRAM 256K AD to A8 A9 to A16. DRAM 1 MB A0 to A9 AL0 to AL. SRAM 64K A0 to A12 A13 to A18. SRAM 256K A0 to A14 A15 to A18. Maximum configuration of memory chips. Memory type 4-bit ADPM 3-bit ADPM. DRAM 64K XL 11 sets of 8 PCS88J 11 sets of 6 PCS66J. DRAM 64K X4 11 sets of 2 PCS22J 11 sets of 2 PCS22J. DRAM 256K XL 8 sets of 8 PCS64J 8 sets of 6 PCS48J. DRAM 256K X4 8 sets of 2 PCS16J 8 sets of 2 PCS16J. DRAM 1 MB XL 2 sets of 8 PCS16J 2 sets of 6 PCS12J. SRAM 64K 6 pieces 6 pieces. SRAM 256K 4 pieces 4 pieces. The MPUIFF version omits the address bus A0 to A18. 121. Pin functional description, continued. Terminal number, LSI version. Pin name IO. 40 DIP I44 FLT I60 FLT I68 PLCC SAI MPU. VDD 32 I29 I23 I52 I0 I0. Power supply pin, nominally 5 volts. VSS 195521700. Digital ground pin, nominally 0 volts. VSS 23330285800. Analog ground pin, nominally 0 volts. 122. Pin functional description for MPUIIF oriented 1I0S. Terminal number LSI version. Pin name 110. 40 DIP I44 FLT I60 FLT I68 PLCC SAI MPU. MPU 15 I11 IXI0. Selects the MPU interface. When H, the internal circuitry is set to communicate with an external CPU. Since the input is internally pulled down, make sure to apply AH. CS2723XO. A chip select input. When receiving AL, the MSM6258 can communicate with the CPU. When set to H, the data bus goes on high impedance, thus disabling read and write functions. MCK1280XO. Synchronization signal to the CPU. During recording and playback, a frequency of sample/2 is output. Here. RD282446XO. When this pin is L, the CPU can read the ADM-coded data or status data of the MSM6258. WR262548XO. At the L to H transition, the CPU can write ADM data or command data into the MSM6258. D/C2926XO. When selected H, the data bus provides ADM data, when L, command or status data can be accessed. TDS1612IX0. TRS11714IX0. TRS21813IX0. TSP3027 IX0. TRP444IX0. TVD3634IX0. These are test inputs for factory testing. The three terminals must be grounded during normal operation. 123. How to control external ADC and DAC. Internal and external modes are related to signal conversion. Mode IAD/EAD equals H, internal, IAD/EAD equals L, external. 6. Voltage input, SIC, serial input clock. VR, ADSI, VR, reference voltage, ADSI, analog/digital serial input. External DAC. The straight binary, PCM coded, data is fed into the MSM6258 through terminal ADSI, while the data clock must be applied to SIC. As a result, every bit coming from the external ADC is shifted into the speech chip at the raising edge of every clock impulse. In case less than 12 bits are provided, the remaining lower order bits, LSB, must be clocked in as zeros. However, usually an external ADC of more than 8 bits will be employed to boost up the speech quality. Timing charts, FOSC equals 4.096 MHz. External analog I/O digital converter. VCK. ADSI MSB. 2SB 3SB 4SB. SIC. 2US. External digital to analog converter. VCK, -.J. DASO. SOC. MSB 2SB 3SB. 7.8 US ********************************** $3.9 US. Data latched. L-F into MSM6258. LSB. 10 SB 11 SB. 2 US. L. SB. 10 SB 11 S. Lose equals 4.096 MHz. External DAC. During playback, recuperated straight binary PCM coded data is output by terminal DASO, while the data clock is available at SOC. Every bit of the PCM pulse train is valid upon the falling edge of the clock out pulses. The effort that an external DAC involves is worthwhile only under the condition that an external ADC of a higher resolution than 8 bits is used at the input. MSM6258 does not accept ULA or ALA comp and PCM data, and also does not satisfy CHIT. G.721 recommendation. Therefore, the device cannot fully replace an ADM codec. 124. Recording instructions, for standalone version. 1. Select the desired sampling frequency at pins SAM1 and SAM2. 2. Set the rec/play pin to H to determine the recording mode. 3. Set the phrase select pin CA1 to CA3 in accordance with the channel priority. 4. The flag of the selected channel is output at pin OVF, FST, note. 5. Commence recording by pressing the STSP momentary button. Note, when the selected channel flag if H, it is indicated that the channel is already recorded. The available recording time for a new input is identical to the duration of the previous recording length, and ends automatically when the pre-recorded data boundary has been reached, followed by an internal reset. The STSP input has no effect during recording. In other words, the recording operation cannot be suspended intermediately once commenced. When the selected channel flag is L, can also be set to L by applying AH pulse to the input, recording time is freely available until STSP is pressed again. However, if the recording merges into another already recorded channel, playback of this intruded channel becomes impossible since its flag is reset. L. In brief, FST equals H. Recording 1. Playback 3. 1 equals the recording time is the same as the previous. 2 equals recording time is variable. 3 equals playback time as previously recorded. FST equals L. 2. 4. 4 equals playback impossible when data from previous channel has merged. Playback instructions. 1. Set rec/play to L. 2. Select the desired channel to be reproduced. 3. Make sure that the OVF, FST, pin outputs H. If L, playback is not possible, see table above. 4. Input a pulse through STSP to commence playback. 5. Playback stops automatically when the time of the recording has elapsed, or can be interrupted any time by another pulse to STSP. 125. Start/stop/pause timings. 1. Recording, flag equals L. A. Start and stop. Start/stop. STSP. Phi. I flexible recording time. B. Twice pause during operation. Start/stop. STSP, LN. Pause Phi. N. I. Restart. Temporary. C. Once pause during operation. Start/stop, priority. STSP, LF1. Pause. Phi. I. Standby. Temporary stop. D. Pause during standby. Start/stop. STSP, L11. Pause, L11. Invalid. 2. Rec/play equals H, recording, flag equals H. Stop. Original length of selected channel. Auto reset. STSP 11 stop. And reset. Stop. Start. Invalid. 3. Rec/play equals L, playback, flag equals H. Start original length of selected channel end off play. STSP 11 stop. Start/stop. STSP. IIE. Standby mode. Note, pause timings at 2 and 3 are identical with 1, BCD. 4. Rec/play equals L, playback, flag equals L. The LSI is in standby condition and does not permit playback. 126. Power down reduction mode. During standby, the internal oscillation circuit automatically stops the operation and validates the power saving mode. This mode can be entered under the condition that the SRAM interface is set, D/S equals L, When the master clock is 4.096 MHz, the startup period after cancellation of the power saving mode by a start pulse lasts 20 to 30 milliseconds until the oscillator stabilizes. How to use phrase channel 0, standalone version. 1. Phrase channel 0 is effective for reading EPROM resident ADM-coded speech data into the MSM6258. The EPROMs may have been programmed previously by a SAS1A or A101 development system. When channel 0 is selected, CA1 to CA3 equals LLL, all address outputs from A0 to A18 are initialized to all 0, and commence counting up the NA, GA addresses upon receipt of a pulse to the start input. Condition, rams1 equals L, rams2 equals H, 0/RA equals L, refer to pin descriptions. Playback of certain words or word groups can be implemented by external individual control of the CE inputs of the EPROMs. However, this demands adequate editing of speech data prior to writing the EPROMs. In the interest of best reproduction, the MSM6258 should be set at the same sampling rate at which the data was recorded and stored in the memories. When channel 0 is selected, VDS, voice detector, input goes to L. Playback instructions. A. Set rec/play to L. B. Select channel 0 by setting CA1 to CA3 to LLL. C. Make sure that OVF/FST output is H, otherwise playback is impossible. If necessary, reset the chip. D. Apply a pulse to STSP, and playback commences. E. Suspend playback with another pulse to start/stop. 2. When DRAM or SRAM memories are interfaced with MSM6258, the selection of channel 0 gives the user the totally available memory area without channel separations. Speech development systems. Right top, SAS1A records, replays, edits speech 0001020304050500607. Data, and writes ADM-coded data into 64 to M6258. 128K EPROMs. It also copies written EPROMs. NIIN+1. A microphone and a line input are provided. N+2 II. N+3. Right bottom, the latest development system. A101 performs the same functions as SAS1A. SAS. But can be linked with a floppy drive, and has a N+1 I. N. Hex keyboard for comfortable operation. IT. N+3. 2. N+2. Writes EPROMs from 64K to 512K. 127. Switching characteristics. MPUIIF version. VDD equals 4.SV to S.SV, TA equals -40 to +8 SC, FOS equals 4.096 MHz, sample equals 8.0 kHz. Parameter. VCK high period. VCK low period. MCK high period. MCK low period. VCK raised to MCK raised time. Setup time in respect to MCK fall. When reading ADM data. Hold time in respect to MCK fall. When reading ADM data. Setup time in respect to MCK fall. When writing ADM data. Hold time in respect to MCK fall. When writing ADM data. RD pulse width. D/C setup time in respect to RD fall. D/C hold time in respect to RD raise. CS setup I hold time in respect to RD. Data stabilization time after RD fall. Data floating time after RD raise. WR pulse width. D/C setup time in respect to WR fall. D/C hold time in respect to WR raise. CS setup I hold time in respect to WR. Data setup time in respect to WR raise. Data hold time in respect to WR raise. AC fall to start command input. Start command input setup time. In respect to VCK raise. Stop command input hold time. In respect to VCK raise. VCK fall to RECM raise. VCK fall to RECM fall. AC fall to DOUT equals 1/2 VDD. Start command input to PLAEM raise. Stop command input to PLAEM fall. Time from stop command input to start command input. Notes. 1. Directly proportional to FSAMP. 2. Directly proportional to FOSC. 3. Sampling frequency x2, TMH. 128. Note 1. Note 1. Note 2. Note 3. Note 2. 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 Note 1. SYMB min tip. TVH, 1LFSX 0.5. TVL, 1LFSX 0.5. TMH, 39.1. TML, 210.9. TVM, 19.5. TRMS 15. TRMH 55. TWMS 70. TWMH 2. TRR 250. TDCR 50. TRDC 100. TCR 50. TOR. TDRF 10. TWW 250. TDCW 50. TWDC 100. TCW 50. TOS 100. TDWH 150. Law 16. TWVS 4. TWVP 4. TVRR 0. TVRF 0. TDAS, 15.6. TWPR 0. TWPF 0. TSPT 260. Max unit. PS. US. S. S. PS. S. PS. S. PS. NS. 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 200 NS. 200 NS. 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 MS. 120 US. 120 S. 2S. 2S. MS. 4S. 2S. PS. Standalone version. VU equals 4.5V to 5.5V, TA equals -40 to +85C, FOSC 4.096 MHz, FSample equals 8.0 kHz. Parameter SYMB min tip max unit. AC pulse width TACP 2.0, S. STSP pulse width TSTP 2.0. Pause pulse width TPAP 2.0. FRST pulse width TFRP 2.0, S. STSP input to RECM raise, DRAMI/F, TOR, 16.3, ms. Oscillation start to RECM raise, SRAM, TSRR 5 and 2, 70 milliseconds. Oscillation start to DOUT active, SRAM, TXDS, 40, ms. Stop input to RECM fall TSRF 0 to 32 milliseconds. VSS to 1/2 VDD transition time at DOUT TDAR, 16, ms. RECM/PlayMel to doubt equals VSSTDAF 0:16:32 milliseconds. Start pulse input to PLAEM raise TSPR 0 to 4. Stop pulse input to PLAEM fall TSPF 0 to 4s. PlayMel to next replay start pulse TPRS 35, ms. 129. Timing charts. MPU interface version. Underscore 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 I. TMHI, dash I. J, TVM3IETMLI. VCK. IIIMCK. TRMS underscore, dash 1 dash, T, dot, RMRT dot H comma dot dash dash. F colon colon Evo, slash, slash Arl slash Lily. VOC 1 dash 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 C. L. OIC underscore 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 slash dash underscore 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 dash colon W dot lu LLI 1 IJ slash IJ slash LJJ 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 LLI LJJ LLJIJ slash dot L dot L. RO underscore 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 TOCR equals TTRRNR dash WR dash dash plus dash dash 00 dash 07 underscore 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 dash. Read timing, recording or status data output. I underscore TVH underscore ITVLI. III. VCKLTVMITMHTMLI. Dash dot E equals tie dash 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 underscore 1. MCK. R, I equals I colon colon, colon 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 equals R. TWMSIT. TWMH. P colon colon WIA underscore 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 V colon colon, all colon D underscore 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 FOIV7, 000L701111JXV underscore L underscore LD underscore 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 L. OIC dash slash 1 dash 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 comma dash plus dash 1 dash 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 1 dash dash underscore 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 WR 00 dash 07. Write timing, playback or command data input. 130. AC loss. VCK. O/C. Vir. AD. MCK. FECM. Do. 01. 02. 03-07. OUT. DAOUT veiled IDAOUT veiled. Recording timing. AC loss. VCK. DLC. Vir. AD. H. MCK. Plame. Do. 01. 02. 03-07. OUT. TOS DAOUT VOT OAOUT valid. Playback timing. 131. Dash dash. Dash dash. Standalone version. 1. Recording timing, DROM IIF, VDSL. SPSP stop. ISRF dash comma slash dash dash 1. RECM. VCK, Joule. FUD. VDD dash 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 4 dash 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 dash. Doubt. GND 4 4 IDR. Note, when VDSISH, the pin RECM outputs a 2 Hz pulse during voice deletion. IDAF. 2 playback timing, DROM IIF. SPSP start. Dash dash plus TISPRISPF dash, dash plus. Plame IR dash. VCK, Jewel C, Ju 1 LL. VDD 4 dash 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 4 dash 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 doubt. GND asterisk dash 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 plus underscore dash IDAR IDAF 132. 3 recording timing, SRAMIIF, VDSL. TSTP. JI. STSPL.S underscore T underscore A underscore RT underscore 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 underscore. OSCA start. Stop. XTXL underscore underscore R dash dash. OSCA stop. TSRF. RECM. VCK. VDD dash underscore plus dash dash plus underscore underscore R underscore plus dash. GND dash plus underscore underscore plus dash. IOAR loaf. 4 playback timing, SRAMIIF. TSTP. JI. STSPN start R, stop. N. Restart I underscore 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 I. Lee underscore 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 underscore. OSCA start. XTXL underscore underscore dash dash underscore R underscore dot dash. Oscillation OSCA stop. TSPFO plus dash plus. TPRS. Plame. VCK. VDDR dash plus underscore dash plus dash dash plus underscore. Doubt. GND dash 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 1L dash 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 plus dash 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 dash. TDAR loaf. 133. How to use the data bus, MPUIIF version. 1. The data bus designations are explained by the following table. CSD/CRDWR operation. LHLH ADM data output. LHHL ADM data input. LLLH status data output. LLHL command data input. HXXX high impedance. 2. ADM data composition on the bus. Bus lines. 4-bit ADM. 3-bit ADM. 4-bit ADM. 83 equals sign bit. B2 equals MSB. B1 equals 2SB. Bo equals LSB. Do D1. Bone B1N. XX bone. Sign bit equals 1, waveform descending. Sign bit equals 0, waveform ascending. D2 D3. B2N B3N. B1N B2N. 3-bit ADM. 82 equals sign bit. B1 equals MSB. Bo equals LSB. 3. Command input structure on the data bus. Do D1 D2 D3 D4 D5. SP play rec P4 P3 P2. ST. Condition, CS equals L, D/C equals L, RD equals H, WR equals L. SP, terminates recording or playback. Play ST, commences playback. Rec ST, commences recording. D4. Bone +1. XX. D6. P1. Po to P4, set the initialization pointers. Normally set to L. Note, do not input SP command during pause. For command data direction. Command. CPU MSM6258. 5 status output structure on the data bus. Do D1, D2, D3, D4, D5. ROP1, P2, P3, P4, XX. Condition, CS equals L, D/C equals L, RD equals L, WR equals L. Po to P4, set initialization pointers. Voice, L equals mute. H equals voice present. Rec/play, H equals during recording operation. L equals during playback operation. 6 status data direction. Status. D6. Voice. CPU MSM6258. 134. D5. B1N +1. Bone +1. D7. Po. D7. RECI. Play. D6 D7. B2N +183N +1. B1N +182N +1. How to measure IDD. VDD. A. 1. 100. VIH. L. 36V, VDD. VR. A18. 6A17. A16. A's. A14. A13. -A12 rec/play. N. STSP. 1 equals. 1 pause AOF. IAC. D7. N open. C, LLF. CLO. VDSIT, F. IAD/EAD. Do F. N. Disram 5F. RAMZW. RAMS2. FRST. Doubt. Cal. CA2. CA3. TL equals XT. XT. Dash equals. SAMI. SAM2. VSSI VSS2. VIL, 08VJ. Dash equals I. AC. Dash 36V. 08V ________ N. Dash. 3.6V. STSPL. ______________________________________________ _08V. Dash _V J. Period to measure 100. 135. Package dimensions. 68 PLN quad PLCC, MSM 6258JS. 136. 45. 1,45. 050 LYP. 3 places. R1H, JA, 53C/W. Lead frame CUIAIIOE. 25,020. 25,270. 24,130. Pin 1. Index mark. BC 0,177. I. 0,66. 0,81-R1-:1-__1. 12,510. 12,635. Footprint layout 88 lead PLCC. FL5B. 23,12. AL dimensions are in millimeters. Connection diagram and control timing for DRAM. A. How to connect DRAM. There are 5 kinds of DAMs that can be connected to the MSM6258. 64K x 1 bit, 64K x 4 bit, 256K x 1 bit, 256K x 4 bit and 1M x 1 bit. However, plays connect as follows. Type of ADM bit length input/output x 4 bit DRAM. 4 bit use pin 8 every even number. 3 bit use pin 6. 1 bit DRAM. A multiple of 8. A multiple of 6. B. DRAM refresh. The way to refresh DRAM is by RAS only refresh, and so almost all DRAMs can be used with the MSM6258. The MSM6258 has a D to A18 address pin, and if a specific type of DRAM is selected, upper order address bits, A8 to A11, are used as CA signal. They also play a role of chip select. DRAM driving timing of selection of 64K DRAM is shown below. Diagram 1 to 3. Timing for DRAM memory. A 10-OTRROO-NDDNO-. A 9-OOO-DOOO-MUOUDUDO-I. No. T. C. JTFC. Asterisk. C. VCKA10. H. A9. H as I. 64. IOSC equals 4.0 MHz. ISAM equals 78 kHz. Diagram 1, timing of higher rank address. I. 64 II. O. L. IHN. Unit.usec. Diagram 2, enlarged timing of diagram 1. 137. VCK. As 4. RAS. AOA7 ___ dot colon dot slash dash dash slash. Refresh address change I. 812 I8. When recording. Internal timing. When YINGBACK -L. Refresh data read write refresh. Diagram 3, data read timing of MSM6258. See RAM selection and DRAM type that can be used. Following chart shows the combination between DRAM type and addresses when D/SRAM terminal is H level and DRAM is selected. RAM/SL RAM2 DRAM type. OKI's equivalent address chip select. Parts no. Terminal 64K XL bit MSM4164. LLAOA7A8A18. 64K X4 bit MSM41464. 256K XL by MSM41256. HLAOA8AGA16. 256K X4 bit MSM414256. LH1M XL bit MSM411000AOAG ALOAL. 138. Control timing for SRAM. Timing for SRAM memory. A 15-.1. A 14. A 13. Standby 2 SEC 2 SEC. Diagram 4, chip select timing. VCK1 -II 2 SEC. I. 64K SRAM selection. Lose equals 4.0 MHz. ISAM equals 7.8 kHz. I. 60.1. AOL2 dash 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 dash. Underscore 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 I 48.8 WIOI underscore 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 dash dash. When recording U MSM 6258 data read timing OEH when recording L when playing back 52 T diagram 5 detailed timing unit microsec 139 how to re-record MSM 6258 has protection function for each recorded channel. So to re-record, and to extend the length of recording, the protection function has to be turned off for each subsequent channels. For example, if CH1 is to be extended, then CH2 protection flag is cancelled by activating the flag reset pin, FRST equals H. Below is a sequence to record over and change the recording length 6F channel 2 to 4 after the channel links and lengths had been established. Please note that each channel has an override priority. That is, if CH2 protection flag is reset and the new length of CH2 is longer than before, it will extend into CH3 area even if CH3 protection flag is set. 1. Select channel 2 and reset the flag of channel 2 by FRSTB. 2. Record again on channel 2. At this time, FST is low and so input beginning and ending pulse for ST/SP pin is need. Ed. At this stage, recording time of channel 2 is prolonged, FST signal of channel 3 will automatically be low, but at the same time, channel 3 will not be able to be recorded. C. 3, 2, is an example where channel 3 was selected and that it was recorded again so as not to extend into channel 4. 4, E, is an example where channel 4 is reset and recorded over. Example showing change of recording length. External RAM capacity. CH.12. I. 34. A. FST equals HHHH. L. Reset flag of CH.2. CH.1234. B. FST equals H-HHH. L. Record again to CH.2. CH.1234. C. FST equals HH degree HH. Record again to CH.3. CH.2234. D. FST equals HHHH. J. Reset CH.4 flag and record. Again to CH.4. CH.22. I. 34. E. FST equals HHHH. 140. As shown above, all channels of MSM 6258 can be used for external RAM efficiently. OVF pin of MSM 6258. OVF pin of MSM 6258 outputs H level when input signal exceeds 80% of dynamic range. However, human voice peak has extremely large amplitude as compared with the average, so even if H level is outputted from OVF pin, average power of voice is occasionally too small and the playback signal is noisy. Therefore, usage of OVF pin be avoided. Pin connection for MPU interface. Following pins must be grounded for MSM 6258 VRS. 1 STSP5. TRS1. 2 Resupply 6. TRS2. 3 VDS7. Pause. 4 TOS. V. GND. 141. dash 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 dot dash 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 dot dash it 2 MB DROM module LFI start/stop E11111 I lie IT I 2 mic preamp OVF/FST plus dash 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 equals rec/PB I ven switch functions R dash 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 R dash 1 degree DD.DDD D7 dash MSC 2304 dash 15 YSBLKSB dot M equals dash SWI recording or playback sampling YCKPWRAMP SW2 ISW3 sampling frequency clockout SW4/SW5 ISW6 channel select IOP-F PBI commences start or stops operation F XTDAU PB2 sets the pause mode IOP-F equals _ PB3 causes flag reset XTPB mon PB4 initializes the chip 4.096 MHz Rec M3 and decoupling capacitors C 0 IUF Cal CA3 start/stop dash 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 IL dash dot JL dot IL _ rec/play dash _ slash rec 1 _ play I operation timing N LRRGI J2X 4069 MSM 6258 interfaced with DROM module minimum configuration 1 speaker .j n LTLSTART/stop 111111 2 AO RH 07 06 05 04 SI J IIC/PB mic preamp OVF/FST LPF ven switch functions SWL recording or playback sampling SW2 ISW3 sampling frequency clock OU dot I D3 02 01 do SW4/SW5/SW6 channel select 10 PF PWRAMP PB2 sets the pause mode 10 PF equals PB3 causes flag reset XT PB4 initializes the chip 4096 MHz decoupling capacitors C 01 UF 1 QJL00 PB1 commences start or stops operation F XT CA1 CA3 start/stop rec/play dash 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 L _ I rec I play 1 operation timing MSM 6258 interfaced with 64K/X4 DROM minimum configuration speaker H C 4 A T SWLL SW21 SW31 SW41 SWSL SW6 pause start/stop 6x loc cal CA2 CA3 S2 SI rec/play /C J 4069 OVF/FST : ven switch functions I:6Y sampling. SW4/SWS/SW6 channel select clock out 1 up F. PB1 commences start or stops operation. PB2 sets the pause mode. PB3 causes flag reset. PB4 initializes the chip. CA1 CA3 start/stop. Rec/play. Dash, dash dash. Dash. L_. I rec I, play _I. Operation timing. File MSM6258 GSK. GP. FC5. F MHz. XT. XT. L1. DAUFL. Decoofen Kapactlers, C, 01 UF. 2x4069. MSM62S81 interfaced with SRAM, minimum configuration. 5V, plus. Stabilized 330. 330. SW11S2. 6x100K. Switch functions. SWLI SW2. Sampling frequency. PB1 commences start or stops the operation. PB2 sets the pause mode. PB3 causes flag reset. PB4 initializes the chip. Pause. Start stop. Channel 0 LI. CA1. CA2. LCA3. 2x4069. Sampling. Clock out. P10. 10 PFC:::J. 46 MHz. I. S2. S1. Rec/PB. OVF/FST. Playmon. VCK. XT. Lit. Start/stop. DAU. 5x MSM27128. 128 kbit TPROM. 64K to 512K types. Applicable. CE #5. L________ equals CE #4 CE #3 select. CE #2. CE #1. Decoofen capacitors, C, 01 UF. MSM6258 interfaced with EPROMs, minimum configuration. Operation timing. Dash. V. A13, A13. A8 A8. AD7 D7. A-do-do. Decoder VCC ERN. A15 TDLL DOL AD RAM. A14. MSM AD MSM. ADC 85A. WR82 C12. D18 D08 A7. LSTB MD. DSIGND. CE. OE. 0.00. X2. Dash. We. X1. L, L, L. L, 2IIFFF. FJ, FJ, FJ. A, CRA, I. 10-1, FJIU0. 1. A, U, 300. MCK. VDDF. T. RECM MSM 6258 VRSMPU. F. VRF. Play my IAD/EADF. XT, JW4B/38. 1L. C/L, N, QA. N, J. 6. FJ, 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 FJUC, FJ::::::::. R, FJOA FJWFO, LPFFFF-A FJ, FJ, FJA, I. Interface example with MSM80C85A. Remarks to the application circuits. 1. All bypass capacitors, C, 0.1 UF, should be mounted in close proximity to the relevant IC. 2. If the 4.096 MHz crystal were replaced by an SM Hertz type, the sampling frequency adjusted at pins S1 and S2 is proportionately increased up to the possible maximum of Fs equals 15.6 kHz. 3. When various sampling frequencies are to be used, the cut-off frequency of the LPFs must be related individually to Fs, Fc equals Fs/2x0.S5. For sampling frequencies up to S.0 kHz, the hybrid filters, type number ALP3B, Fc equals 2.6 kHz, and ALP4B, Fc equals 3.5 kHz, manufactured by Sachin may used. Timetable for application circuits at FOSC equals 4.096 MHz, 4 equals bit add. Total I/O times of application circuits. S1 S2 sample bit rate. SRAM DROM X1 DROM X4 EPROM. LL 4.0 kHz 16.0 kb/s23 sector 128 sector 64 SEC 40 seconds. HL 5.3 kHz 21,2 kb/s18 sector 97 sector 48 SEC 30 seconds. LH 8.0 kHz 32.0 kb/s12 sector 64 seconds 32 SEC 20 seconds. HH invalid //////. 4. The analog ground shall be separated from the digital and bonded together at a well-chosen system. Ground position. Use VSS1 and VSS2. The power rail to VDNAN, MSM625S, and the memory supply line should as well be separated in the interest of improved noise immunity, especially when using QDRAMs. High-level and low-level signal lines should be located as far from each other as possible. 147. OKI semiconductor. MSC 1161. Speaker direct drive amplifier. General description. MSC 1161 is a speaker drive amplifier IC designed specifically for watches and also for similar small system having a limited space and power supply restriction. This IC is used together with a speech SIN. These ICs are LSI. It receives a high impedance analog signal generated from DA converter section of the voice synthesizer LSI and directly drives a low impedance voice coil of a speaker. Features. Driven by a single power supply of plus 3V. Input impedance higher than 1 mO. Output impedance lower than 10 O. Speaker output enable function. 2 built-in voltage doublers for VDD and 2 VDD. 4 external capacitors higher than 0.1 ILF are required. Block diagram. VU. VSS. OAU. T. T. VSS. OAL. VU. R. VSST. MSB. SID. VSS. SPE. VCK. BO. Loud. LD. 148. By CMOS device technology. Class B amplification. Input terminal pins and levels are compatible with those of MSM6202. Chip, 18-pin plastic dip, 24-pin plastic flat. Speaker. $out. Colon. EOUT. O. VSS. Double. Wound. EOUT. VSS. VDO. Co equals 0.1 ILF or higher. Pad layout. Y. 16. 4567. 11. 10 plus. X. 9. 8. Note, chip size, 2.95 mm x 2.65 mm. Pin configuration. Top view, 18 lead plastic dip. SPE. VCK. Loud. Low. Bow. SPE. SPE. VU. VU. Pad location. Pad no. Symbol. Position. XY. 1 dal minus 1325 minus 655. 2 dau minus 1325 minus 835. 3 msb minus 1325 minus 1175. 4 sid minus 865 minus 1175. 5 vo plus 365 minus 1175. 6 vcp plus 925 minus 1175. 7 vcm plus 1325 minus 1175. 8 2 vdd plus 1325 minus 755. 9 vss plus 1325 minus 295. 10 vdd plus 1325 plus 23. 11 vdd plus 1325 plus 203. 12 sp8 plus 945 plus 1173. 13 spc plus or minus, plus 325 plus 1173. 14 bd minus 925 plus 1173. 15 ld minus 1125 plus 1173. 16 lout minus 1325 plus 1173. 17 vck minus 1323 plus 355. 18 spe minus 1323 plus 133. Top view, 24, lead plastic flat package. OAL10 SPE. OAU2 VCK. NC3 loud. MSB4 low. SID5 bow. NC6 NC. VCO7 SPE. VCP8 SPG. VCM9 NC. NC NC. 2 VUVU. VSS VU. 149. Electrical characteristics. Absolute maximum ratings. Characteristics symbol test conditions ratings unit. Power supply voltage VDD TA equals 25 degrees Celsius minus 0.32 plus 5 V. TA equals 25 degrees Celsius. Digital input voltage VIND MSB, SID, SPE, minus 0.32 VDDV. VCK, BD, LD. Analog input voltage VINA. TA equals 25 degrees Celsius. Minus 0.32 VDDV. DAUDL. Output current loud TA equals 25 degrees Celsius O to 150 mA. Storage temperature TSTG, minus 55 to plus 150 degrees Celsius. Power dissipation PO TA equals 25 degrees Celsius 200 max MW. Operating ranges. Characteristics symbol test conditions range unit. Power supply voltage VDD, plus 2.4 to plus 3.3 V. Operating temperature top air, minus 10 to plus 60 degrees C. Analog input frequency FIN, 0 to 8 kHz. Effective analog input, VCL. Load dependent. Voltage per graphs of Fig 1 auto VDDV. And 2. Output current lout vein equals 0 to VDD0 to 80 mA. VCK input frequency FVCK, 2 to 8 kHz. 150. DC characteristics, Ta equals -10 to +60 degrees C, VU equals 3.0 V, tip is at 25 degrees Celsius. Characteristics symbol test conditions min tip max unit. Input high voltage VIH. MSB SPE, VCK. 2.5, V. BO, low. Input low voltage VIL. MSB, SPE, VCK. 0.5 V. BO, low. Input high current IIH. MSB, SPE, VCK. 1 ILA. BO, low. Input low current IL. MSB, SPE, VCK. -1 ILA. BO, low. Input VS. Output error. VE. VEN. Voltage RL equals 100 N. Analog input current IINA VEN equals VU, 3 ILA. Switching transistor serial. YS, 10 N resistance. On output voltage vol. Lout. 0.4 V. I sync equals 10 mA. Off output leak current lower. Lout. 1 ILA. VO equals VU. Current consumption 100, 1. Active at 1 mA. 8 kHz FVCK. Current consumption 100, 2. Standby. 1 ILA. VCK equals SPE equals OV. Pin description. Terminal number. Pin name. Chip 18 DIP 24 FLT. IO. VU 101013I. VSS 9912I. Power supply. In general, a 3V line is connected to pin VU and a 0V line to pin VSS. Note that the power supply current needed is determined in most part by the current flowing through the external load. It should be also noted that the internal impedance of the power supply must be sufficiently smaller than the load. Impedance. OAU. OAL. MSB. 2. 1. 3. 2. 3. 2. 1. 4. O. O. IO. The former two pins correspond to the positive half wave and negative half wave of the analog signal. Output of the OA converter in a speech synthesizer LSI, for example, OKI's MSM6202, respectively. It should be stressed to note that in using any LSI, the VU and VSS must be in common with the preg. In LSI, the OAU means the positive half wave of the output analog signal and the OAL is the negative half wave. The following illustration shows a relationship of the MSB pulse with the OAU and OAL waves. 151. Original signal. Positive. // Negative // I. I. U. L. I. DAUI. I. Positive I. Half side, I. 1/ I. Dal. MSB. SPE 181824. Speaker enable input. MSB-+H. MSB-+L. Center. VDD. VSS. VDD. VSS. MSB-+L. MSB-+H. Used to make the internal circuit active when voice is produced. This feature is so effective for power saving that the internal circuit is designed to fairly reduce power consumption when no voice is produced. To enable the speaker at all times, make the pin level high by connecting pin SPE to VU or H as shown in the truth table below. Truth table: i.e. state, high active, low standby. 152. Terminal number: pin name 110. Chip 18 DIP 24 FLT. VCK 171723I. Voltage doubler clock input. Has a 2 to 8 kHz pulse input. This input is not needed when no voice is produced. It, however, is required for a period of time for at least 8 VCK pulses before starting voice input from the pins DAU and DAL. The reason is that the two VDD and VDD voltages of the internal voltage double circuit should be stable. List previously. _FI. SPE. ___________, 1 input start // END. VC dash. Dash, FFIJLJL. I. 8. KI. 2 VDD8811I. VCP668I. VC0557I. VCM779I. VDD111114I. 2 voltage doublers. Additional capacitors should be externally connected as shown in the preceding block diagram and 18-pin terminal identification figure. With a specific frequency input from the pin VCK, a doubled vol tage, 2 VDD, and negative voltage, VDD, will be obtained. It should be noted that the both voltages are for internal use only. BD 141420. Buzzer drive input. Has a usual square waveform input when no voice is produced, to make the voice speaker sound as a buzzer. For this purpose, should be as follows. SPE input, low, standby state. BD input. Connection diagram, for single wound speaker. L. MSC 1160. Ju1JLIL. Registered NNN. Copyright --.j/UUL. /specific frequency when buzzer mode. Normal, no buzzer, level. 153. Terminal number. Pin name. Chip 18 DIP 24 FLT. 1/0. LD 151521I. Loud 16162220. Lamp drive input, lamp drive output. A simple independent lamp drive circuit for watch is built in. If a high signal is applied to pin LD, it turns on the NPN transistor, the open collector of which makes low output signal at pin loud, thereby turning on the lamp. SP, F. SP8. SID. 13. 12. 4. Speaker output single double wind select. 13. 12. 4. VSS. 18. 17. 5. O. I. The former two pins are connected to the speaker to directly drive in Class B amplification. For a speaker having double wound voice coil with a center tap, a voltage of VSS is applied to pin SID as shown in the preceding figure of the internal block diagram and 18-pin terminal identification. The voltage LEF L to be applied to pin SID is charted below. Speaker used voltage input level at SID. Single wound type high, or open. Double wound type low. 154. Relation between input voltage and voice coil current. DAU. Ven. Step 1, relation between ven and vout. 5. CSW.tr. VSS. ELOUT. Vout. iCoil. Gout. Load, voice coil. R. Coil, DC impedance. L. J. 5. Internal serial resistance of the switching transistor. The Class B amplifier shown in the equivalent circuit above can satisfactorily follow up the input sig. NAL because its frequency is relatively low. A. If ven is lower than VU. Ven equals vout plus VOFSET. 1. Where VOFSET represents the offset voltage of the amplifier which is lower than 10 mV. In view of the fact that ILSB, input least significant bit level, of ven, DA converter output, is 10 mV, the offset voltage, VOFSET, can be ignored. The ILSB is given as ILSB equals 2.5 V/28 equals 10 mV. Hence, EQ1 can be regarded as ven equals vout. 2. B. If ven approaches to VU. As long as ven. If vel ven VU, the following relationship is given. Ven corresponds almost to vout in the amplification as described in A. If ven is made to approach VU, the upper limit of the output voltage, vout, of the amplifier fixes to the clipped value, vel. Hence, in the region of vel ven VU, vout equals vel. 3. This equation means that vout has no relation to ven. 155. See graphical illustration. The two operational cases, A and B, mentioned above are illustrated in graph below. VU. VCLA equals B. VCL VU ven. D relation between VU and VCL. The clipped voltage, VCL, for a specific power voltage, VU, can be determined according to the characteristics of the driver elements in the amplifier. The MSC 1160 is designed to have such load characteristic lines as in Figs 1 and 2. According to the load characteristic lines, VCL can be determined uniquely together with iCoil, denoting the current flowing the voice coil, with a serial resistance of the voice coil as part of a parameter. The designer should take the condition for iCoil and vout in designing the voice coil. The condition will be explained in the following paragraphs. Step 2, relation between vout and iCoil. A. If vout is lower than VCLJ.E, vout. If ven is rather small, vout is not clipped by VCL yet. Relationship between vout and iCoil is given as iCoil equals ICO/OTYS. 3. Where YS is the internal serial resistance of the switching transistor, and iCoil is the serial resistance of the voice coil. Since YS is around 5N as the switching transistor characteristic, if iCoil can be ignored in comparison with YS, then EQ3 can be modified as iCoil equals voucher T. 4. YCoil. B. If vout is clipped to VCL, i.e., vout equals VCL. The voice coil current, iCoil, can be given by iCoil, VCL. 5. YCoil. 156. See graphical illustration. The two operational cases, A and B, are shown in Figs 1 and 2 for obtaining the voice coil current, iCoil. For using the graphs, refer to the illustration below. Coil. Region 1 corresponds to EQ3 or 4. Vout equals VTN. Region 2 is a range where vout and iCoil are clipped to VCL and ICL. 157. 158. T. RNA. Lcal. 100. 90. 80. 70. 60. 50. Example 1 for 50 N load. Vout equals VCL equals 25V. ICL equals ICL equals 50 Ma. Example 2 for 66 N load. 40. Vout equals VCL equals 26V. ICL equals ICL equals 39 3 RNA. 30. 20. 10. 10 15 20. Fig 1 determination of iCoil vs. Vout with parameter of iCoil plus ys at 2.4 V of VDD. V. Vout. T. Ma. Leo 2. 100. 90. 80. 70. 60. 50. 40. 30. 20. 10. 10 15. Example 1 for 50 0 load. Vout equals VCL equals 19V. Leal equals lay equals 38 Ma. Example 2 for 66 0 load. VOU equals VCL equals 20V. ICL equals ICC equals 30 Ma. 4-_V. VOD. Fig 2 determination of iCoil vs. Vout with parameter of iCoil plus ys at 3.0 V of VDD. 159. Appendix. Application notes. MSM5205 voice synthesis circuit example. An example where 2764 devices are used linked together is shown in Figure 1. The timing chart for this example is provided in Figure 2. MSM 4025 100 220 L _ 147p 680p 470 MSM 4556 plus 470 20K plus 47. Note, the 2764 data conforms with the data analyzed and written by Speech Analyzer. The power supply is 5V for the 4000 series, and for 5205 and 2764. Fig 1 MSM 5205 voice synthesis circuit example. 163. M5 205 VCK. JLJ1.J1JLLLFLF. Start SW. .jll underscore 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 M4013 SI 1 underscore 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 dash M4013 chi I M5205 reset, underscore underscore I. M4013NNNN, underscore 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 underscore, underscore 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 N. 4 low order bits, LLJLJLJL.jl. 4 HLGHORD, FZBLTS, dash dash. M404001. Dash. 02. L-rl. 012rl underscore 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 s. M4520 Q1 AIL. Q1B. IL. JL. Q2BI. Q3B. L. M4556Q, dash 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 1. Chi L underscore 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 S. Q2L underscore underscore S. Q3. L underscore R. Fig2 MSM5205 Application Circuit Example Time Chart 164 OL 11 AM cell A RAM cell B IUOK Fig3 MSM5218 Voice Analysis / Synthesis Circuit Example. When MSM5204 is used, EG_S CS SJXL F 11 OCS CDX_U1 COOLOLI /J3 5L0 2 SO 0LG22 J dot 0 J10L I J1J-0 OL__0 N 0 N T 00L ETT J J S dash 11 dash cock C 0_ WO 1 2 CD0 TTCD 30L CDJ T Olin C Ren _OL 0J 0 N T 5LJ CD T 0 dot J Sen TCNN OLS Coco L L 2 I F T I N 3 O C M 3 TJ C I T I L S F S U1 I /G 3 Power on JRFF I Reset -1 IL-JH Internal rest $I 5218 Reset 1 RI VCK Start Q Q2 Q Q Q5 166 J J UUU ILUUUU _NLN _N_______ 12 pulses __FF____ I1 UII 450 kHz 11-111-111-111_001 111-112 pulses 11 000 111 00 .1 limel 11 001 _______0008 ______XL _____XL____XL____ HTHL_____IR TLTLL RS L Fig.4 MSM5218 Voice Analysis Time Chart Power on Initial 1 / Reset -J H _____________ internal reset -J1 RRF 5218 reset start VCK Q IFF -LLF _______ I1 ILI _ sent equals sent. RAM. Address. Do, doubt. AEI. AE2. Underscore 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 T dash dash IT dash dash. FF slash dash T plus. If 0 I17. FJL slash slash, I slash 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 LIJLILJA underscore X underscore X. R. Output. Underscore 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 I. Underscore 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 dash dash 1 IH underscore IHL. IIT. 1 dash 1 underscore underscore. FFL. L. Fig.5 MSM 5218 voice synthesis time chart. 167. MSM 5218 voice analysis / synthesis circuit example, when 12-bit AD converter is used. An example of an application circuit for voice analysis and synthesis using MSM 5218 and a 12-bit AD converter, ADC-ADAG is manufactured by *MN Co. Is shown in Figure 6. The time charts for these circuits are given in Figures 5 and 7. Micro Network Corp. 168. M. 5V. JL. I. Plus 15V. T. HT. J. 11 III. AOLAEA3 as AOAO. MSM 5128111 VU. I/06 I/04 VIVSS. I/03 I/JL. JJJ. T. 6. 7W. 8. So. 1. VU. E. R11. 2B2 initial 3B3. Reset 4A, B4. 5B5. 6B6. 7CJJB7. 8. B8. So underscore. Reset I. To MSM 5128 CSASA/LL. It dash. 1, 2, 3, 4, 5, 6, 7, 8, VSSAE sent I. Look. 1, 2, 3, L. T77. Ramsel. A. Look. Ramsel. Point 1, B. OI234J67. VU. SLROBE MSM 4515. Inhibit. GND. IACF, dot. II. ALA 1A, AIATM/V, :.AIO. WSMSM 5128 121. CS. N2. ISSSSSSSSI. MSM 5128 131. 11. 15JSJ5 IL. MSM 5128 141. LJ. Look 0, 2, JQJ or OJOLP1L012. Sent MSM 4040 Vim. N. OJ, 20:1. Sent MSM 4040. JFLL. I. 1, 2 JJ. Fig.6 MSM 5218 voice analysis / synthesis circuit example. When 12-bit AD converter is used. JJ. Dash equals. Power. Initial A. Reset dash 1. Underscore R. 111-1 111-1. Underscore 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 JR. Underscore 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 dash H dash I. L. L. L dash 2. dash 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 1 r dash 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 1 170 Fig.7 MSM5218 voice analysis time chart when 12-bit AD converter is used. Example of interface between MSM5218 and an external DA converter. An example of an interface circuit between MSM5218 and an external DA converter is shown in Figure 8. The time chart for this circuit is given in Figure 9. Connected to 12-bit external DA converter. Note 1. MSBR-LSB. MSM5218. VDD. O.E MSM4094 SENIL MSB/SO. GND. Strobe CLK SOC. Dash, dash dash dash. C, dash dot H, comma slash L dash dot J1 dash underscore plus underscore 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 dash. Q3. MSM4015. Reset. Q, CL dash 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 VCK. GNDDATN. Note 1. The 12-bit output is in regular straight binary code. Fig.8 MSM5218 to external DA converter interface example. Reset input. VCK. 5218 reset. A, Q3. Dash equals R. B, or output. C, STROB underscore 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 if dot L underscore 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 L underscore underscore L underscore 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 L underscore 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 dot J underscore. Expanded time chart for interval A. External DA converter. Operation interval. XT, 384K. VCK. SCON. MSB/SO. SOC. Dash dot J, colon underscore 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 equals 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 colon dash LJ dash dash III dash underscore 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 LSB underscore 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 underscore. Fig.9 MSM5218 and external DA converter time chart. 171. Example of MSM6258 application circuit. An example of an application circuit which MSM6258 is used with 664K SRAM. Devices for voice recording and reproduction is shown in Figure 10. Fig 10 MSM6258 application circuit example. The time chart for Figure 10 is given in Figure 11. CAICA3 equals colon 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 x equals equals underscore 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 start stop it underscore underscore dash underscore 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 rec/play recording point 1 reproduction. Fig 11 MSM6258 time chart. 172. MSM5248 and LM380N, power amplifier, interface example. An example of interfacing with LM380N to achieve a high volume output from MSM5248 is outlined in Figure 12. 3V 12V Push 10K 10K SW O.LU J Load SP plus 5248 SP Test O.LU AC AL A 27.3-5.10-12 GND DTL-32.768 kHz 22p I122p. Fig 12 MSM5248 and LM380 interface example. Note 1. The MSM5248 and LM380 and ground pins are connected to a common ground terminal. To use SP and SP pull-up resistances of about 20 ohm when an external VREF resistance of 500 Koni VR is used. 3 LM380N is manufactured by the National Semiconductor Co. 4 The MSM5248 outlined in Figure 12 shows load input activated with no AO pull-down resistance. 173. MSM6243 switch input interface example. An example of MSM6243 switch input interface is shown in Figure 13. And the time chart for repeated vocalization of a single word is shown in Figure 14. VDD AO VDD TJ AL T2 A2 SD3 A3 SD2 SDI A4 S2 A5 S/P A6 MSM6243 MSB TVDDCR SPE Load VCK Busy/NAR T DAU VSS DAL ACV XTXT-VSS/LA DDSLB VSS. When a class is selected. Note, unused input pins from among AO through A6 are to be connected to VSS. 174. Load NAR Busy SPE VSS. Fig 13 MSM6243 switch input interface example. X F FFT hashtag dash.jr bad applied LL dash F : low _ D not applicable. D. Approximate 1.1 millisecond. RRF _ +-- R. J 0.15 millisecond. APJ rocks 0.1.0 I _MSEC. FF dash. B equals : I. No sound. Standby F vocalizal dby. IE dot. DAU or DAL output. Approximate 1.5 millisecond, approximate 0.4 millisecond. Equivalent to 3 samples. Fig 14 MSM6243 switch input timing diagram. Example of MSM6243 and MSM5055, watch CPU, interfacing with MSC1161. An example of MSM5055 interfacing when MSM6243 is used in time. Announcing watches is outlined in Figure 15. MSM5055 L18. XT. Open. FT-+F++-. USDO SD2 SD3 bonding. Sol slot op T ion. VDD. 5 lb. Solo. 32,168 kHz CL. M4F-AO. M31-_law. M21-_I-IA. Me law. L21-_IA. LEA_LA. LOF. MSM6243-02. SPEI plus dash, JSPE. 5 to 35 PFV, MSC 1161. DAUI plus. Dolly plus dash. Note, if bonding on chip, make sure that MSC 1161 is begin IND, isolated from MSM 5055 and MSM 6243. See accompanying diagram. Cobb example. \sj. Lamp. Fig.15 example of MSM6243 and MSM5055 interfacing with MSC1161. 175. MSM6243 microcomputer interface examples. MSM6243 has been designed with due consideration given to microcomputer interfacing, thereby enabling simple voice editing, etc. The method for interfacing MSM6243 to a microcomputer is described here using the well-known Centronix parallel interface as an example. Normal centronic interfaces consist of handshaking by busy and strobe lines where 7 or 8 bits of data are passed via the 00-07 data line for accurate transfer from microcomputer to external device, such as a printer. That is, the microcomputer first places the data to be sent on the due D7 line, and after checking that the external device is not busy line at L level, applies positive pulses to the strobe line. The external device subsequently detects pulses on the strobe line and proceeds to accept that data. An H-level signal is passed to the busy line until the external device completes acceptance of the pulses and is prepared to accept the next set of pulses. In this way, a single item of data is transferred, and where necessary the next item of data is transferred in the same way. MSM6243 is equipped with a load pin and a busy INAR pin, user selecta BLI, which correspond to the above strobe and busy pins. Furthermore, MSM6243 is equipped with AO, as pins which correspond to the above data line. Vocalized syllable codes are applied to the AO as pins. The microcompute ER is notified whether this input code has been enabled or disabled at this time. Via the busy/NAR pin, enabled when H, and disabled when L if NAR has been selected. When enabled, a positive input pulse is applied to the load pin. Upon input of this code, the busy/NAR output is switched to L, if NAR has been selected, thereby disabling subsequent input. And almost at the same time, the sound corresponding to that syllable code is vocalized. And if input of the next code during vocalization of that syllable is enabled, the busy INAR output is switched to H, if NAR has been selected, in readiness for input of the next code. Do D7 underscore 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 O underscore A underscore T underscore A underscore 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 O underscore A underscore T underscore A underscore 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 strobe busy. Fig 16 Centronic interfaces in /out timing. 176. In this way, sounds can be vocalized by MSM6243 in much the same way that characters are printed by a printer. The flow for vocalization of a single syllable code is outlined in Figure 17. And since MSM6243 is equipped with two buffers for storing syllable codes, editing without interrupting syllables is possible. Single syllable vocalization output routine flowchart assume that reset has been cancelled by main routine. Assume that syllable codes are obtained from the main routine. Start dash NAR output monitoring 1/0 status input syllable code output to AO as pins. H applied to load pin. Strobe output to control board 1. L applied to load pin. Strobe output to control board. No. Underscore 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 OJ. Wait until NAR becomes H. Load pulse application. Fig 17 single sound output routine flow chart. 177. Example of MSM6212 interfacing with an op-amp. Class B operation. An example of MSM6212 interfacing with an op-amp used in Class B operation is shown in figures 18 and 20. 1. Example of circuit where the op-amp plus power supply is used apart from the MSM6212 power supply. VDD DAU-1-0K 10K DAL I plus dash I dash dash plus dash YI dash dot connection to LPF VSS 10K Fig 18 MSM6212 and op amplifier interface example 1. 2. DAU and DAL output waveforms and the LPF input waveform in the above example. DAU OVT \F N DAL OVC \D LPF OV CVF \P Fig 19 Class B operation output and input waveforms. 178. 3. Example of 5V single-phase power supply circuit for both MSM6212 and op-amp, LPF, VSS. Fig 20 MSM6212 and op-amp interface example 2. Note, ensure that the op-amp is operated in this case, begin end, with an input voltage above 0V. 179. MSM6212 switch input interface example. An example of MSM6212 switch input interfacing is shown in figure 21, and the time chart for repeated vocalization of a single word is shown in figure 22. VSS AO AL A2 A3 CS load NAR busy VDD VDD MSM6212 TL T2 SD2 SDL SDO S/P MSB SPE VCK V DDL JO plus dash underscore 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 L AC DAUI DAL VDD SLA SLB XT VSS VSS VDD VSS Fig 21 MSM6212 switch input interface example. AO A3 : X F T load underscore I if load applied L load not applied NAR dash dash busy dash dash dot J F SPE DAU or DAL output standby F Asian J dash : dot standby E approximate 1.1 millisecond equivalent to 9 samples. Fig 22 MSM6243 switch input timing diagram. 180. Example of MSC 1161 interfacing with voice synthesis LSI. An example showing how OKI voice synthesis LSLS, MSM6212, MSM6243, are connected to MSC 1161, speaker driver IC, is given in figure 23. Note that a speaker with impedance of at least 30 ohms should be used. VDD SPE VCK VCK low SPE LD MSB5 test Rs BD DAD MSM6212 DAL \0 VC1 or VCP0, MSM6243CF, VCM, 2VDD VDD, VSS VDD, /SS/SLA VDD SLB, VSS, DD. Note, all capacitors are 0.1 JLF min. Fig.23 example of interface between MSC 1161 and voice synthesis LSI. New Jersey. 30 ohm. MIN. 181. Examples of inexpensive voice synthesis LSI output circuits. The following circuits are examples of inexpensive voice synthesis LSI. Systems constructed with fewer components in the output circuit. 1. MSM5248 output circuit example. 182. An output circuit example is shown in figure 24, and the waveform of the output from the SP plus pin is shown in figure 25. A good degree of clarity is obtained with the waveform shown in figure 26. LK SP B MSM5248 VSS 2SA1015/2SA952 etc. Fig 24 output circuit example. VDD. Fig.25 output waveform from SP plus VDD VSS. Fig 26 output waveform from SP plus when deconverter. Accuracy is set to 9 bits. 2. Example of voltage type deconverter output circuit. An MSM6243 output circuit is shown in figure 27 as a typical example of a voltage type deconverter. The LPF cutoff frequency, C010, can be changed by changing resistance and capacitance. VDD. MSM6243. DAUIJ /IO-. Fig.27 MSM6243 output circuit example, for Class A operation. 3. Example of interfacing with regular audio amplifiers. An interface example where the speaker is driven by a regular audio amplifier to achieve volume levels greater than that achieved by MSC 1161, is shown in figure 28. Although the circuit shown here includes a CR-type LPF C010, resistance in excess of 500 ohm is to be inserted between DAU and the audio amplifier input terminal even if the filter is removed. The reason for this is that the DAU output impedance varies considerably from -50% to +100% of the typical value due to ambient temperature conditions etc. The purpose of the resistance is to protect the audio amplifier output volume level from the effects of these changes. The audio amplifier used should have a voltage gain of at least 40 dB. MSM6243 VSS 330K 330K DAUJ /AJ /+ YJ CR-type LPF. Audio amplifier examples. LA4140/LA4180/ M51501L1 M51180L etc. Audio amplifier. Fig 28 example of interfacing with regular audio amplifier. 183 Voice synthesis LSI library. Apart from custom order devices for specific user requirements, the following library of general purpose voice synthesis LSLS, with built-in ROM, is available from OKI. OKI plans to further expand this library, and welcomes suggestions from its customers. Voice Synthesis LSI Library, as of August 1987. Device vocalized phrase. MSM 5248-01 Happy Birthday, English. IA1:1. MSM 5248-04 Fanfare I2 Sound. W equals. MSM 5248-05. Merry Christmas and a Happy New Year. English. MSM 5248-09. Irasaimasu, arigato gozaimashita. Japanese, welcome, thank you. MSM 6243-02 Time announcement in Japanese. MSM 6243-21, under development, time announcement in English. 184. Q&A. Q11 What is the relationship between the vocalization time and quality in build? In ROM voice synthesis LSLS? IA1I. Parameters involved in determining vocalization time and quality include the sampling frequency, ADM word length, and the degree of data reduction when a compressed ADM method is used. These parameters are described below. 1. Sampling frequency. The vocalization bandwidth where voice can be synthesized is determined by the sampling frequency. According to the sampling theorem, F-band equals FSAMPLE x 1/2, where F-band is the upper limit of the frequency passband and FSAMPLE is the sampling frequency. The effective bandwidth, FBANDEFF, where the ADM method response, see figures 33 and 34, and the LPF used are considered can be stated as F-band F equals F sample x 112 x 0.85. The hearing evaluation for different FSAMPLE values are listed in Table 1. Table 1. FSAMPLE bandwidth hearing evaluation. 8.2 kHz DC, 3.49 kHz very clear sound including almost all vocalized sounds. 6.55 kHz DC, 2.78 kHz high tone female voices sound as if the nose is blocked up. 4.1 kHz DC minus 1.78 kHz. Both male and female voices sound as if the nose is blocked up. The blocked up nose sound is due to elimination of high frequency components normally included in the human voice. Since high frequency components are prevalent in constants, and in the I vowel, the effect is stronger at lower sampling frequencies. In determining the sampling frequency, it is better to decide the most suitable value after listening to the source voice passed through a LPF. 185. 2. ADM word length. The ADM word length is related to the SYN ratio. The 4-bit ADM method is fewer than the 3-bit ADM method by about 6 dB. 3. Degree of data reduction in compressed ADM methods. The quality of sound varies according to the degree of compression in compressed ADM methods. In compressed ADM, data can be compressed to 1/3 of the data used in straight ADM. Needless to say, the greater the degree of compression, the poorer the quality of sound becomes. The degr.ee of compression is selected according to the intended purpose. 4. Vocalization duration and quality of sound. 0. C. O. / An example of the relationship between vocalization duration and the quality of sound as determined by the above parameters when MSM 6243 is used is outlined in Figure 29. 8.2 kHz sampling in straight ADM method. 8.2 kHz sampling in compressed ADM method. 0. Pound. M. A. 186. 20. Vocalization duration, section Fig 29 relationship between vocalization duration and quality of sound. The quality of sound is depicted as a range in the compressed ADP method. In Figure 29. This is because the quality of sound is also dependent on the quality of the source sound vocalized statement specifications. And since the quality of sound cannot be expressed in absolute terms, it is shown here in relative terms. 5. Examples of calculating the vocalization duration. An example of calculation of the maximum vocalization duration in straight ADP for MSM 6243 at a sampling frequency of 8.2 kHz is given below. 193,584 bits-7, 8.2 kHz x 4 bits, equals 5.90 section. 111. Built-in ROM. Capacity. FSAMPLE ADP word length. The reason why the built-in ROM capacity is not 196,608 bits equals 192 kbits x 1024 bits/kbits is because the user will have a certain amount of area where use is disabled. 187. IQ 21. Although there is a certain amount of variation in the precision of the MSM 5205 and MSM 5218 deconverters, are there any methods for improving the SYN ratio? IA 21. Yes. In terms of configuration in the above two deconverters, it is possible for the voice waveform precision to fall in the vicinity of the center waveform. Therefore, the SYN ratio can be improved by displacing the center of the waveform either up or down. This method is particularly effective in improving the SYN ratio for low-level signals and in minimizing the residual noise during silent periods, such as the intervals between successive words. In practice, the waveform center can be shifted by adding additional data before or after the current ADP data, voice data, as indicated in Figure 30. Section A. 0000 0000. Section 8. 1000 1000. Example where the ADP bit length is 4 bits. 100 items of data. Since an offset of about 5 MV per 2 items of data can be obtained in this case, shifts of about 250 MV will require input of some 100 items of data. The shift is upwards in A, and downwards in 8. The number of data items should be equal in A, and 8. The output waveform obtained when A, isolated at the start of the voice data and 8 is added at the end is shown in Figure 30. Note that since the dynamic range is compressed in the shifted sections, overflow may occur in some cases depending on the data, and this can result in clipping of the output sound. Reduce the sound pressure by about 20% and repeat the analysis. See 03 for additional information about overflow. Voice data section. Fig 30 deconverter output waveform. I. TVDD. 25B. Note, there must be less voice data immediately prior to section 8. Input of some 20 to 30 millisecond of silence prior to the beginning of the voice is recommended. 188. I. Q31 when ADP data analyzed by MSM 5218 was used in voice synthesis by MSM 5205, noise was generated in the synthesized voice. How can this be overcome? There was no noise in the output from the MSM 5218 DOUT pin. IA31. The analysis must be repeated. This is because MSM 5205 is not equipped with the overflow prevention Circuit featured in the MSM5218 internal computing circuits. Although sound synthesized by MSM5218 may be normal, overflow can occur during synthesis by MSM5205, resulting in the generation of noise. In this case, the data must be re-analyzed and the ADM data regenerated. An example of a waveform where overflow has occurred, and a method for avoiding this overflow are outlined below. 1. Waveforms where overflow occurs. Observation of the MSM5205 deconverter output waveform by oscilloscope shows the occurrence of an overflow. See Figure 31. Overflow section. Fig 31 output waveform when overflow occurs. 2. Method used to avoid overflow. Even where the input waveform does not exceed the dynamic range when analyzed by MSM5218, output overflow can be generated by internal calculation error. Therefore, even if the input amplitude level reaches a maximum when analyzed by MSM5218, keeping the level within 80% of the dynamic range, see Figure 32, will ensure that no overflow occurs in the MSM5205 output and no noise is generated in the synthesized sound. 189. 190. VDD. 9. 10 VDD. 1. ZVDD. 1. 10 VDD. O. Fig 32 waveform with amplitude kept within 80% of the dynamic range. What kind of frequency response is achieved in the output waveform in respect to OKI ADM input waveforms? IA41. The frequency response achieved in output waveforms when sine wave input waveforms are applied is outlined in Figures 33 and 34. Since these diagrams show the frequency response when 4-bit ADM data is used with an 8 kHz sampling frequency, an increase in the sampling frequency will result in a shift of the frequency response to the right. 1. When input waveform is a half-scale sine wave, 1/2 VDD VPP. 0. 3. -2. Q, N. C. 0. A. \n. -4Q. CC. -6. 100 200 300 500 700 1K 2K 3K 4K. Frequency, Hertz. Fig.33 OKI ADM frequency response, 1. 2. When input waveform is a full-scale sine wave, VDD VPP. 0. 3. -2. Q, N. C. 0A. -4N. Q, CC. -6. Dash. 1 \\. F. colon. 100 200 300 500 700 LK 2K 3K 4K. Frequency, Hertz. Fig 34 OKI ADM frequency response, 2. 191. 1. Oslo. What does it mean to say that the deconverter output from MSM6243 etc. is a Class A output or Class B output? 1. ASL. MSM6243 and other devices are equipped with 2 deconverter output pins DAU and DAL. In Class A output mode, the normal mode, the output waveform only appears at the DAU pin with the VDD/2 potential at the amplitude center to obtain maximum amplitude for VSS through VDD. Class B output mode is used in interfacing with MSC 1161, note the upper half of the waveform above. The Class A output amplitude center appears at the DAU pin and the lower half of The waveform appears at the dial pin with the main amplitude direction as the positive direction. The comparative waveforms are shown in figure 35. Where class B is multiplied by 1, the amplitude scale is twice class A level, and likewise class B multiplied by 2 and 4 result in class A multiplied by 4 and 8, respectively. In waveforms where the VDD level is exceeded, however, the output is clamped at V. Note, the method described in MSM6212 switch input interface example at page 174. 192. VUD. 3/4 VUIJ. 1/2 VU. Class A DAU. 1/4 6. MSH0. 1. J. _______ LSBL. VOV ++++. Class B X1V. 9-bit DAC, VILIJ. \::. Class B X2. 8-bit DAC. \::. Class B X4. 7-bit DAC. MSB0. Fig 35 Comparative waveforms. 193. 1 QSI What is the best way to form a sine wave? With MSM5205. Phi, ls by input of the following data values. The corresponding output. Waveforms are also shown. The data used is 4-bit data, in hexadecimal notation. 1. To obtain an output of 1.5 VPP. Use the following input data. 0,0,3,3,3,7F7F4C4C. Then 4,0,9C8,1 repeatedly. Fig 36 1.5 VPP output. 2. To obtain an output of 0.85 VPP. Use the following input data. 0,0,BBB7F7F4C0,0. Then 4,0,9C8,1 repeatedly. VDDI-T. Fig 37 0.85 VPP output. 3. To obtain an output of 2.6 VPP. 194. Use the following input data. 0,0,0,7F7F4C0,0. Then 4,0,9C8,1 repeatedly. Fig 38 2.6 VPP output. 1Q71 How should the MSM5205 and MSM5218 reset input timing be best set? IA71. The MSM5205 and MSM5218 reset should be input according to the following timing. Interna IIC ______________ I. Reset timing LJJJ-I. Fig 39 MSM5205 reset timing. R. 125/1 SEC-1. VCKJ1, 1-I. 78 USEC, 3XL/384 kHz, IL__L. Reset latch timing node. II. Reset II. Internal reset. N. Node. Fig.40 MSM5218 reset timing, 8 kHz sampling example. Note, the reset signal is latched within the LSI by the reset latch timing. Analysis is commenced by switching the external reset signal from H to L before this timing. Switching is probably best achieved by the leading edge of the VCK. Signal 195. I. QSIY is a low-pass filter required in the voice synthesis output. IASL. Low-pass filters, LPF, are designed to pass only those frequency components below a certain frequency when the input contains a number of different components. Since the voice synthesis output is obtained from a DA converter output, the output waveform is a stepwise waveform as indicated in Figure 41. Fig 41 DA converter voice output waveform. This waveform contains certain high-frequency noise components, and since the sampling theorem states that sampling is not effective unless only frequency components below half the sampling frequency are obtained, the unwanted high frequency components are removed by the LPF. The LPF output waveform is as shown in Figure 42. Fig 42 LPF output waveform. 196. IOSLO. How is the LPF cutoff frequency best determined? FF.ls. In an ideal LPF, all frequencies above a certain level are filtered out. In practice, however, frequencies are attenuated at a certain rate, slope, from a particular level. This slope is usually expressed in terms of dB per octave. dB/oct. For example, in a filter with a slope of 12 dB/oct, the output is attenuated by -12 dB, that is, reduced to 1/4, for each octave increase of the frequency, that is, each time the frequency is doubled. The frequency where the attenuation commences is called the cutoff frequency. Note: the best cutoff frequency for any situation will depend on the sampling frequency, the attenuation slope, and the frequency components in the source sound. The usual design criteria is the degree of attenuation, that is, how many dB, at half the sampling frequency, FSAM. A number of reference values are listed in Table 2. Since the optimum value as determined for the frequency components in the source sound varies considerably, it is best to decide on the basis of actual listening. Table 2 relationship between filter attenuation characteristics, cutoff frequency, and sampling frequency. Filter attenuation. Cutoff gain at diagram. Characteristics. dB/oct. Frequency 0.5 FSAM, dB, number. -12 0.3 FSAM, 8.7. -18 0.33 FSAM -11. -24 0.35 FSAM -12.5 CD. -48 0.38 FSAM -19. Although high-frequency noise components are attenuated more efficiently when the attenuation characteristics are sharper, a larger number of structural elements are required, making such a filter uneconomical. The filter frequency response when FSAM-PLE is 8 kHz is outlined in Figure 43 for reference purposes. 197. 0. -5. 3 -10. 2. S. A. -15. 9. -20. \_2 \_CD \____ I .300500 LK2 K3 K4 K5 K7 K. Frequency, Hertz. Fig 43 FSAM-PLE 8 kHz filter frequency response. Note, strictly speaking, the cutoff frequency is not defined as the point where attenuation is commenced. In Butterworth type filters, the cutoff frequency is the point -3 dB below the overall characteristics, while in Chebyshev type filters it is defined as the point where the maximum ripple width within the set passband first appears, where strict adherence to either definition is not required. The cutoff frequency can be assumed to be the point where attenuation is commenced. 198. 1Q101 is the configuration of low-cost filters designed for voice synthesis. Applications. IA10I. The most common types of active filters, filters with active elements used are the Butterworth, Bessel, and Chebyshev filters. Each type is used for different purposes. The Butterworth filter puts emphasis on the flatness of the passband and is less strict in terms of attenuation characteristics and transient response performance than the Bessel and Chebyshev filters. In the LPF used for voice synthesis, where the passband attenuation characteristics do not need to be perfectly flat, a Chebyshev filter capable of achieving sharp attenuation characteristics with a small number of component parts should be considered. Chebyshev filters can be designed with suitable ripple width and attenuation characteristics. Note that if the frequency response of the speaker rolls off at the desired cutoff frequency, the LPF will not be required. Configuration. A one-pole RC LPF where no active elements are used is shown in Figure 44, and the corresponding transmission characteristics can be expressed in the following way. I. Low. Feju, equals Li. Where 1 plus Wo equals 1. E. Wo 1. Or U0 equals 271 F0. 1. L backslash NV1F. Li. J. Low. II. Fig 44 1-pole RC LPF. Fa. Cut-off frequency. An FFJW plot is shown in Figure 45. The frequency response shown in this diagram is cut off at -6 dB/oct above frequency Wo, where Wo is the -3 dB value. 0. ID. -5. C. 3-10. C. -15. R. I. Dash. Dash. R dash. 0.3, 0.5, 0.7123345. With Wo. FLG.45 CR1 stage LPF frequency response. 199. The circuit configuration of a second-order Chebyshev filter is shown in Figure 46. Fig 46 second-order Chebyshev type filter. The transmission characteristics for this circuit can be expressed in the following way. L _2 RJ4ZR 1 421 1 dash plus J Evo Q 4 Evo. The active element used in this circuit is assumed to be an op amplifier voltage follower with a gain of 1 U 2 J Evo R 200. Higher order Chebyshev filter design. Even numbered higher order filters such as 4th and 6th order filters can be divided into second order elements. And odd numbered higher order filters such as 3rd and 5th order filters can be divided into second order and first order, CR1 stage passive filter elements. A 4th order filter, for example, can be divided into 2 second order element stages as shown in Figure 47. And by determining the Fn and Qn factors in each stage, the filter configuration can be easily achieved. Input second order output. Copyright dash, dash. Fig.47 4th order LPF. The attenuation characteristics of Chebyshev filters can be changed depending on the ripple tolerance within the passband. The Fn and Qn settings will also vary according to the tolerance. A list of Fn and Qn values for Chebyshev filters is given in Table 3 below. Table 3 Chebyshev LPFN HPFTN and Qn values. Ripple equals 0.1 dB, ripple equals 0.2 dB, ripple equals 0.25 dB, ripple equals 0.3 dB, ripple equals 0.5 dB. In Qn, in Qn, in Qn, in Qn, in Qn. Second. 1820-4497076593151966079664181453, 9722080925361391, 16670821081123, 141808637210 order. Third 1299902914902761188961214595, 50331156992115080264113218611552, 4768108685351706, 1895. Order 0969405705081463410507292773050625456505. Fourth 115326992183310310106381592627902010031270429429405542. Order 07892550618801064422306572494065324280867780030597002407051102. Fifth 109313282014110570753370685861046410461406858610465337 13860118360110177454549633. Order 07974460091452150747258107907324054103593190720755310675310674. 897907207553310767 8056. 053891430504695050469441712910503623196050. Sixth 1062-726146329012100381124255520416412025 5981574740761011445965128456. Order 083440331570708030621149171870793854215555, 6533078668301613, 59590768121218103772. 05131875059946062806370268063046270294064729240396229006836390. The 05 asterisk in the QN column denotes CR1 stage first order. 201. Example. The following example shows how a fifth-order Chebyshev filter would actually be designed. A ripple tolerance of 0.5 dB is assumed. The circuit diagram is shown in Figure 48. First stage second order, second stage second order, third stage first order. Fig 48 fifth order Chebyshev LPF. The Fn and Qn values have already been listed in Table 3. Where ripple 0.5 dB for a fifth order filter, the first stage second order Fn equals 1.0177347 and Qn equals 4.54496333. The second stage second order Fn equals 0.69048332 and Qn equals 1.1778056. The third stage first order Fn equals 0.36233196 and Qn equals 0.5. The constants can thus be calculated using these values. Begin IND, A. Cut-off frequency of 2.8 kHz is selected. This value is then substituted in equations introduced earlier for calculating first and second order constants. First stage second order. Assume RF1 equals 51 cohm. F0 equals 2800 x 1.0177347 2850 C Hz. 2Q 2Q and 2x 4.54496333. 01 equals dash. CUORF2/TFO RF2/TX 2850 x 51 x 103. 11. 02. 2QORF2Q and 2/TFO RF2X 4.54496333X. Second stage second order. Assume RF2 equals 56 cohm. 120 CPF. F0 equals 2800 x 0.69048332 1933 Hz equals 9953 PF 1 2/TX 2850x equals 2x 1.1778056. CUORF2/TX 1933x 561103. 3463 CPF. 51x 103. Underscore 1 equals underscore 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 il underscore 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 2 quo RF2x 1.1778056x2/TX 1933x56x103. 624 CPF. 202. Third stage first order. Assume RF3 equals 68 cohm. FO equals 2800 x 0.36239196 *1014 C Hz. 27 RX 1014, 68 x 103 equals 2308, PF. In this case, the RF value can be changed to approach the value of a real capacitor. If the values of C1 and C2 are increased 1.5 times, RF1 is more or less divided by 1.5. By selecting values which approach capacitor values, the filter constants finally selected are as shown in Figure 49. R 580p, R 2200p. Fig 49 designed filter, fifth order. The filter characteristics for this filter can then be plotted. The transmission characteristics for the first and second stage second order filter elements can be expressed in the following way. F JW equals underscore 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 1 underscore 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 W1W 1, underscore, 2 plus j. Wo q wo. And the transmission characteristics for the third stage first order filter element can be expressed by FCJW, I plus C, colon dot. J wo. 1. When, for example, W wo in the first stage filter. F, J wo, equals 1 equals, JQ equals, 4.54496333J. 1, 1, 2 plus JX1. 203. If the absolute input/output voltage ratio is expressed in dB. 20 log 4.545 equals 13.15 dB. That is, the level is 13.15 dB when the frequency is 2850 Hz. The plot obtained. Inserting successive values in this equation is shown as a dashed line in figure 50. And similar plots obtained for the second and third stages are shown as the dot dash and double dot dash lines. The overall characteristics are shown by the full line. According to the overall characteristics, the use of values approaching actual capacitors gives a maximum ripple of 0.6 dB and a cut-off frequency of about 2.9 kHz. 2J S C 3 L 204 20 10 0 minus 10 minus 20 minus 30 100 200 backslash I backslash backslash slash backslash slash backslash 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 dash dot j dash dash colon dash do backslash underscore t backslash 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 r backslash 500 lk2k. Frequency, Hertz. I backslash t dash backslash 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 5k 10k. Fig 50 frequency response of the designed filter, fifth order. The constants and frequency response for a third order Chebyshev filter, designed in the same manner, are shown in figures 51 and 52. The full line in figure 52 represents the overall characteristics. According to these overall characteristics, the use of values approaching actual capacitors gives a maximum ripple of 3 dB and a cut-off frequency of about 2.56 kHz. R3300p. Fig 51 design filter, third order. 10 I dash backslash slash backslash 5 backslash backslash dB 0 minus 5 minus 10 minus 15 minus 20 backslash dash backslash dash dash backslash dash colon 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 u backslash t backslash dash backslash 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 1 backslash 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 r backslash backslash 1 backslash I dot minus 25 1 backslash backslash 300 500 1k 2k 5k 7k. Fig 52 design filter frequency response, third order. 205 I Q111. How should the filter be connected where the MSM6243 voice output pin output impedance is 60 ohm, tip I a 111 and output impedance of 60 ohm is equivalent to connecting 60 ohms to A 0 ohm output impedance pin, ideal constant voltage source. If ambient temperature fluctuations and manufacturing tolerance spread are considered, this 60 ohm output impedance can vary from -50% to 100%, making filter constant settings impossible. Hence, it is recommended that a voltage follower be inserted before the filter as shown in figure 53 to vary the impedance. A voltage follower should also be used when MSM5205, MSM5218, MSM6212, MSM6258, and other devices are used. MSM6243. Fig.53 MSM6243 and filter interface. 206. 1Q121 Can the MSM5205 voice output be connected directly to an audio amplifier? IA121. Yes. But note that the amplifier input impedance and allowable input amplitude must be considered. With a preamplifier stage input impedance of about 47 ohm, the normal input amplitude is 200 mVpp. Since the MSM5205 voice output impedance is approximately 100 ohm and the output amplitude about 4 Vpp, VDD equals 5 V. When unloaded, a load has to be connected to reduce the amplitude to about 1/20. Likewise with other devices, direct connection to an audio amplifier is enabled by connecting a load to match the output impedance. See figure 54. 5205 analog output 0-470K. To preamplifier. Look. Fig 54 audio amplifier connection. 207. Note, product data and specification information herein are subject to change without advance notice for the sake of technical improvements in performance and reliability. SINCE OKI is permanently endeavoring to supply the best products possible. The manufacturer does not assume responsibility for customer product designs and for the fitness to any particular application, nor for patent RIGHTS or other RIGHTS of third parties and infringements thereof resulting from the use of his products. This publication does not commit immediate availability of the product, described by IT. If in doubt, please contact your nearest OKI representative. The information furnished by OKI is believed to be accurate and reliable. However, no responsibility is assumed for inaccuracies that may not have been detected prior to printing, and for those which occur beyond our control. This issue substitutes and supersedes all publications previously supplied by OKI for the captioned product, S. This document may not, in whole or part, be copied, photocopied, reproduced, translated, or converted to any machine readable form, without PRI or WRITN consent from OKI. OKI Semiconductor. 785 North Mary Avenue, Sunnyvale, California, 94086-2909. Tel, 408-720-1900. Fax, 408-720-1918. For further information please contact OKI. PRINTEDIN USA.